Welcome back to the DevOps Week by Simplilearn. So far, we have learned the detailed briefing of DevOps Introduction and the two major tools which are Docker and Kubernetes. As discussed earlier, today we'll be learning about DevOps testing. Continuous testing plays an important role in DevOps given its ability of seamless integration into the process of accelerated development in an agile environment. The cooperation of development, operations, and quality analysis teams form the crux of DevOps. Continuous testing enables teams to work as one cohesive unit. Today, we'll learn how exactly we carry out DevOps testing in real time. So without further ado, let's get started.
Let's look at what's in store for us. First, we'll understand Jenkins, which is an open source continuous integration tool. It helps automate continuous development, testing, and deployment of newly created codes. Followed by this, we'll learn about Selenium, which is an open source automation tool that is used for testing web applications. After that, we'll learn all about Jmeter, which is also an open source Java application used for load testing and measuring the performance of several applications. Under Jmeter, we'll first understand the installation, then we'll look at performance testing. Moving ahead, we'll also look at load testing and API testing. And finally, we'll understand Jmeter script recording. So now that you know what's in store for you, let's jump right in.
Meet Tim. Tim builds a robot in his lab, a climate-controlled and pollution-free environment. Once he's done, he drops the robot off at his project partner, Mia's house. Mia takes it out to her backyard to ensure that the robot meets the requirements. But here is where the problem arises. The change in the environment causes the robot to malfunction. Mia is now really annoyed and she has a lot to correct. And it seems to her as though Tim didn't really do much. This wall between them leaves the poor robot to bite the dust. Well, what if we broke this wall? Tim and Mia now work together in a common space. Tim develops each block of functionality of the robot, which is then immediately checked by Mia. Both are now working simultaneously instead of waiting on the other to finish their task. As and when a feature is ready for use, they are put together to build the final product. They develop a common mindset and share ideas. To further speed up the process, they use several tools which can automate every stage. This means that the robot is now ready sooner, with less iterations and manual work. From an organization perspective, Tim would be the developer, while Mia, the operations. Their union is the core of the DevOps approach. DevOps has several stages and set of tools to automate each of these stages. Let's have a look at these. Tim first puts down a plan. In terms of software, this could mean deciding on the modules and the algorithms to use. Once he has the plan, he now codes the plan. With tools such as Git, Tim has a repository for storing all the codes and their different versions. This is called version control. Next, this code is fetched and made executable. This is the build stage. Tools such as Gradle and Maven will sort this out. Now before deployment, the product is tested to catch any bugs. The most popular tool automating testing is Selenium. Once the products are tested, Mia must deploy it. The deployed product is then continuously configured to the desired state. Ansible, Puppet, and Docker are some of the most common tools used that automate these stages. Now, every product is continuously monitored in its working environment. Nagios is one such tool that automates this phase, and the feedback is fed back to the planning stage. And finally, we have the core of the DevOps Lifecycle, the integration stage. Tools such as Jenkins is responsible for sending the code for build and test. If the code passes the tests, it's further sent for deployment. This is called continuous integration. Giants such as Amazon, Netflix, Target, Etsy, and Walmart have all adopted DevOps and seen a considerable increase in delivery and quality. In 2014, an hour of downtime for Netflix would cost it $200,000. It became absolutely crucial that Netflix prepared themselves for any sort of failure. And so, they took to the DevOps approach and implemented it in the most unique way. They developed a tool called the Simian Army. This tool created failures and automatically deployed them in an environment that did not affect the users. The team would troubleshoot these failures, and this gave them enough experience to deal with any degree of collapse. With everything being automated and happening simultaneously, organizations can now deliver at a much faster pace. So, considering the benefits of DevOps and its divergence from the traditional methods, would DevOps be the future?
Hello, this is Matthew with Simplilearn, and today we're going to go through and introduce you to DevOps. We're going to go through a number of key elements today. The first two will be reviewing models that you're already probably using for delivering solutions into your company. And the most popular one is Waterfall, followed by Agile. Then we'll look at DevOps and how DevOps differs from the two models and how it also borrows and leverages the best of those models. We'll go through each of the phases that are used in typical DevOps delivery, and then the tools used within those phases to really improve the efficiencies within DevOps. Finally, we'll summarize the advantages that DevOps brings to you and your teams. So let's go through Waterfall. So Waterfall is a traditional delivery model that's been used for many decades for delivering solutions, not just IT solutions and digital solutions, but even way before that. It has its history that goes back to World War II. So Waterfall is a model that is used to capture requirements and then cascade each key deliverable through a series of different stage gates that is used for building out the solution. So let's take you through each of those stage gates. The first that you may have done is requirements analysis. And this is where you sit down with the actual client and you understand specifically what they actually do and what they're looking for in the software that you're going to build. And then from that requirements analysis, you'll build out a project plan so you have an understanding of what the level of work is needed to be able to be successful in delivering the solution. After that, you've got your plan, then you start doing the development, and that means that the programmers start coding out their solution. They build out their applications, they build out the websites, and this can take weeks or even months to actually do all the work. When you've done your coding and development, then you send it to another group that does testing, and they'll do full regression testing of your application against the systems and databases that integrate with your application. You'll test it against the actual code, you'll do manual testing, you do UI testing. And then after you've delivered the solution, you go into maintenance mode, which is just kind of making sure that the application keeps working. If there's any security risks, that you address those security risks. The problem you have, though, is that there are some challenges, however, that you have with the waterfall model. The cascading deliveries and those complete and separated stage gates means that it's very difficult for any new requirements from the client to be integrated into the project. So if a client comes back and the project has been running for 6 months and they've gone, hey, we need to change something, that means that we have to almost restart the whole project. It's very expensive and it's very time consuming. Also, if you spend weeks and months away from your client and you deliver a solution that they are only just going to see after you spend a lot of time working on it, they could be pointing out things that are in the actual final application that they don't want or are not implemented correctly or lead to just general unhappiness. The challenge you then have is if you want to add back in the client's feedback to restart the whole waterfall cycle again. So the client will come back to you with a list of changes, and then you go back and you have to start your programming, and you have to then start your testing process again, and just you're really adding in lots of additional time into the project. So using the waterfall model, companies have soon come to realize that, the clients just aren't able to get their feedback in quickly, effectively. It's very expensive to make changes once the teams have started working. And the requirement in today's digital world is that solutions simply must be delivered faster. And this has led for a specific change in Agile. And we start implementing the Agile model. So the Agile model allows programmers to create prototypes and get those prototypes to the client with the requirements faster. And the client is able to then send the requirements back to the programmer with feedback. This allows us to create what we call a feedback loop, where we're able to get information to the client and the client can get back to the development team much faster. Typically, when we're actually going through this process, we're looking at the engagement cycle being about 2 weeks. And so it's much faster than the traditional waterfall approach. And so we can look at each feedback loop as comprising of 4 key elements. We have the planning, where we actually sit down with the client and understand what they're looking for. We then have coding and testing, that is building out the code and the solution that is needed for the client. And then we review with the client the changes that have happened. But we do all this in a much tighter cycle that we call a sprint. And then typically a sprint will last for about 2 weeks. Some companies run sprints every week, some run every 4 weeks. It's up to you as a team to decide how long you want to actually run a sprint. But typically it's 2 weeks. And so every 2 weeks, the client is able to provide feedback into that loop. And so you were able to move quickly through iterations. And so if we get to the end of sprint 2 and the client says, hey, you know what? We need to make a change. You can make those changes quickly and effectively for sprint 3. What we have here is a breakdown of the ceremonies and the approach that you bring to Agile. So typically what will happen is that a product leader will build out a backlog of products, and what we call a product backlog. And this will be just a whole bunch of different features, and they may be small features or bug fixes, all the way up to large features that may actually span over multiple sprints. But when you go through the sprint planning, you want to actually break out the work that you're doing so the team has a mixture of small, medium, and large solutions that they can actually implement successfully into their sprint plan. And then once you actually start running your sprint, again, it's a 2-week activity. You meet every single day with the actual sprint team to ensure that everybody is staying on track, and if there's any blockers, that those blockers are being addressed effectively and immediately. The goal at the end of the 2 weeks is to have a deliverable product that you can put in front of the customer, and the customer can then do a review. The key advantages you have of running a sprint with Agile is that the client requirements are better understood because the client is really integrated into the Scrum team. They're there all the time. And the product is delivered much faster than with a traditional waterfall model. You're delivering features at the end of each sprint versus waiting weeks, months, or in some cases years for a waterfall project to be completed. However, there are also some distinct disadvantages. The product itself really doesn't get tested in a production environment. It's only being tested on the developer computers. And it's really hard when you're actually running Agile for the sprint team to actually build out a solution easily and effectively on their computers to mimic the production environment. And the developers and the operations team are running in separate silos. So you have your development team running their sprint and actually working to build out the features. But then when they're done at the end of their sprint and they want to do a release, they kind of fling it over the wall at the operations team. And then it's the operations team job to actually install the software and make sure that the environment is running in a stable fashion. That is really difficult to do when you have the two teams really not working together. So here we have is a breakdown of that process with the developers submitting their work to the operations team for deployment. And then the operations team may submit their work to the production servers. But what if there is an error? What if there was a setup configuration error with the developer's test environment that doesn't match the production environment? There may be a dependency that isn't there. There may be a link to an API that doesn't exist in production. And so you have these challenges that the operations team are constantly faced with. And their challenge is that they don't know how the code works. So this is where DevOps really comes in. And let's dig into how DevOps, which is developers and operators working together, is the key for successful continuous delivery. So DevOps is an evolution of the Agile model. The Agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, that Agile and DevOps are closely related delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as Maven and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments. And so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another pointer here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment. So you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site. So let's step through some of those tools that we have in the DevOps environment. So here we have is a breakdown of the DevOps tools that we have. And again, one of the things I want to point out is that these tools are open source tools. There are also many other tools. This is just really a selection of some of the more popular tools that are being used. But it's quite likely that you're already using some of these tools today. You may already be using Jenkins. You may already be using Git. But some of the other tools really help you create a fully scriptable environment so that you can actually start scripting out your entire DevOps tool set. This really helps when it comes to speeding up your delivery, because the more you can actually script out the work that you're doing, the more effective you can be at running automation against those scripts, and the more effective you can be at having a consistent experience. So let's step through this DevOps process. So we go through and we have our continuous delivery, which is our plan, code, build, and test environment. So what happens if you want to make a release? Well, the first thing you want to do is send out your files to the build environment, and you want to be able to test the code that you've been created. Because we're scripting everything in our code, from the actual unit testing being done to all the way through to the production environment, because we're testing all of that, we can very quickly identify whether or not there are any defects within the code. If there are defects, we can send that code right back to the developer with a message saying what the defect is, and the developer can then fix that with information that is real on either the code or the production environment. If, however, your code passes the scripting tests, it can then be deployed. And once it's out to deployment, you can then start monitoring that environment. What this provides you is the opportunity to speed up your delivery. So you go from the waterfall model, which is weeks, months, or even years between releases, to agile, which is 2 weeks or 4 weeks, depending on your sprint cadence, to where you are today with DevOps, where you can actually be doing multiple releases every single day. So there are some significant advantages. And there are companies out there that are really zeroing in on those advantages. If we take any one of these companies, such as Google, any given day will actually process 50 to 100 new releases on their website through their DevOps teams. In fact, they have some great videos on YouTube that you can find out on how their DevOps teams work. Netflix is also a similar environment. Now, what's interesting with Netflix is that Netflix have really fully embraced DevOps within their development team. And so they have a DevOps team, and Netflix is a completely digital company. So they have software on phones, on smart TVs, on computers, and on websites. Interestingly, though, the DevOps team for Netflix is only 70 people. And when you consider that a third of all internet traffic on any given day is from Netflix, it's really a reflection on how effective DevOps can be when you can actually manage that entire business with just 70 people. So there are some key advantages that DevOps has. It's the actual time to create and deliver software is dramatically reduced, particularly compared to waterfall. Complexity of maintenance is also reduced because you're automating and scripting out your entire environment. You're improving the communication between all your teams. So teams don't feel like they're in separate silos, but that are actually working cohesively together. And that there is continuous integration and continuous delivery so that your consumer, your customer, is constantly being delighted.
Welcome everyone to this topic on continuous integration, delivery and deployment. So this topic by Simplilearn is going to explain you that what exactly is all about the continuous integration process, continuous deployment and continuous delivery. So let's talk about these concepts one by one. So continuous integration is a kind of a process which comes up in the first part, right? So first the continuous integrations comes into the picture, then the continuous delivery and the deployment comes into the part. So the main important component or the main task which we primarily perform in the continuous integration is all about the build automations, test executions and merging in various branches. So it's nothing but the integration of the source code from the each and individual developers' machines to a shared location, which we often call it as a kind of a version control system. So continuous integration is integrating the source code into the shared repositories, and then depending on the order triggers, once the changes are checked into the version control system, the automated build, test cases, all these executions can really happen. Now in the build process and the test cases automation, it's going to validate that how the source code is really working, how the compilation is going on, how the test cases are getting executed. So all these things are getting validated during the execution of these things. Now once the continuous integration is successful, we cannot give 100% surety that the code base is working fine, because it's just taking care of the compilation and the test cases. There could be a possibility that some kind of errors may also come up into the production environment because those test cases or those scenarios are not being covered in the test cases. So test cases are very important aspect over here because it's giving us the authority whether we need to proceed further or we need to halt there itself. So after the continuous integration, the next process which comes into the picture is the automatic release to the repository over here, right? So it's just a kind of a mechanism where we will be releasing the source code to the artifacts. We are uploading the artifacts to the particular component. So that kind of automation is available. But that is also happening when we are saying that yes, the test cases execution is successful and we have to proceed further. And at the end, it's nothing but the automated deployment to the production environment, which we call it as a kind of continuous deployment over here. So these are the overall process which we are looking forward, so that we will be able to have an end-to-end automations going on over here with the help of CI/CD automations. Now continuous integrations, again, the build, test, merge. These are the different options which we do. So continuous integration is a kind of a process, a kind of a development process which is being used by most of the development teams nowadays, that eventually enables the developers to merge their source code, whatever the changes or whatever the modifications they are doing. They can like merge their source code from their local systems to the centralized repository, so that after that, with the help of CI tools, we can actually have the build automations and the test cases automation there. So this is the reason why we prefer the continuous integration process, because it depends on the basis of our modifications that how the whole build and test cases automations can really happen here. Now, continuous integration is considered as a very important process because of the various reasons. Let's talk about those reasons one by one. The very first one is that it avoids the merge conflicts, because if we frequently sync back our source code from our systems to the shared repository, and the same thing can be done by other developers also, so eventually it definitely helps the different developers to collaborate their source code into a single shared repository, and that can really help you to avoid the merge conflict situations, because you are always going to work on the latest source code. So the scope of merge conflicts is not going to be there. It also helps us to decrease the need of the code review, because we are just doing the collaboration frequently, so we don't require any person to be sitting there and have to perform a kind of a heavy duty code review, because that is something which we can easily manage and we can work with that. So code review is something which we can easily decrease with the help of this continuous integration process. It also speeds up the development process. Yes, definitely, because the developers can easily collaborate with each other. So from collaboration perspective also, it's beneficial for us to do, and that can really help us to see that how easily we can integrate our source code, and that differs, or that basically helps us to go for the overall mechanism and going for a perfect automation process over here. So it also increases the overall development process which needs to be implemented during the CI process. Next, it also reduces the product backlog, because we are doing our changes frequently into the repositories. So any kind of product backlog which is there, which is pending from long, that is also can be managed easily, because it's keep on reduced there. So we keep on implementing our changes, we keep on implementing merging our particular changes to the shared repository, so that reduces the amount of backlog which is available. Now, next thing is the continuous delivery, which is an automatic release to the repositories here. So what exactly is in continuous delivery all about? So continuous delivery is a kind of a practice that refers to the particular building, testing, delivering improvements to the software code. So the important part of continuous delivery is that the code is always in the deployable state. So we are saying that we are done with the delivery, we are ready with the delivery, and whichever environment, whichever particular server you want us to deploy, we are ready to do that. So that is where we call it as a continuous delivery. So we have our artifacts ready, and whenever is desired, whenever we feel that we want to do the deployments, we want to proceed further, we will be able to do that with the help of this process. So it's in kind of an end-to-end process. You do the builds, you do the test cases executions. Once the test case execution is done, once the testing is done, then you create an artifacts, you create a particular var files, jar files, er files, whatever the artifacts we have, we prepare that artifacts, and then we deliver it to a specific environment. We say that yes, let's go with the delivery, let's make it into a particular state where we will be able to deploy to pretty much any environment which we feel as such over here. So that's the real beauty about the continuous delivery, where we can actually deliver it to whatever environment we feel we want to deliver. Now, continuous delivery is also something which is a very important concept for most of the organizations. So each and every organizations are actually looking forward to invest in this one for a variety of reasons, because it's something where we can invest some of our particular efforts, budget, money, a lot of things are there, but the kind of benefits which we get in the return, that's what we are going to talk about over here as such. So let's go with that. So it provides the higher quality of products. Yes, the efforts are there. Yes, the investment is also there. But in the return, the very important concept or very important thing which we get is the high quality of products here. So the kind of quality which we are getting with this one is quite high. And that's the biggest benefit which we get when we talk about any kind of continuous integration, continuous delivery, or continuous deployment here. So the quality is always top notch when we work off these particular processes. It also helps us to go for a quicker and less risky releases. So that's another benefit which we get this process. Customers are also satisfied because they feel that yes, we are going with this particular automated process. Within few days we are getting the deliveries. We don't have to wait for months for getting our deliveries. So that's the biggest benefit which a customer usually gets when he talks about the continuous delivery. And it's more efficiency is there, and the cost effectiveness of the team also. So from the cost and from the particular efficiency, all those parameters are fully fulfilled when we talk about the continuous delivery. So this process delivers a lot of benefits which can eventually help us to go for a perfect high quality product which we can develop as such over here. Now the next thing is the continuous deployment, which is an automatic deployment to the production environment. So let's see that what exactly is in continuous deployment all about here. So continuous deployment refers to the final stage in the pipeline. So which means that we are not only preparing our artifacts, we are not only doing the particular compilations or test case executions, we are actually going one step ahead. And this one step ahead is nothing but the deployment to the production environment. So this is what we are typically doing when we talk about the continuous deployment over here, that we are going to one step ahead, and that's where we are going for the deployment of our particular artifact. So we are deploying to the production environment so that our changes, whatever the changes we are trying to do, we are trying to make, that should be deployed to the production environment. Right now, so continuous deployment again can be deployed to higher whatever the organizations want to feel or want to deploy. They can actually go with that, and there are a lot of benefits actually which we get when we talk about the continuous deployment. So let's see about all these particular deployments one by one. So first of all, the faster development of the products is there. So we are looking forward that when we are going for the automations, when we are going for this deployment, so we get a kind of a faster development process which is there. So the products are getting developed very quickly, very fast. That's the biggest benefit which you are getting when we talk about this continuous deployment here. And it's less risky releases also there, and it's easy to fix problems. Whatever the automations we are feeling we are trying to perform, that can definitely help us to go that how we can automate and how we can go for these particular releases over here. So these releases are very less risky because we are doing all the things automated. There is not much of a scope which is there for the manual errors. So usually manual errors is something which is the biggest problem, or which is the biggest risk when we go for any release, but that is something which is totally removed with this automation here. Now it also helps in continuous improvement in the quality. So continuously improvement quality is also getting improved as such here. Now let's talk about that why exactly, as in we talk about at the industry level, in the market level also, that the CI/CD is one of the best practices. Now what is the reason behind that? Why those are known as the best development and DevOps practices as such? Now continuous integration and continuous delivery are the best practices as they create an effective process. The kind of integration and delivering the source code, these are the prime things which we need to take care when we talk about the development teams over here. So they want an automated process first of all, and they also want a streamlined process which can take up the things which should not fail. It should be a fail-safe process mechanism through which they can release various kind of changes to the production environment, because ultimately they are looking forward for the deployment of the changes to the production environment. So how they are going to do that? That is where the CI/CD or the continuous integration and continuous delivery helps on that part, and that's the reason why they can help the teams, the development teams, to go for an effective process implementations when we go for these implementations of these two practices. Small code changes can be easily made in the software code, so you don't require much of the efforts. If you are going for even small changes in the source code, that can also be effectively deployed to a production environment. In a simple, straightforward and easy mechanism, the changes can go from the developer machines to the production environment. That's the biggest benefit which we get, due to which we feel that yes, these two processes should be implemented into a DevOps platform. right? So CI and CD provides continuous feedback from the customers and also from the development teams, the DevOps teams. So the increase of transparency is also something which is important, which is implemented with these processes here. So the process enables faster release of the product. So we don't have to wait for months to release the source code there. Within couple of hours, within couple of days, we can actually release it to the production environment, provided we do all these steps like build, compilations, testing, development, validation. All these things will be done in that duration of time. So the failures can be easily detected faster, and you can easily find out that what is the problem with the code base, what is the problem with the changes, and we can even do the hot fixes. Now hot fixes, these kind of ad hoc changes are also can be easily deployed to the production environment within just a couple of hours there. So that was a complete summary on what exactly is CI/CD, and the prime important concept which we have got a proper understanding is that why these two processes are really important for our development process. And the only benefit which we are getting, the prime benefit which we are getting from these processes implementation is that we get a effective build process, effective test cases automation process, and an automated deployment process. And these processes, when we combine, that is something which we can use to deliver our source code, our features to the production environment and eventually to the end user. So that's how the CI/CD automations really works into a DevOps environment.
Hey guys, welcome to Jenkins pipeline tutorial by Simplilearn. My name is Chidanand, and let me quickly walk you through the topics that I plan to cover as a part of this tutorial. At a very high level, I'll be introducing you Jenkins and then get into more details of the continuous integration process. As most of you are aware, most of the softwares in recent times are developed using some or the other kind of agile practices, and continuous integration is an important or key factor in all such agile software development lifecycle. Next, I'll be looking at the software delivery pipeline from a perspective of if someone were to visualize all the steps that is required from the time someone gives out a requirement, a software requirement, it gets translated into some sort of a code, it gets tested, maybe moved into one of the testing platforms, and then migrated across or moved across or propagated across various environments, and then finally put out in production. If one were to put a value stream mapping for all these steps that is involved, each of these steps could translate into a simple job within Jenkins. I will first look at what existed in Jenkins, or rather pre-Jenkins 2.0, where we had a way of upstream downstream mapping of jobs. There were some plugins that allowed us to visualize all the jobs at one shot, starting from the first job that triggered. And then I will get into the most powerful groovy scripting that are there in Jenkins 2.0 or post Jenkins 2.0. These groovy scripting gives us much more powerful ways of defining our pipelines. There are two different ways in which you can write your scripts. One is a scripted one, the other one is declarative one. There's very subtle change or difference between each one of them, but these gives you a much more flexible and much more powerful feature to write complicated pipelines for your software delivery. Having said that, most of these topics that I'm going to discuss will be followed up with a demo, and the source code for most of these would be on our GitHub repository. Alright, now as a prerequisite, probably it may be a good idea, in case if you haven't already watched, please watch our previous video wherein I mentioned how to install Jenkins and how to put up some sample jobs on our Jenkins server. So what exactly is Jenkins? Jenkins is nothing but a powerful automation server that is written in Java, and it is a web application which can also be run on any web server. But what makes Jenkins an ideal choice for a continuous integration server? Jenkins has got wonderful plugins that allows it to connect to all kinds of tools, software development, deployment, coding, build, source code kind of tools. That is what makes Jenkins very, very powerful. From a continuous integration perspective, Jenkins can connect to various source code servers, and it has also got plugins that allows it to build, deploy, test all kinds of software artifacts. So this is what makes Jenkins an ideal choice for a continuous integration server. But mind you, for me, Jenkins is nothing but a very, very powerful automated server. At the heart of it, there's a lot of automation in it, but the powerfulness of Jenkins is more so because of the tools that it integrates with and the kind of plugins that it has got. What is continuous integration? From a software development lifecycle, assuming that the software delivery is happening in very small sprints, maybe 3 to 4 weeks is your delivery lifecycle, and there are a bunch of developers who are located in different locations who are working on the same code base, on the same branch. If the code check-ins do not happen quickly, as in every day, if at all developers stagger their code check-ins into the repository, finding problems at a later stage would be very costly for the whole project. Early detection of any such issues would be, quick to resolve and would not affect your delivery schedules. So, as a part of continuous integration, what is requested or what is demanded is that every developer checks in code pretty much, every day. As long as it doesn't break the code, he checks in code pretty much regularly. And at the end of a day, you have an automated server which kind of wakes up, pulls the latest code. So this code has got the integrations of all the code bases that has been checked in by various developers. So it pulls out the code. It builds on a completely different server. That is the CI server, which pulls this code. It builds it. It's got all the tools that is required to compile it, build it, and test it. And assuming that you got some good percentage of test case automation, you're also having most of your regression test suites automated. If at all there is a way by which in a couple of hours time, when the team is out, or rather the team is sleeping, you have verification that happens at a very crucial level. And then any breakages, even before the team arrives for the next day, if these are notified to the whole team members, saying an email going out saying that something got broken, most of the code would be pretty okay from the perspective of compilation errors or build errors. It is the functionality and the regression that the team is worried about. So if these can be automated, tested very, very quickly and very, very fast, and then any breakages are detected early during the day. Right? By the time the next day people come in, they know what is broken, and possibly they know what code check-in broke that particular thing. And they can have a quick stand-up meeting, and then they discuss what broke the code and able to fix it. So this way, any problem that could possibly arise at a later point in time, if at all they kind of move to the initial phase of the project, any detection that is early doesn't really hurt the team. So this is all continuous integration that is about, and Jenkins plays an important role in being the continuous integration server because it's got connections to anything and everything, all kinds of tools, and then it has also got various ways on which triggering the job, which is a part of its automation strategy. Now that we know what is continuous integration and where does Jenkins come into picture, let's look at the rest of the tasks of our software development lifecycle. So if at all I were to visualize the kind of steps that is involved in delivering my software, possibly the continuous integration phase would be somewhere here where multiple developers are developing on that. And then we have a little bit of a stable code that is there that can be kind of moved across because I want to go ahead with the particular build that I have, and then I want to migrate that, I want to propagate that across various environments. So if you consider the standard software delivery approach, in the first cycle, you just do some minimal testing. And then you kind of move that to one of the environments, and from there you kick off more and more tests. They could be integration test, they could be acceptance test, they could be functionality check, they could be a stress test, they could be a load test, there could be a system integration test, all kinds of tests that you can think about, and all the way maybe propagating the build across various environments. If all this can be considered as various steps, the workflow is such that as and when the build moves across various phases, if there's any failure, of course, the build propagation kind of stops. Everyone gets notified. But if at all everything goes well, so your workflow is progressing well, and at the end of the workflow, you eventually have a code which is pretty much good to release. Now, mind you, I make an assumption here that most of your test cases are automated and you have a good percentage of coverage of your test cases. But if that is not the scenario, then possibly there are some automated tests or checks that may be required in between. But if the workflow can kind of accommodate all that as well, you can visualize this as the steps that is required for your software development or a software delivery lifecycle. Now in Jenkins, the way this kind of translates is that each of these tasks can be put out as a job. So now let me quickly let you know, or let me quickly demo what existed in pre-Jenkins 2.0, where I could put up a couple of jobs and I can connect them using the upstream downstream linking mechanism. So if this job 1, if at all it is a build and unit test cases, if at all that passes successfully, job 2 gets triggered. If the job 2 is more about running some more automated tests or possibly deploying it to environment and then kicking off some more test cases, that would be job 2. But if the deployment fails or if some of the other test cases fail, it would not propagate to the third job. Alright, so let me quickly bring up my Jenkins instance and put up some sample jobs and tell you how to connect that, or rather how would one connect that using Jenkins 2.0 or pre-Jenkins 2.0 release. I have now brought up my Jenkins instance, and in case some of you don't know how to install Jenkins or you don't know how to bring up your Jenkins instance, I would strongly recommend that you watch our previous videos on Simplilearn YouTube channel, where I've detailed out the steps that is required for you to install Jenkins and bring it up. So alright, so I've brought up my Jenkins instance. Let me put up few of those jobs now. Mind you, I'm going to cover the pre-Jenkins 2.0 feature here. Alright, so let me put up my first job. Alright, I hope I don't have that job. I say it's a freestyle project. I don't want to change anything. I'm going to put up a very simple job here. It's in batch command. I say echo first job triggered at. Alright, that's my first job. Now let me put up my second job. It's a freestyle project. Alright, that's my second job. Alright, that's my third job. I've got a very simple echo statements in this. So it just prints out the system date and the time in it. Alright, so I could run these jobs individually if I want. So let me just check running my third job. So this is what I get in the console output. Third job triggered at date and time. Oops. Let me fix that. Right, that should fix it. Let me check my second job. Alright, that's my second job. Alright, so I've got 3 jobs. Now, if I were to link them together, or if at all I want a scenario where after the first job is successfully run, I would like to trigger my second job. So I would do a small configuration change in here. I would say after this first job is run, I want to trigger the second job. So I have something called as a post build action. So I can say that trigger some other jobs from here. So if you see this, publish, record, deploy, alright, trigger. Let me check the other one. Build other projects. This is what I would want to do. So after the first job is done, I want to trigger my second job. Alright, I would say save this. Now let me go back to my second job and then trigger the third job after the second job is done. Alright, I will add this post build other projects, third job. Again, I'm not really sure if you guys noticed this. There is various configurations as to when exactly do you want to trigger the other job. And the default one is trigger only if the build is stable. So typically this is the configuration that we would need. We definitely don't want the third job to be triggered in case the second job fails. Alright, so this is the combination that I want, or this is the choice that I want, and I save this. Now I have 3 of my jobs. If you see this, the second job, the upstream job is the first job. So let me check this kind of a pipeline. What I've set here is a very simple pipeline. So after my first job gets triggered, if I build this guy, right, the second job gets triggered after the first job is built. So if I click on the second job, all right, so the first job was triggered the second job, and after the second job it is triggering the third job. So this is how first job, second job, and third job were kind of linked. But it's pretty hard to visualize this as to, if I need to see one holistic picture where after the first job, after the second job, after the third job, what was the flow? It's not possible for me to visualize that. That's wherein I install a plugin. So let me go to manage plugins right here. I think I already have it installed. For those of you who don't have it installed, you can go to the available button, available tab, and click on that. The plugin is called Delivery pipeline plugin. I already have it installed. In case you don't have it installed, you just go to the available, you click on this and say install without restart. This is the plugin that I want you to install. Alright, so now we have that plugin installed. So what I want to do is after the plugin is installed, you see something like this. So this is where I would create a new visualization for the pipeline that I've created. So I would say my first pipeline, or I give a name for my visualization. I would say, yes, this upstream, downstream dependencies, this is exactly what I want. And there are a bunch of settings here. I'll not look at any of that now. What I want is, I just want to tell this view that, I can give a name for this. I would give it as Simplilearn pipeline. And what's important is that I specify what is the first job that should be picked up as a part of this pipeline. And the final job is optional because it knows that if the first job is triggering this other jobs, it knows where to end this whole life cycle. So I define a pipeline, I give a name for my component and I initialize that as I give it the first job. So I say, okay, and there you go. This is much better. This gives you a beautiful visualization as to what happened after the first job, second job was run, second job. If I click on any of these, that will in fact take me to that job. Alright, there is also one other option, which is pretty good option in my opinion, which is about edit view. Yes, this is where it is. Enable start of a new pipeline build. Let me apply and let me click OK on this. What it gives me is a way in which I can trigger my whole pipeline from here. So if I click on this, there you see the first job getting triggered, the second job is still running. The green means it's all run properly and nicely. The second one is triggered now. The third one, it's still running. Alright, so this is the pipeline that existed prior to Jenkins 2.0. This is pretty decent enough, and if you see, there's a one-to-one mapping. But if at all you remember, we could go and add multiple dependencies for the projects that I set in. Just to give an example, let's say if I go to my first job, I can do a configuration here and nothing stops me from triggering multiple jobs after this by giving me a comma. I can trigger multiple jobs here in case if I have to run few things parallelly. This also gives me that option to do that. But having said that, this was the most primitive way in which the jobs were kind of visualized and run prior to Jenkins 2.0. Now, this feature became such an important feature. The users wanted more and more complicated because the pipelines was not a lot complicated. It was not just one job after the other. There were multiple jobs that has to be run. And there is also an introduction of the Jenkins agents where multiple tasks could be parallelly run on different agents. So they wanted to club all of that and the pipeline could have all the such complicated stuff. That's where in post Jenkins 2.0 or in Jenkins 2.0, Jenkins released a version which has got the feature of pipeline which can be written in Groovy scripts. Now Groovy is wonderful scripting language. It's very, very powerful. Anybody can visualize your pipeline or write your pipeline using programming language. And the point of everything as code where this whole Groovy script gets into your source code repository. So instead of putting jobs here and in case my Jenkins kind of fails, there's a crash on my Jenkins, I don't get back these jobs. How do I bring back all these jobs back? So everything as code, that's the DevOps principle. So the pipelines will be written as scripts. That is what I'm going to do in my next exercise. In my previous example, I showed you the crude way, in my opinion, of putting up a Jenkins pipeline. But this is what existed prior to Jenkins 2.0. And now I have post Jenkins 2.0 in terms of my version, Jenkins version is 2.107. So this supports something called as a scripted pipeline, wherein you can write your pipeline in terms of Groovy scripts. No need to put up any jobs here and remember how exactly you put up these individual jobs. You can write a pipeline script in terms of Groovy language. Let me quickly show you a very, very simple and elementary pipeline that I have. This is what a Groovy script would look like. Pipeline, any agent can run this. Stages, there are individual stages that is defined as a subset of these stages. So the first stage is the compile stage, and stage has got some steps in it. You can have multiple steps in it, and once only after all these steps successfully complete, that's wherein the stage gets through perfectly with a pass. So there's a compile stage, there's a JUnit stage, there's a quality gate stage, there's a deploy stage, and I'm really not doing anything much within this other than echoing some text within each of these stages. And what's interesting is at the end there's something called as a post, which is similar to, or you can kind of equate that to what would be there in a try catch kind of a block. Supposed, always, meaning this would run all the time. Success, only if at all the steps that were above in terms of the stages, they were completed successfully without any failures. So typically you would have your email that is going out here saying that the build is successful and stuff like that. Failure, if something went bad. If any of the steps resulted in a failure, this particular block will get executed. Unstable, whenever any build is marked unstable. If at all, only few things that failed within your test run and you would want to mark the build as unstable are changed. This is an interesting option. So this compares the present run with the previous run, and if there's any change, meaning if the previous run was a failure and the present run is a success or vice versa, this would get triggered. So this is what a simple pipeline script would look like. So let me copy this pipeline and let me put up a simple job for running this pipeline. So let me open up my Jenkins, say a new, I would say scripted pipeline. Yeah, this is what I want. I don't want to choose a freestyle project. This is going to be a pipeline project. So I would say pipeline and say okay. All right, this has got far less options than the other jobs that we put up. So general, I don't want anything here. I don't want any build trigger. Right. So this is where I can paste in whatever I had copied. There's also something called as a pipeline syntax or a syntax generator. This is like a lookup where you can choose what you want to do and choose the option that is specific to those steps, and you will get a pipeline generated or a script generated for you. Jenkins knows that you're not very good at understanding these pipelines. So this gives you this sandbox kind of an environment where you can check out whatever you want to do as a part of your pipeline and then get the equivalent groovy script from here. Let me look at this in a bit later. So for now, I have my pipeline syntax already copied. So what I'm going to do is I'm going to paste what I copied. All right, so this looks good. Okay, I'm not connecting to any GitHub repository of any of that. I'm just running a very simple pipeline which has got some steps in it, and it just compiles, or rather it just puts out some messages saying that this stage completed successfully and stuff like that. So let me save this and let me try to run this scripted pipeline. All right, if you see this, you would see each of those steps going through, and if at all I look at the console output, compile successfully, unit passed, all the stages passed, there was a pass, the failures doesn't show up. You would see the messages from our post or the try catch block that I was mentioning earlier. So this is how one would put up a pipeline, and you also get to see the visualized view of your pipeline that says which stage run after which phase, how much time did it take, and you can click on any of these and get into looking at the logs from that particular pipeline run. That was pretty easy, wasn't it? Now let me give you another scenario for a pipeline wherein the source code of my pipeline would be in a GitHub repository, and I will write scripts to grab this particular code and run some part of the code which is there as a part of the repository. So let me look at the repository that I have. I have a repository out here on the Simplilearn GitHub account, which is called the pipeline script. And if you see in there, there are a bunch of batch files that are there. So the first batch file would be a build.batch. So there's nothing in it except that it is just trying to build a particular project. You can visualize this as individual batch files, which actually contain the scripts for building, running, deploying, and checking the quality gate of your particular project. So I have a couple of batch files that is here, and this is on the GitHub repository. So I would need to write Jenkins job, which will log into my GitHub account and then check out this particular repository from my account and then run these batch files as a part of those individual steps within the scripted pipeline. So let me check as to how I could do that. Let me put up a new project for this. Let me call this scripted pipeline from GitHub. All right, so let this be a pipeline project. That's good enough for me. Let me see my scripts. All right, now this is where I need to put in the scripts for pulling out the code repository from my GitHub server and running those batch files that are there as a part of the repository. So what I want to do is I already have the skeleton of my pipeline that is written, which is very similar to whatever was the pipeline syntax that I showed you in the previous step. So I just copy this out here and then paste it here. So what I have here is I've written on the high level skeleton without really putting in the actual steps required for checking out rather running those build scripts. So I've got 4 steps. One is the git checkout step, the build step, unit test, quality gate, and possibly the deploy. Alright, so I need to put in the actual scripts that is required for first checking out the repository from my GitHub server. So this is where I will make use of this pipeline syntax. So as I mentioned earlier, you have a bunch of help that is available for you to figure out the actual scripts that is required for you to write within your pipeline. So what I wanted to do is check out something from Git. So it's Git related. So search on Git and you'll find this option. So I got to specify my Git repository URL and my credentials. So let me look at the repository URL. This would be my repository URL. So let me copy this. I'm going to copy the HTTPS URL of my repository, and branch is good. And one thing that you got to notice is for now the repository is anyway a public repository on GitHub. So even though if I don't specify any credentials, that would work for me still. But in case you have a repository which needs strictly a username and password to be specified, you can kind of add it out here using add Jenkins, and you can give your username and password out here. But for now I don't need any of these things. So I'm going to just say git checkout, or rather the URL of my repository, and what we want is the master branch. For now I have only one branch on my GitHub server, so this is good for me. So this is what exactly I want to do as a part of the script. So if I click this is the script that I need to put in my build script. So I come over here and this is what will check out the code from my repository. Alright, so now once I get my code onto my repository, from my repository rather, it will grab those code, all these batch files, and get it onto my Jenkins workspace. Now I'll have to run these batch files as a part of each of my steps. So let me look at what would be the syntax. So the first one that I want to run would be my build.bat. Alright, so I want to run a batch file. Alright, and what is the name of the batch file that I want to run? I want to run this build.bat. So generate pipeline script. This is all that I got to specify as a part of my build step. And then unit test, I've got to just change this to unit. I think that's what I have in my repository. Okay, that is unit. And then deploy and quality. Q capital quality, and this one would be deploy. Alright, so this piece of code will actually get into my repository and check out my source code and grab it and take it to the Jenkins workspace. So from this workspace, since all the files are there in the root directory of this workspace, it will run these batch files one after the other. Alright, let me save this and let me try to run my pipeline. Alright, so it runs a lot of things in the background trying to get the source code from my repository. Whoa, that was fast. Alright, so it pulled out all the source code from my repository. The last commit message from where the source code was pulled out was this create deploy.bat. That looks good. I'm saying building checked out project, building the checked out project. This is what I had in my build.bat if I'm not mistaken. Okay, building the project, that's what is there with the timestamp, running unit test cases, unit.bat, it is running the unit.bat, and then giving me the date and timestamp. Okay, so all these kind of passed, and if I go back to the project, I will also see this beautiful view of how exactly, what is the time that was taken for checking out the repository, running the build.bat, running the unit test cases, quality gates, and all this. Isn't that pretty simple? Now let me modify my previous job, or rather let me put up a new job for making use of an agent wherein I could delegate a job to an agent. Typically, agents can be brought up on any other remote machines other than where your primary Jenkins server is running. In case you don't know or you don't know how to start up these agents, I would strongly recommend that you refer to our previous Jenkins video on the Simplilearn YouTube channel. Alright, so let me just check the status of my agent for now. Yes, he's offline. So let me start this agent because agent is not running. So I have the agent set up in my Selenium agents. So let me copy the script file that is required for starting my agent. Let me go to the agents folder, open up a command prompt, and let me try to bring up my agent. Alright, so the agent is up and running. For now, I don't have the luxury of starting my agent on a different machine. So my agent is running on the same machine, but the agent's workspace is Selenium agent, while my primary Jenkins server is running, has the workspace out here, C:\program files 86, and this is the workspace of my Jenkins. Alright, I hope you can kind of differentiate those two. Alright, so now what I want is I will look at the same job that I put in earlier, or rather modify that. Let the steps be the same, but I don't want to run that on my master server. Let me try to delegate that using the script. So let me put up an agent scripted job. Alright, it will be a pipeline rep job. I would say okay. And let me copy. This was a step that I had put in for my previous job. So agent any. So what I'm going to do now is I don't want this to be running on any other agent. I want this to be running on the agent whose label is, let me check what is the label of my agent that is running. Okay. So this is the name of my agent. Okay. Windows node. So let me just copy that there. Alright, so with a very subtle change, instead of saying agent any, I'm going to run, or rather I'm going to specify the agent who will be running this job is the one who has got the label as Windows Node. So this agent that I brought on my system has got the name as Windows Node, and it is configured to pick up any job that matches the label to which any job is kind of delegated. So let me come back to my jobs. Where is my scripted agent job? I've got too many jobs running. Alright, so this is my agent scripted job that I left halfway through. So here in the pipeline, what I'm going to do is this is all I'm going to need. So the job remains the same. Git checkout is going to check out from the same repository, run the batch files accordingly, but this change is just to ensure that this job is kind of delegated on the agent. Alright, so this would be my agent job. Let me save this. Let me get back to the dashboard and let me run it from here. If you see this, the master and agent are both idle as of now. Let me try to run this agent scripted job. Alright, so the agent kind of kicked in and there was a job that was delegated to the agent. If I look at what is there in the console output, he's pretty much doing whatever was there as a part of the job. But the interesting thing to note is that this is the new workspace, or rather this is delegated to the agent, and the agent's workspace is this particular folder. So this is where it's going to get all this stuff, run the whole thing, and the flow is pretty much the same. The only thing is this whole thing ran on the agent. If I need to check my agent, I would see the workspace out here, agent scripted job. If you look at this, all the batch files are here, and this is where the job was kind of delegated to run. So with a very subtle change in the scripting, I can ensure that the jobs are kind of delegated onto the agent, the pipeline job specifically. As I mentioned earlier, Jenkins provides you two different ways of writing pipelines, called the scripted and the declarative. The first one that was launched was the scripted pipeline. This is heavily based on Groovy scripting. Since Jenkins ships along with the Groovy engine, so this was the first script or the first support for pipeline that was provided by Jenkins in 2.0. This needs a little bit of a learning curve since Groovy is a wonderful script. Understanding that may be a little cumbersome. But then once you kind of master it, you can write really powerful scripts based on Groovy. At a very high level, this is what a typical scripted pipeline would look like. Something called as a node. Node represents the agent or the actual box on which your job would be running. And then a bunch of stages are put out, which each of the stage along with the steps that needs to be covered as the part of those stages listed one below the other. So all these stages, if they run peacefully, then the whole task is kind of marked as run successfully. Since understanding Groovy or learning Groovy was a little tough for many of the people, so this is a new one from Jenkins wherein it provides you a much simple and friendly syntax for writing pipelines without really needing to understand or without really needing to learn some Groovy scripting. Again, there's a very subtle change between these, and there are a lot of lookups for figuring out what is a better pipeline for you to kind of write. But if you can figure out the difference, or if you can try to find that particular piece of code which kind of helps you out with your pipeline, either of the scripts, there's not really any difference in writing or kind of delivering your pipeline using either of these two methods. All right, so declarative pipeline is something like this, where you have an agent. You can specify the agent label, or if you can say agent any, it will pick up whatever is an available agent and run the job. And then you have something called as stages. Stages is nothing but a collection of stage, and stage could have multiple steps defined within this. So if any of the steps in any of the stage fails, then that particular complete stage and the build is marked as failure. So very subtle difference between both these two syntax, but using either of these you can write powerful scripts for your pipeline. Now let me come up with an example where I'm going to at least demo one of the feature where you could run a master and a slave job in parallel. So let me come up with a demo for that particular scenario. Let me put up a new job for my parallel agent pipeline. Let me call this, and this would be a pipeline project. I don't want anything here. Let me look at the pipeline script that I have. Pipeline agent none stages, and there's a first stage where this would be a kind of non-parallel stage where there's a need for you to possibly pull out the source code from one of the repositories and possibly unit test it. If all the unit test cases pass, then possibly you want to deploy it to one of the test environments. That would be what would be there as a part of the non-parallel stage. And then you may have a bunch of tests that could be run. And assuming that you have a Windows node, you have a Linux node, you have some other kind of an operating system based node, you could run these stages in parallel. So just for demonstration, I've just put in two parallel stages. In parallel is the keyword that you're going to use for running tests parallelly. So I would say parallel stage test on Windows, and I'm going to run this in my Windows node. Well, I could run a bunch of steps that I want out here, and then in the other stage or other step, what I want is I will run something else on my master. As long as this parallel keyword is encountered, Jenkins will ensure that these two stages are run parallelly. For now, I have both these things running on my same machine, but assuming that these were running on different boxes, you could kind of visualize it as these two steps are going to be started parallelly, without really any dependency on each other. And then you could wait for the test results, and then based upon whether both of these steps passed or failed, if one of them failed, then we could kind of mark the build accordingly. So let me copy this pretty simple script. Let me put this out here, and let me save this out, and let me try to build this. All right, there you go. This stage will be executed first. This is the non-parallel stage that's going to happen. Then the task 1 on agent, task 1 on master, followed by, as I said, since I have only one node, or rather one system on with both these things are running simultaneously, you would not really see a benefit of this. But assuming that you have a couple of boxes on which you have multiple agents running, you will possibly want to run your Selenium tests on the Windows box, because Selenium brings up some of those UI which needs a browser. You could possibly need some regression tests that could run on Linux boxes or Linux agents. And then you can kind of break down your tasks into multiple things that is running on multiple systems at the same time, and then collate all the results. Okay, one final thing. All right, now I have all my particular job, or rather the steps required for my pipeline put down in terms of the scripts, and this is saved in this particular job. That's not a good or a recommended approach. So what I'll do is I'll copy all of these steps out here, and then what needs to be done is actually, let me go back to this repository. The most preferred approach is where you create something called as a Jenkinsfile, and you paste all the scripts that is required for your pipeline. Now this is in a true sense the DevOps approach, where I'm going to save this out. So if at all you have a pipeline defined for your project, the best place to kind of put out your configurations for the pipeline is within your repository. So this may be a different project that I was referring to, but assuming that you have your project where you have to define your pipeline, instead of putting that as a particular job on Jenkins and fearing that if Jenkins fails or the jobs, there's a crash and then you lose out your job configuration, the best approach is to use a Jenkins file. Put all the steps that is required, the tried tested steps that is required as a part of your Jenkins file, and then you can put out a job that can pull the source code from here as well as use the steps that is defined in the Jenkins file. So let me end up by putting up another job which is a true DevOps kind of a job. So I would say DevOps pipeline, and this is a pipeline script. And then I'm not going to say any of these things. I would say the pipeline script is from the source code management. So my pipeline script is already defined. It is present in SCM. So what is my SVN? I mean, what is my source code repository? This is my source code repository where I already have this. So let me copy this URL. This is my URL. I don't need any credentials because the repository is anyway in public repository. That is all that is required, I would say. And the scripted file, it automatically picks up Jenkinsfile. All right, so let me save this. Let me build this. So that's the beauty of DevOps, wherein I have a pipeline that is defined, and instead of putting the pipeline as a job, because pipeline is nothing but a configuration, the configuration is also checked into the source code repository, and any changes to this pipeline, instead of putting that modifications in the job, these are all captured as a part of my repository. So the changes are nicely configured so that we know who's done what change.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
DevOps today is being implemented by most of the major organizations, whether it's a financial organization, whether it's a kind of a service organization. Every organization is somehow looking forward for the implementation and the adaptation of DevOps, because it totally redefines and automate the whole development process altogether, and whatever the manual efforts we were putting earlier, that is simply or gets automated with the help of these tools here. So this is something which get really implemented because of some of the important feature like a CI/CD pipeline, because CI/CD pipeline is responsible for delivering your source code into the production environment in less duration of time. So CI/CD pipeline is ultimately the goal, which really helps us to deliver more into the production environment when we talk about from this perspective. Now let's talk about that. What exactly is a CI/CD pipeline? Now when we go into that part, when we go into that understanding, so CI/CD pipeline is basically continuous integration and continuous delivery concept, which is used or which is considered as a backbone of the overall DevOps approach. Now it's one of the prime approach which we implement when we are going for a DevOps implementation for our project. So if I have to go for a DevOps implementation, the very first and the minimum implementation and the automation which I'm looking forward is actually from the particular CI/CD pipelines here. So CI/CD pipelines is really a wonderful option when we talk about the DevOps here. So what exactly is the pipeline term all about? So pipeline is a series of events that are connected together with each other. It's kind of a sequence of the various steps, like typically when we talk about any kind of deployment, so we have like build process, like we compile the source code, we generate the artifacts, we do the testing, and then we deploy to a specific environment. All these various steps which we used to do it like manually, that is something which we can do it into a pipeline. So pipeline is nothing but a sequence of all these steps interconnected with each other, executed one by one into a particular sequence. Now the pipelines is responsible for performing a variety of tasks like building up the source code, running the test cases. Probably the deployment can also be added up when we go for the continuous integration and continuous delivery there. So all these steps are being done into a sequence, definitely, because sequence is very important when we talk about the pipeline. So you need to talk about the sequence the same way in which you are working on the development, and in a typical world, the same thing you will be putting up into a specific pipeline. So that's a very important aspect to be considered. Now let's talk about what is the continuous integration here. Now continuous integration is also known as the CI. Pretty much you can see that a lot of tools are actually named as CI, but they are referring to the continuous integration only. So continuous integration is a practice that integrates the source code into a shared repository, and it used to automate the verification of the source code. So it involves the build automations, test cases automation. So it also helps us to detect the issues and the bugs quite easily and quite faster. That's a very early mechanism which we can do as such if we want to resolve all these problems. Now continuous integrations does not eliminate the bugs, but yes, it definitely helps them easily to find out, because we are talking about the automated process cases, we are talking about the automated test cases. So definitely that is something which can help us to find out the bugs, and then the development can help on that, and they can proceed with those bugs, and they can try to resolve those things one by one. So it's not a kind of automated process which will eventually remove the bugs. Bugs is something which you have to recode and you have to fix it by following the development practice, but yes, it can really help us to find those bugs quite easy and help them to remove. Now, what is the continuous delivery here? So continuous delivery, also known as CD, is a kind of a phase in which the changes are made into the code before the deployment. Now, in this case, what happens that it's something which we are discussing, or we are validating that what exactly we want to deliver it to the customer. So what exactly we are going ahead, or we are moving to the customer. So that's what we typically do in case of continuous delivery. And the ultimate goal of the pipeline is to make the deployments. That's the end result, because coding is not the only thing. You code the programs, you do the development. After that, it's all about the deployments, like how you're going to perform the deployment. So that is a very important aspect. You want to go ahead with the deployments, that's it, you can go there. And that's a real beauty about this, because it's in kind of a way in which we can identify that how the deployments can be done or can be executed as such here. Right. So the ultimate goal for the pipeline is nothing but to do the deployments and to proceed further on that. Right. So when both these practices are placed in together in an order, so all the steps could be referred as a complete automated process, and this process is known as CI/CD. So when we are talking about, like, when we are working on this automation, so in that case, what happens that we are looking forward that how the automation needs to be done. And since it's in kind of a CI/CD automation which we are talking about, so it's nothing but the end result would be like build and deployment automation. So you will be taking care of both the build and the test case executions and the deployments as such when we talk about as such the CI/CD here. The implementation of CI/CD also enables the team to do the build and deploys quite quickly and efficiently, because these are things which is happening automatically, so there is no manual efforts involved, and there is no scope of human error also. So we have frequently seen that while doing the deployments, we may miss some binaries or some miss can be there. So that is something which is completely removed as such when we talk about this. The process makes the teams more agile, productive, and the confident here, because the automations definitely gives a kind of a boost to the confidence that yes, things are going to work perfectly fine and there is no issues as such present. Now, why exactly Jenkins? Like, Jenkins is what we typically understand, or we here and there, that it's a CI tool, it's a CD tool. So what exactly is Jenkins all about? So Jenkins is also known as a kind of orchestration tool. It's an automated tool which is there, and the best part is that it's completely open source. Yes, there are some particular paid or the enterprise tools are there, like CloudBees and all, but there is no as such offering difference between the CloudBees and the Jenkins here. So Jenkins is a kind of open source tool which a lot of organizations pretty much implement as it is itself. So even if they don't want to go, we have seen in a lot of big organizations where they are not going for the enterprise tool like CloudBees and all, and they are going for the pretty much core Jenkins software as such here. So this tool makes it easy for the developers to integrate the changes to the project. That is something which is very important, because it can really help the teams to say that how the things can be done and how it can be performed over there. So the tools is very easy for the developers to integrate, and that's the biggest benefit which we are getting when we talk about these tools as such. So Jenkins is a very important tool to be considered when we talk about all these automations. Now, Jenkins achieves continuous integration with the help of plugins. That is also a kind of another feature or benefit which we get, because there are so many plugins which is available there as such, which is being used. And for example, you want to have an integration with Kubernetes, Docker and all. Maybe by default those plugins are not installed, but yes, you have the provisioning that you can go for the installation of those plugins, and yes, those features will start embedded up and integrated within your Jenkins. So this is the reason, this is the main benefit which we get when we talk about the Jenkins implementation. So Jenkins is one of the best fit which is there for building a CI/CD pipeline, because of its flexibility, open source nature, plugin capabilities, the support for plugins, and it's quite easy to use, and it's very simple, straightforward GUI which is there, which can definitely helps us. You can easily understand and go through the Jenkins, and you can grab the understanding, and as an end result you will be able to have a very robust tool using which pretty much any kind of source code or any kind of programming language you can implement CI/CD. Whether it's an Android, it's a .NET, it's a Java, it's a Node.js, all the languages are having the support for the Jenkins. So let's talk about the CI/CD pipeline with the Jenkins here. Now, to automate the entire development process, a CI/CD pipeline is the ultimate solution which we are looking forward. To build such a pipeline, Jenkins is our best solution and best fit, which is available here. So there are pretty much 6 steps which is involved when we look forward for any kind of pipeline. It's a generic pipeline which we are looking forward. Now it may have like another steps which is available there, probably some additional steps you're doing, like some other plugins you are installing, but these are the basic steps which is there, like a minimum pipeline if you want to design. These are the steps which is available there. Now let's see. The first one is that we have to require a Java JDK, like a JDK to be available on the system. Now most of the operating systems are already available with a GRE, like a Java GRE. But the problem with the GRE is that it's only for the build process. It will not be doing the compilation. You can run the artifacts, you can run the jar files, you can run the application, run the code base, but the compilation requires the Java C or the Java JDK kit to be installed onto the system. And that's the reason why for this one we also require the JDK. And certain Linux commands execution understanding we need to have, because we are going to run some kind of steps, some installation steps and process. So that's pretty much required. Now let's talk about how to CI/CD pipeline with Jenkins. Now first of all, you have to download the JDK, and that is something which is installed. So after that you can go for the Jenkins download. Now jenkins.io/download is the official websites of Jenkins. Now the best part is that there you have the support for different operating systems and platforms. From there you can easily say that if you want to go for a Java package like a WAR file, Docker, Ubuntu, Debian, CentOS, Fedora, Red Hat, Windows, OpenSUSE, FreeBSD, Ganto, Mac operating system. In fact, whatever the different kind of artifacts or different environment or different application you want to download, you will be able to do that. So that's the very first thing to start upon. You download the generic Java package like a WAR file. Then you have to execute it. You have to download that into a specific folder structure. Let's say that you have created a folder called Jenkins. Now you have to go into that Jenkins folder with the help of cd command, and there you have to run the command called java-jar and the jenkins.var there. So these are the executables artifacts. So WAR files can be easily executable. Jar files, WAR files can be easily deployed. So just because with the Java command you can run them, you don't require any kind of web container or application container as such. So here also you can see that we are running the Java command and it runs the applications as such. And once that is done, so you can open the web browser, and you can open like localhost colon 880. So Jenkins uses the 880 port just like a Tomcat Apache. So if once the deployment is done, installation is done, so you can just open the localhost colon 880. Now if you want to get the Jenkins up and running in the browser, probably you can go through the public IP address also there. So you can put the public IP address colon 880, and that can also help you to start accessing the Jenkins application. Now in there you will be having an option called create new jobs, so you need to click on that. Now once the particular new job, new item, new job, that's a different naming conventions which is available there. Now all you are going to do is that you're going to do like you are proceeding with creating the pipeline job. So you will be having an option called pipeline job over there. Just select that and provide your custom name, what pipeline name or job name you want to refer or you want to process there. Now once that is available, so what happens that it will be an easy task for us to see that how exactly we can go ahead and we can perform on that part. So this can really help us to see that how a pipeline job can be created and performed on these modifications as such. Now when the pipeline is selected, and we can give a particular name, that is, this is the name which is available, and then we can say okay as such over there. Now you can scroll down and find the pipeline section. So there what happens that when you go over there and say that okay, this is the way that how the pipelines are managed and those kind of things. So you will scroll down and find the pipeline section and go with that pipeline script. Now when you select that option, there are different options which is available, like how you want to manage these pipelines. Now you have the direct access also, like if you want to directly create a pipeline script, you can do that. If you feel that you want to manage, like you want to retrieve the Jenkins files, also a code management tool also can be used there, so you can work on that also. So like this, there are so many a variety of things which is available, like which you can use to work around that how exactly the pipeline job can be created. So either you can fetch it from the source code management tool, like Git version or something like that, or you can directly put the pipeline code as such over there, right? Now, so next thing is that we can configure and execute a pipeline job with a direct script. So we can, once the pipeline is selected, so you can put the particular script like Jenkinsfile into your particular GitHub link. So you may be having like already a GitHub link, so that where the Jenkins file is there, so you can make use of that. Now once you process the GitHub link, so what we can do is that we can proceed with that, and once the processing is done, so you can do the save, and you can keep the changes, and it will be picking up the pipelines. The pipeline script is added up into the GitHub, and you have already specified that let's just go ahead with this Jenkins file pipeline script from the GitHub repository and proceed further. Now once that is done, so what next you can do is that you can go with the build now process. You click on the build now, and once that is done, so what will happen that you will be able to see that how the build process will be done and how the build will be performed over there. So these are pretty much a kind of a way. So you can click on the console output, you will get all the logs that is happening inside that. Whatever the pipeline steps are getting executed, all of them you will be able to get, or you will be able to get on that part there. So these are the different steps which is involved as such. And the sixth one is that yes, whatever the particular when you run the build now, you will be able to see that source code will be will be checked out and will be downloaded before the build, and you can proceed with that part. Now later on, if you want to change the URL of this GitHub, you can configure the job again, the existing job, and you can change that URL, GitHub link URL, whenever you require. You can also clone this job whenever you go ahead and you work on that, and that's also kind of the best part which is available as such, right? And then you can have the advanced settings over there. So in there you can put like your GitHub repository. You can say like, okay, the GitHub repository is there, so I'm just going to put this URL, and with that, what will happen that the settings will be available there, and the Jenkins file will be downloaded as such. And when you run the build now, you will be able to have a lot of steps, like a lot of configurations going on. So then the checkout SCM, so we can have a declaration like checkout SCM which is there. So when the checkout SCM is there, so it will check out a specific source code. After that, you go to the log, and you will be able to see that each and every stage which is being built up and executed as such. Okay, so now we are going to talk about a demo here. So on the pipeline here, so this is a Jenkins portal. Now you can see here that there is an option called create a job. You can either click on the new item, or you can click on the new job, create a job here. Now here I'm going to say like a pipeline, and then you can select the pipeline job type here. Now you have the freestyle pipeline, GitHub organization, multi-branch pipeline. These are the different options which is available there, but I'm going to continue with the pipeline here as such. So when I selected the pipeline and say okay, so what will happen that I will be able to see a configuration page which is related to the pipeline. Now here the very important part is that you have all the general build trigger options which is similar to the freestyle, but the build step and the post build step is completely removed because of the pipeline introduction. Now here you either have the option to put the pipeline script all together. You can also have some particular example. For example, let's talk about some GitHub Maven particular tool here. So you can see that we have got some steps as such over here, and it's pretty much running over there. Now you run it, it will work smoothly, it will check out some source code. But how we are going to integrate like the Jenkins file into the version control system, because that's the ideal approach we should be following when we create a pipeline of a CI/CD. Now I'm going to select a particular pipeline from SCM here, then go with the Git here. Now in there, the Jenkins file is the name of the file of the pipeline script, and I'm going to put my repository over here in this one. Now this repository is of my Git, which is like having a Maven build pipeline which is available there. It's having some steps related to CI for the build and deployments, and that's what we can follow as such over here. Now in this one, if it is a private repository, definitely you can add on your credentials, but this is a public repository, a personal repository, so I don't have to put any kind of credentials. But you can always add the credentials with the help of add here, and that can help you to set up whatever the credentials, the private repositories you want to configure. Now once you save the configuration here, now what it's going to do is that it's going to give you a particular page related to build now, if you want to run, if you want to delete the pipeline, if you want to reconfigure the pipeline, all these different options are available there. So we are going to click on the build now here, and when I do that, immediately the pipeline will be downloaded and will be processed. Now you may not be able to get the complete stage view as of now because it's still running. So yeah, you can see that the checkout code is done, then it's going on to the build. Okay, that's one of the steps which is there. Now once the build will be done, so it will continue with the next steps, with the next further steps there. So you can also go to the console output log here, like you can click on this, or you can click on the console output to check the complete log which is happening there. Or in fact, you can also see the stage wise logs also, because that is also very important. When you go for the complete logs, it may have a lot of steps involved, and a lot of logs will be available there. But if you want to see a specific log of a specific stage, that's where this comes into the picture. And as you can see that all the different steps like test cases executions, the sonar cube analysis, the archive artifacts, deployment, and in fact the notification, so all this is a part of a complete pipeline. This whole pipeline is done here, and you get a kind of a stage view, its success over here, and the artifacts is also available to download. So you can download this WAR file is a web applications as such over here. So this is what a typical pipeline looks like, that how the automation, the complete automations really looks like as such over here. Now this is a very important aspect because it really helps us to understand that how the pipelines can be configured, can be done, and pretty much with the same steps you will be able to automate any kind of pipelines as such. So that was the demo to build a simple pipeline as such with the Jenkins, and pretty much in this one we understood that how exactly the CI/CD pipelines can be configured, and we can use them, and we can get hold on that part.
Hello and welcome to continuous integration tutorial using Jenkins. My name is Chidanand and I am with the Simplilearn team. Today let's get started with Jenkins. Jenkins, in my opinion, is one of the most popular continuous integration servers of recent times. What began as a hobby project by a developer working for Sun Microsystems way back in early or mid 2000s has gradually and eventually evolved into very, very powerful and robust automation servers. It has a wide adoption since it is released under MIT license and is almost free to use. Jenkins has a vast developer community that supports it by writing all kinds of plugins. Plugins is the heart and soul of Jenkins, because using plugins, one can connect Jenkins to anything and everything under the sun. With that introduction, let's get into what all will be covered as a part of this tutorial. I will get into some of the prerequisites required for installing Jenkins, post which I will go ahead and install Jenkins on a Windows box. There are a few first-time configurations that needs to be done, and I will be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part. I'll create few users, and I will use some plugins for setting up various kinds of access permissions for these users. I will also put in some freestyle jobs. Freestyle job is nothing but a very, very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon a time schedule. I will also connect Jenkins with GitHub. GitHub is our source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box and run few commands to build this particular repository that is pulled from GitHub. Sending out emails is a very, very important configurations of Jenkins or any other continuous integration server for that matter. Whenever there is any notifications that has to be sent out as a part of either a build going bad or build being good or build being propagated to some environment, and all these scenarios, you would need the continuous integration servers to be sending out notifications. So I will get into a little bit details of how to configure Jenkins for sending out emails. I will also get into a scenario where I would have a web application, a Maven based Java web application, which will be pulled from a GitHub repository, and I will deploy it onto a Tomcat server. The Tomcat server will be locally running on my system. Eventually, I will get into one other very important topic, which is the master-slave configuration. It's a very important and pretty interesting topic where distributed builds is achieved using a master-slave configuration. So I will bring up a slave, I will connect the slave with the master, and I will also put in a job and kind of delegate that particular job to the slave configuration. Finally, I will let you know how to use some plugins to back up your Jenkins. So Jenkins has got a lot of useful information set up on it in terms of the build environments, in terms of workspace. All this can be very easily backed up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. I have listed popular 3 mechanisms in which Jenkins is usually installed on any system. The topmost one is as a Windows or a Linux based services. So if at all you have Windows like the way I have, and I'm going to use this mechanism for this demo. So I would download a MSI installer that is specific to Jenkins and install this service. So whenever I install it as a service, it goes ahead and nicely installs all that is required for my Jenkins. And I have a service that can be started or stopped based upon my need. Any flavor of Linux as well. One other way of running Jenkins is downloading this generic war file, and as long as you have JDK installed, you can launch this war file by the command opening up a command prompt or shell prompt if at all you're on Linux box, specifying java-jar and the name of this war file. It typically brings up your web application, and you can continue with your installation. The only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt. You either do a Control-C and then bring down this prompt, and your Jenkins server would be down. Other older versions of Jenkins were run popularly using this way, in which you already have a Java-based web server up and running. So you kind of drop in this war file into the root folder or the HTTPD root folder of your web server. So Jenkins would explode and kind of bring up your application. All user credentials or user administration is all taken care of by the Apache or the Tomcat server or the web server on which Jenkins is running. This was a very older way of running, but still some people use it because if they don't want to maintain 2 servers, if they already have a Java web server which it's being nicely maintained and backed up, Jenkins can run attached to it. Alright, so either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very same or similar one, with the subtle changes in terms of user administration if at all you're launching it through any other web server which will take care of the user administration. Otherwise, all the commands or all the configuration or the way in which I'm going to run this demo, it is going to be same across any of these installations. Alright, so the prerequisites for running Jenkins, as I mentioned earlier, Jenkins is nothing but a simple web application that's written in Java. So all that it needs is Java, preferably JDK 1.7 or 1.8. 2 GB RAM is the recommended RAM for running Jenkins. And also, like any other open source toolsets, when you install JDK, ensure that you set in the environment variable Java home to point to the right directory. This is something very specific to JDK, but for any other open source tools that you install, there is always a preferred environment variable that you got to set in, which is specific to that particular tool that you're going to use. This is a generic thing that is there for, for any other open source projects, because the way open source projects discover themselves is using this environment variables. So as a general practice or a good practice, always set these environment variables accordingly. So I already have JDK 1.8 installed on my system, but in case you do not, what I would recommend is just navigate on your browser to the Oracle homepage and just type in or search for install JDK 1.8 and navigate to the Oracle homepage. You'll have to accept the license agreement, and there are a bunch of installers that you can pick up based upon the operating system on which you're running. So I have this Windows 64 installer that is already installed and running on my system. So I will not get into the details of downloading this or installing it. Let me show you once I install this, what I've done with regard to my path. So if you get into this environment variables, alright, so I've just set in a Java home variable. If you see this, C:\program files Java JDK 1.8. This is where my Java is located. C program files Java. Okay, so this is the home directory of my JDK. So that is what I've set it up here in my environment variable. So if you see here, this is my Java home. All right, one other thing to do is ensure that in case you want to run Java or JavaC from a command prompt, ensure that you also add that path into this path variable. So if you see this, somewhere I will see, yes, there you go. C: program files Java JDK 1.8 bin. So with these two, I'll ensure that my Java installation is nice and good enough. So to check that, to double check that, or to verify that, let me just open up a simple command prompt. And if I type in Java -version, all right, and Java C -version. So the compiler is on the path, Java is on the path, and if at all I do this, even the environment variable specific to my Java is installed correctly. So I'm good to go ahead with my Jenkins installation. Now that I have my prerequisites all set for installing Jenkins, let me just go ahead and download Jenkins. So let me open up a browser and say download Jenkins. All right. LTS is nothing but the long-term support. These are all stable versions. Weeklies, I would not recommend that you try these unless until you have a real need for that. Long-term support is good enough. And as I mentioned, there are so many flavors of Jenkins that is available for download. You also have a Docker container wherein you can launch Jenkins as a container, but I'll not get into details of that in this tutorial. All right. So what I want is, yes, this is the WAR file, which is a generic WAR file that I was talking to you earlier. And this is the Windows MSI installer. So go ahead and download this MSI installer. I already have that downloaded. So let me just open that up. All right. So this is my downloaded Jenkins instance, or rather installer. This is a pretty, maybe a few months old, but this is good enough for me. Before you start Jenkins installation, just be aware of one fact that there is a variable called Jenkins Home. This is where Jenkins would store all this configuration data, jobs, project workspace, and all that specific to Jenkins. So by default, if at all you don't set this to any particular directory, if at all you install an MSI installer, all your installation gets into C: program files 86 and Jenkins folder. If at all you run a WAR file, depending upon the user ID with which you're running your WAR file, the Jenkins folder, there's a .jenkins folder that gets created inside the user home directory. So in case you have any need wherein you want to back up your Jenkins or you want Jenkins installations to get into some specific directories, go ahead and set this Jenkins home variable accordingly before you even begin your installation. For now, I don't need to do any of these things, so I've already downloaded the installer. Let me just go ahead with the default installation. All right. So this is my Jenkins MSI installer. I don't want to make any changes into the Jenkins configuration. C: program files is good for me. Yeah. This is where all my destination folder and all the configuration specific to it goes. I'm happy with this. I don't want to change this. I would just say go ahead and click installation. Okay, so what typically happens once the Jenkins installation gets through is it'll start installing itself, and there are some small checks that needs to be done. So, and by default, Jenkins launches on the port 8080. So let me just open up localhost 8080. There's a small checking that will be done as a part of the installation process, wherein I need to type in a hash key. All right, so there's a very, very simple hash key that gets stored out here. So I'll have to just copy this path. If at all you're running as a WAR file, you would see that in your logs. All right, so this is a simple hash key that gets created every time when you do a Jenkins installation. So as a part of the installation, it just asks you to do this. So if that is not correct, it'll crib about it, but this looks good. So it's going ahead. All right, one important part during the installation. So you would need to install some recommended plugins. What happens is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugin and it's got a dependency which is not installed, and you get into all those issues. In order to get rid of that, what Jenkins recommends, there's a bunch of plugins that is already recommended. So just go ahead and blindly click that install recommended plugin. So if you see, there is a whole lot of plugins which are bare essential plugins that is required for Jenkins in order to run properly. So Jenkins, as a part of the installation, would get all these plugins and then install it for you. This is a good combination to kind of begin with. And mind you, at this moment, Jenkins needs lots of bandwidth in terms of network. So in case your network is not so good, few of these plugins would kind of fail. And these plugins are all available on openly or mirrored sites, and sometimes some of them may be down. So do not worry in case some of these plugins kind of fail to install. You'd get an option to kind of retry installing them, but just ensure that at least most or 90-95% of all these plugins are installed without any problems. Let me pause the video here for a minute and then get back once all these plugins are installed. My plugin installation is all good. There was no failures in any of my plugins. So after that, I get to create this first admin user. Again, this is one important point that you got to remember. Give in any username and password, but ensure that you kind of remember that, because it's very hard to get back your username and password in case you forget it. All right, so I'm going to create a very, very simple username and password. Something that I can remember. That's my name, and an email ID is kind of optional, but it doesn't allow me to go ahead in case I don't. So I just give in an admin and I got a password. I remember my password. This is my full name. All right, I say save and finish. All right, that kind of completed my Jenkins installation. It was not that tough, was it? Now that I have my Jenkins installed correctly, let me quickly walk you through some bare minimal configurations that is required. These are kind of a first time configuration that is required. So, and also let me warn you, the UI is little hard for many people to wrap their head around it, specifically the Windows guys. But if at all you're a Java guy, you know how painful it is to write UI in Java, you will kind of appreciate, all the effort that has gone into the UI. Bottom line, UI is little hard to, wrap your head around it, but once you start using it, possibly you'll start liking it. All right, so let me get into something called as Manage Jenkins. This can be viewed like a main menu for all the Jenkins configuration. So I'll get into some of those important ones. Something called as Configure System. Configure System, this is where you kind of put in the configuration for your complete Jenkins instance. Few things to kind of look out for. This is a home directory. This is a Java home where all the configurations, all the workspace, anything and everything regarding Jenkins is stored out here. System message, you want to put in some message on the system, you just type in whatever you want and it's possibly show up somewhere up here on the menu. Number of executors, very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. You can kind of visualize it like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, number of executors 2 should be good enough. In case at any point in time, if there are multiple jobs that kind of get triggered at the same time, in case the number of executors are less compared to the number of jobs that have woken up, no need to panic because they will all get queued up and eventually Jenkins will get to running those jobs. Just bear in mind that whenever a new job kind of gets triggered, the CPU usage and the memory usage in terms of the disk write is very high on the Jenkins instance. So that's something that you got to kind of keep in mind. All right, but number of executors 2 for my system is kind of good. Label for my Jenkins, I don't want any of these things. Usage, how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this node as much as possible. Quiet period. Each of these options have got some bare minimal help kind of a thing that is out here. By clicking on these question marks, you will get to know as to what are these particular configurations. All right, so this all look good. What I want to show you here is there's something regarding the Docker, timestamps, Git plugin, SVN, email notifications. I don't want that. What I want I want this SMTP server configuration. Remember, I mentioned earlier that I would want Jenkins to be sending out some emails. And what I've done here is I've just configured the SMTP details of my personal email ID. In case you're in an organization, you would have some sort of an email ID that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of send out emails. But in case you want to try it out like me, I have configured my personal email ID, which is on my Gmail, for sending out notifications. So the SMTP server would be smtp.gmail.com I'm using the SMTP authentication. I've provided my email ID and my password. I'm using the SMTP port, which is 465, and I'm, reply to address is the same as mine. I can just send out an email and see if at all this configuration works. Again, Gmail would not allow anybody to send out notifications on your behalf. So you'll have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notifications on your behalf. So I've done already that. I'm just trying to see if I can send a test email with the configurations that I've set in. Yes. All right. So the email configuration looks good. So this is how you configure your your Gmail account in case you want to do that. If not, put in your organization SMTP server details, which are with a valid username and password, and it should all be set. All right, so no other configurations that I'm going to change here. All of these look good. All right, so I come back to manage Jenkins. Okay, one other thing that I want to kind of go over is the global tool configuration. Imagine this scenario, or look at it this way. Jenkins is a continuous integration server. It doesn't know what kind of a code base it's going to pull in, what kind of a tool set that is required, or what is the code that it's going to pull in and how is it going to build. So you would have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from your source code repositories. So just to give an example, in case your source code is a Java source code, and assuming that, because in this demo, this is my laptop and I've put in all the configurations, JDK, everything on my laptop because I'm a developer, I'm working on the laptop. But my continuous integration server would be, a separate server without anything being installed on it. So in case I want Jenkins to, run a Java code, I would need to install JDK on it. I need to specify the JDK location of this out here this way. Okay, since I already have the JDK installed and I've already put in the Java home directory, or rather the environment variable correctly, I don't need to do it. Git, if at all I want the Jenkins server to use Git, Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you would need Git to be installed on that particular system and set the path accordingly. Gradle and Maven, if at all you have some Mavens as well, you want to do this. Any other tool that you're going to install on your system, which is your continuous integration server, you will have to come in here and configure something. In case you don't configure it, when Jenkins runs, it will not be able to find these tools for building your task and it'll crib about it. That's good. I don't want to save anything. Manage Jenkins. Let me see what else is required. Yes, configure global security. All right, the security is enabled. And if you see by default, it's the security access control is set to Jenkins' own user database. So what does this mean? Jenkins by default, it uses file system where it stores all the usernames, which hashes up these usernames and kind of stores them. So as of now, Jenkins is configured to use its own database. Assuming that you are running in an organization, you would probably want to have some sort of an AD or an LDAP server using which you would want to control access to your Jenkins repository, rather Jenkins tool. So you would specify your LDAP server details, the root DN, password or the manager DN and the manager password and all these details in case you want to connect your Jenkins instance with your LDAP or AD or any of the authentication servers that you have in your organization. But for now, since I don't have any of these things, I'm going to use this own database. That's good enough. All right. So I will set up some authorization methods and stuff like that once I put in few jobs. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own servers, which is happening as of now. So I'm going to save all this stuff. That's good for me. So enough of all these configurations. Let me put in a very, very simple job. All right. So job, new item. Little difficult to kind of figure out, but then that's the new item. So I'll just say, first job, this is good for me. I just give a name for my job. I would say it's a freestyle project. That's good enough for me. I don't want to choose any of that. So unless until you choose any of this particular button would not become active. So choose the freestyle project and say, okay. At a very high level, you would see general, source code management, build triggers, build environment, build and post build. In case you install more and more plugins, you will see a lot more options. But for now, this is what you would see. So what am I doing? At the moment, I'm just putting up a very, very simple job. And the job could be anything and everything. So I don't want to put in a very complicated job for now. For the demo purpose, let me just put in a very, very simple job. I'll give a description. This is an optional thing. This is my first Jenkins job. All right. I don't want to choose any of these. Again, there are some helps available here. I don't want to choose any of this. I don't want to connect it to any source code for now. I don't want any triggers for now. I'll come back to this in a while. Build environment. I don't want any build environment. As a part of this build step, I just want to, run few things so that I kind of complete this particular job. So since I'm on a Windows box, I would say execute Windows batch command. All right. So what do you want to do? Let me just echo something. Echo. Hello. This is my first Jenkins job. And possibly I would want the date and the timestamp pertaining to the job. I mean, the date and time in which this job was run. All right. Very, very simple command that says, this is my first job. It just puts out something along with the date and the time. All right. I don't want to do anything else. I want to keep this job as simple as this. So let me save this job. All right. So once I save this job, the job names comes up here, and then I need to build this job. And you would see some build history out here. Nothing is there as of now because I've just put in a job. I've not run it yet. All right. So let me try to build it now. You see a build number, you would see a date and a timestamp. So if I click on this, you would see a console output. If I go here, okay, as simple as that. And where is all the job details that is getting into? If you see this, if I navigate to this particular directory, all right, so this is the directory what I was mentioning earlier regarding Jenkins home. So all the job related stuff that is specific to this particular Jenkins installation is all here. All the plugins that is installed, the details of each of those plugins can be found here. All right, so the workspace is where all the jobs that I've created, whichever I'm running, there will be individual folders specific to the jobs that has been put up here. All right, so one job, one quick run. That's what it looks like. Pretty simple. Okay, let me do one thing. Let me put up a second job. I would say second job. I would say freestyle project. All right, this is my second job. I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put up on Jenkins. Which will be triggered automatically. Remember what I said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right, so what I'm going to do, I will just keep everything else the same. I'm going to put in a build script pretty much similar to second job that gets triggered automatically every minute. All right, let me do that. Percentage date, and I'll put in the time. All right, so I just put in another job called second job, and it pretty much does the same thing as what I was doing earlier in terms of printing the date and the time. But this time I'm just going to demonstrate the powerfulness of the automation server that is there. If you see here, there's a build trigger. So a build can be triggered using various triggers that is there. So we'll get into this GitHub triggering or hook or a webhook kind of a triggering later on. But for now, what I want to do, I want to ensure that this job that I'm going to put in would be automatically triggered on its own. Let's say every minute, I want this job to be run on its own. So build periodically is my setting. If you see here, there's a bunch of help that is available for me. So for those of you who have written cron jobs on Linux boxes, you'll find it very, very simple. But for others, don't panic. Let me just put up a very, very simple regular expression for scheduling this job every minute. All right, so that's 1, 2, 3, 4, 5. All right, come up. All right, so 5 stars is all that I'm going to put in. And Jenkins got a little worried and he's asking me, do you really mean every minute? Oh yeah, I want to do this every minute. Let me save this. And how do I check whether it gets triggered every minute or not? I just don't do anything. I'll just wait for a minute. And if at all everything goes well, Jenkins would automatically trigger my second job in a minute's time from now. This time around, I'm not going to trigger anything. Look, there you see. It's automatically got triggered. If I go in here, yep, second job that gets triggered automatically. It was triggered at 16:42, which is 4:42 my time. That looks good. And if everything goes well, every 1 minute onwards, this job would be automatically triggered. Now that I have my Jenkins up and running, a few jobs that has been put up here on my Jenkins instance, I would need a way of controlling access to my Jenkins server. This is wherein I would use a plugin called role-based access plugin and create few rules. The rules are something like a global role and a project role, project specific role. I can have different roles and I can have users who have signed up or the users whom I create kind of assigned to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwarranted. All right, so first things first, let me go ahead and install a plugin for doing that. So I get into Manage Jenkins and Manage Plugin. A little bit of a confusing screen in my opinion. There is updates available, installed and advanced. As of now, we don't have the role-based plugin. So let me go to available. It'll take some time for it to get refreshed. All right, now these are the available plugins. These are the installed plugins. All right, so let me come back to available and I would want to search for my role-based access plugin. So I would just search for role and hit enter. Okay, role-based authorization strategy enables user authorization using a role-based strategy. Roles can be defined globally or for particular jobs or nodes and stuff like that. So exactly, this is the plugin that I want. I would want to install it without a restart. All right, looks good so far. Yes. Go back to the top of the page. Yes. Remember, Jenkins is running on a Java using a Java instance. So typically many things would work the same way unless and until you want to restart Jenkins once in a while. But as a good practice, whenever you do some sort of a big installations or big patches on your Jenkins instance, just ensure that you kind of restart it. Otherwise, there would be a difference in terms of what is installed on the system and what is there on the file system. You would need to flush out few of those settings later on. But for now, these are all very small plugins, so these would run without any problems. But otherwise, if at all there are some plugins which would need a restart, kindly go ahead and restart your Jenkins instance. But for now, I don't need that. It looks good. I've installed the plugin. So where do I see my plugin? I installed the plugin that is specific to the user control or the access control. So let me go into, yes, global security. And I would see this role-based strategy showing up now. All right, so this comes in because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up. And for the authorization part, in the sense that who can do what, I'm going to install. I've already installed a role-based strategy plugin and I'm going to enable that strategy. All right, I would say save. Okay, now I've installed the role-based access plugin. I would need to just set it up and check that, I would go ahead and create some roles and ensure that I assign users as per these roles. All right, so let me go to Manage Jenkins, configure. All right, let me see, where is this? Configure global security. Is that where I create my roles? Nope, not here. Yes, manage and assign roles. Okay, again, you would see these options only after you install these plugins. So for now, I've just enabled the plugin. I've enabled role-based access control, and I would go ahead and create some roles for this particular Jenkins instance. So I would say first, manage roles. So I would need to create some roles here, and the roles are at a very high level. These are global roles, and there are some project roles, and there are some slave roles. I'll not get into details of all of these. at a very high level, which is a global role, let me just create a role. A role can be kind of visualized like a group. So I would create a role called developer. Typically, the Jenkins instance or the CA instance are kind of owned up or controlled by QA guys. So QA guys would need to provide some sort of limited access to developers. So that's why I'm creating a role called developer, and I'm adding this role at a global role level. So I would say add this here, and you would see this developer role that is there, and each of these options, if you hover over it, you would see some sort of a help on what are these permissions specific to. So what I want is it sounds a little different, but I would want to give very little permissions for the developer. So from an administration perspective, I would just want him to have a read kind of a role. Credentials, again, I would just want a view kind of a role. I don't want him to create any agents and all that stuff. That looks good for me. For a job, I would want him to just possibly read. I don't want him to build. I don't want him to cancel any jobs. I don't want him to configure any job. I don't even want him to create any job. I would just want him to read few things. I would not give him possibly a role to the workspace as well. I mean, I don't want him to have access to the workspace. I would just want him to read a job or check, have read-only access to the job. Run. No, I don't want him to give him any particular access which will allow him to run any jobs. View, configure, yeah, possibly create, yeah, delete. I don't want read, yes, definitely. And this is the specific role. So what I'm doing, I'm just creating a global role called developer, and I'm giving him very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs, or build jobs, or cancel jobs, or configure jobs. At the max, I would just want him to read a job that is already put up there. Okay, so I would save. Now I've created a role. I still don't have any users that is there on the system. So let me go ahead and create some user on the system. That's not here. I would say configure, manage Jenkins, manage users. Okay, let me create a new user. I would call this user as, yeah, developer one sounds good. Some password that I can remember. Okay, his name is developer1 d@d.com or something like that. Okay, so this is the admin with which I kind of configured or brought up the system, and developer1 is a user that I have configured. So still have not set any roles for this particular user yet. So I would go to manage Jenkins. I would say manage and assign roles. I would say assign roles. Okay, so if you see, what I'm going to do now is assign a role that is specific to that particular developer. I will find the particular user and assign him the developer role that I've already configured. The role shows up here. I would need to find my user, whoever created, and then assign him to that particular role. So if you remember, the user that I created was developer1. I would add this particular user, and now this particular user, what kind of a role I want him to have, because this is the global role that I had created. So developer, I would assign this developer1 to this particular global role, and I would go ahead and save my changes. Now let me check the permissions of this particular user by logging out of my admin account and logging back as developer1. If you remember, this role was created with very less privileges. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new job. I can't do anything. I see these jobs. However, I don't think so I'll be able to start this job. I don't have the permission set for that. The maximum I can do is look at the job, see what was there as a part of the console output and stuff like that. So this is a limited role that was created, and I added this developer to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs, because the Jenkins instance is owned by a QA person. He doesn't want to give developer any administrative rights. So the rights that he set out by creating a developer role, and anybody who is tagged, any user who is tagged as a part of this developer role would get the same kind of permissions. And these permissions can be, fine grained. It can be a project specific permissions as well. But for now, I just demonstrated the high level permission that I had set in. Let me quickly log out of this user and get back as the admin user because I need to continue with my demo. With the developer role that was created, I have very less privileges. One of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins that is provided by users or community users who don't charge any money for these plugins, but it's got plugins for connecting anything and everything. So if you can navigate to, or if you can find Jenkins plugins, you would see index of over so many plugins that is there. All of these are wonderful plugins. Whatever connectors that you would need if you want to connect Jenkins to an AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you would have a plugin. You can go and search up. If I want to connect Jenkins to Bitbucket, Bitbucket is one of the Git servers. There's so many plugins that is available. Okay, so bottom line, Jenkins without plugins is nothing. So plugins is the heart of Jenkins. For you to connect, or in order to connect Jenkins with any of the containers or any of the other tool sets, you would need the plugins. If you want to connect, or you want to build a repository which has got Java and Maven, you would need to install Maven and JDK on your Jenkins instance. If at all you're looking for a .NET build or a Microsoft build, you would need to have MS Build installed on your Jenkins instance, and the plugins that will trigger MS Build. If at all you want to listen to some server-side webhooks from GitHub, you would need GitHub specific plugins. If you want to connect Jenkins to AWS, you need those plugins. If you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. SonarQube is one of the popular static code analyzers. So you can connect a Jenkins build, you can build a job on Jenkins and push it to SonarQube and get SonarQube to run analysis on that and get back the results in Jenkins. All of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to GitHub. I already have a very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. All right. So this is my very simple repository that is there called Hello Java, and this is what is there in the repository. There is a hello.java application that is here, or a simple class file that is there. It's got just one line of system.out. So this is already present on github.com at this place, and this would be the URL for this repository. If I pick up the HTTPS URL, this is my HTTPS URL. So what I would do is I would connect my Jenkins instance to go to GitHub, provide my credentials, and pull out this repository which is on the cloud hosted github.com and get it to my Jenkins instance, and then build this particular Java file. I'm keeping the source code very simple. It's just a Java file. How do I build my Java file? How do I compile my Java file? I just say Java C and the name of my class file, which is hello.java. And how do I run my Java file? I would say Java and hello. Okay, so remember, I don't need to install any plugins now because what it needs is a Git plugin. So if you remember, when we were doing the installation, there was a bunch of recommended plugins. So Git is already installed on my system, so I don't need to install it again. So let me put up a new job here. It says Git job. Let it be a freestyle project. That's good for me. I would say okay. All right, so the source code management. Remember, in the earlier examples, we did not use any source code because we were just putting up some echo kind of jobs. We did not need any integration with any of the source code systems. So now let me connect this. So I'm going to put up a source code, and Git would show up because the plugin is already there. SVN, Perforce, any of those additional source code management tools, if at all you would need, just install those plugins, and Jenkins connects wonderfully well to all these particular source control tools. Okay, so I would copy the HTTPS URL from here. I would say this is the URL that I'm supposed to go and grab my source code from. But all right, that sounds good, but what is the username and password? So I'll have to specify a username and password. All right, so I would say the username, this is my username, and this is my HTTPS credential for my job. Okay, so this is my username and this is my password. I just save this. I say add, and then I would say, use these credentials to go to GitHub and then on my behalf, pull out a repository. All right. If at all at this stage, if there's any error in terms of Jenkins not able to find Git or the git.exe, or if my credentials are wrong, somewhere down here you would see a red message saying that something is not right, you can just go ahead and kind of fix that. For now, this looks good for me. I'm going to grab this URL. What am I going to do? This step would pull the source code from the GitHub. And then what would be there as a part of my build step? Because this repository just has a Java file, correct? Hello.java. So in order for me to build this, I would just say execute Windows batch command, and I would say Java C hello.java. That is the way I would build my Java code. And if I have to run it, I would just say Java hello. Pretty simple, 2 steps. And this would run after the repository contents are fetched from GitHub. So Java C, Java, that sounds good. I would say save this and let me try to run this. Okay, if you see, there's a lot of, it executes Git on your behalf. It goes out here, it provides my credentials and says, it pulls all my repository, and by default, it will pull up the master branch that is there on my repository. And it kind of builds this whole thing, Java C hello.java, and it runs this project Java hello, and there you see, this is the output that is there. And if at all you want to look at the contents of the repository, if you can go here, this is my workspace of my system. Hang on, this is not right. Okay, git job. If you see here, this is my hello.java. This is the same program that was there on my GitHub repository. Okay, so this is a program that was there on my GitHub repository. All right, so this was the same program that was here, and Jenkins on our behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to my local system on my Jenkins instance. It compiled it and it ran this particular application. Okay, now that I've integrated Jenkins successfully with GitHub for a simple Java application, let me build a little bit on top of it. What I will do is I have a Maven based web application that is up there as a repository in my GitHub. So this is the repository that I'm talking about. It's called MVN Web App. It's a Maven based repository. As you would know, Maven is a very, very simple Java based build tool that will allow you to run various targets, and it'll compile. It will, based upon the goals that you specify, it can compile, it can run some tests, and it can build a war file and even deploy it into some other server. For now, what we're going to use Maven is just for building and creating a package out of this particular web application. It contains a bunch of things, and what is important is just the index.jsp. It just contains an HTML file that is there as a part of this web application. So from a perspective of requirements, now since I'm going to connect Jenkins with this particular repository, Git, we already have that set. We only need 2 other things. One is Maven, because Jenkins will use Maven. So in order to use Maven, Jenkins would have to have a Maven installation that is there on the Jenkins box. And in this case, the Jenkins box is this laptop. And after I have my Maven installed, I also need a Tomcat server. Tomcat is a very, very simple web server that you can freely download. I'll let you know how to quickly download and install the Tomcat. All right, so download Maven first. There are various ways in which you can kind of download this Maven. There is zip files, binary zip files, and archive files. So what I've done is I've just already downloaded Maven, and if you see, I've unzipped it here. So this is the folder with which I've unzipped my Maven. So as you know, Maven again is a one open source build tool. So you'll have to set in a few configurations and set up the path. So mvn -- version, if I specify this, after I set in my path, Maven should work. And if at all I echo m2 home, which is nothing but the environment variable specific to Maven home, it is already set here. So once you unzip Maven, just set this m2 home variable to the directory where you unzipped your Maven. Also, just set the path to this particular directory /bin, because that is where your Maven executables are all found. All right, so that's with Maven. And since I've set the path and the environment variable Maven is running perfectly fine on my system, I've just verified it. Okay, next one is a Tomcat server. Download Apache Tomcat server 8.5 is what I have on my system. So I'm just going to show you where to download this from. This is where you download Tomcat server, and I already have the server downloaded. Again, this doesn't need any installation. I just unzip it here and it kind of has a bin and configuration. I've made some subtle changes in the configuration. First and foremost, Tomcat server also by default runs on port 8080. Since we already have our Jenkins server running on port 8080, we cannot let Tomcat run on the same port. There will be a port clash. So what I've done, I've configured Tomcat to use a different port. So if I go to this configuration file here, there is a server.xml. Let me open this up here. All right. Okay. So this is the port. By default, it will be 8080. I've just modified it to 8081. So I've changed the port on which my Tomcat server would run. All right. So that's one change. Second change, when Jenkins kind of tries to get into my Tomcat and deploy something for someone, he would need some authentications so that he'll be allowed deployment by Tomcat. So for that, I need to create a user on Tomcat and provide these user credentials to my Jenkins instance. So I would go to Tomcat users.xml file here. I've already created a username called deployer and the password is deployer, and I've added a role called manager-script. Manager-script will allow programmatic access to the Tomcat server. So this is the role that is there. So using these credentials, I will enable or I'll empower Jenkins to get into my Tomcat server and deploy my application. All right, only these two things that is required. Let me just start my Tomcat server first. So I get into my bin folder, I open a command prompt here, and there's a startup.bat. It's pretty fast. It just takes a few seconds. Yes, there you go. Tomcat server is up and running. Now this is running on port 8081. So let me just check if that looks good. So localhost 8081. Okay, my Tomcat server is up and running. That sounds good. The user is already configured on this. That's also fine. So what I'll do as a part of my first job, Maven is also installed on my system. So I'm good to use Maven as a part of my Jenkins. So I will put up a simple job now. I will say job, MVN, web app. I'll call this freestyle job. That's good. Okay, so this will be a Git repository. What is the URL of my Git repository? Is this guy, HTTPS URL. Okay, that's this URL. I will use the credentials. The old credentials that I set up will work well because it's the same Git user that I'm kind of connecting into. All right. So now the change happens here where after I get this, since I said this is a simple Maven repository, I will have some Maven targets to run. So the simple target first is, let me run Maven package. This creates a war file. Okay, so MVN package is the target. Package is the target. So whenever I run this package, it kind of creates it, it builds it, it tests it, and then creates a package. So this is all that is required. Maybe let me try to save this and let me first run this and see if it connects well, if there's any problem with my war file or the war file gets created properly. Okay, wonderful. So it built a war file, and if you see, it all shows you what is the location where this war file was generated. So this will be the workspace. If you see this war file was successfully built. Now I need to grab this particular war file and then I would need to deploy it into Tomcat server. Again, I would need a small plugin to do this because I need to connect Tomcat with my Jenkins server. Let me go ahead and install the plugin for the container deployment. So I would go to manage plugins, available, type in container, container, deploy to container. Okay, so this would be the plugin that I would need. I would install it without a restart. Okay, seems to be very fast. Nope, sorry, it's still installing. Okay, it installed the plugin. So if at all you see this, if you go to my workspace, okay, in the target folder, I would see this web application WAR file that is already built. So I would need to configure this plugin to pull up this WAR file and deploy it onto the Tomcat server. For deploying onto the Tomcat server, I will use the credentials of the user that I've created. Okay, so let me go to configure this particular project again. And okay, all this is good. So the package is good. I'm going to just create a package. That's all fine. Now add a post build step. So after the WAR file is built as a part of this package directive, let me use this deployment to container. Now this will show up after you install the plugin. So deploy this one to the container. Now what is that you're supposed to specify? You're supposed to specify what is the location. Okay, so this is a global configuration that is there that will allow you to, from the root folder, it will pick up the WAR file that is there. So *****war, that's good for me. Okay, what is the context path? Context path is nothing but just the name of an application that, under which it will get deployed into the Tomcat server. I will just say MVN web app. That's the name of my thing. Now I need to specify what kind of a container that I'm talking about. All right, so the deployment would be for this Tomcat 8.5 is what I need. Okay, because the server that we have is a Tomcat 8.5 server that I have. So this would be the URL. So the credentials, yes, I need to add a credential for this particular server. So if you remember, I had created a credential for my web application. So let me just find that. My Tomcat server, yes, configuration of this. Okay, so deployer and deployer. Username is deployer, password is deployer. Okay, so let me use that credential. I would say add a new credential, Jenkins credential. The username is deployer and the password is deployer. So I would use this deployer credentials for that. And what is the URL of my Tomcat instance? So this is the URL of my Tomcat instance. So take the WAR file that is found in this particular folder. And then, context path is MVN web app, use the deployer deployment credentials and get into this localhost, which is there 8081. This is the Tomcat server that is running on my system, and then go ahead and deploy it. Okay, so that is all that is required. So I would say just save this and let me run it now. Okay, it successfully built the WAR file. It is trying to deploy it, and looks like the deployment went ahead perfectly well. So the context path was MVN web app. So if I type in this, or if at all I go ahead into my Tomcat server, there would be a web apps folder. You would see the date timestamp. So this is the file that got recently copied, and this is the Explorer version of our application. So the application was built, the source code of this application was pulled from the GitHub server. It was built locally on the Jenkins instance, and then it was pushed into a Tomcat server which is running on a different port, which is 80881. Now for this demo, I'm running everything locally on my system, but assuming that this particular Tomcat instance was running on some other server with some other different IP address, all that you got to go and change is the URL of the server. So this would be the server in case you already have that, if you have a Tomcat server which is running on some other machine, that's all fine. With a different IP, that's all good enough. The whole bundle or the WAR file that was built as a part of this Jenkins job gets transferred onto the other server and gets deployed. That's the beauty of Jenkins and automatic deployments, or rather deployments using Jenkins and Maven. Distributed build or master slave configuration in Jenkins. As you would have seen, we just have one instance of Jenkins server up and running all the time. And also I told you that whenever any job that kind of, gets started on the Jenkins server, it is little heavy on in terms of disk space and the CPU utilization. So which kind of, if at all you're in an organization wherein you're heavily reliant on the Jenkins server, you don't want your Jenkins server to go down. So that's wherein you kind of start distributing the load that is there on the Jenkins server. So you primarily have a server, which is just a placeholder or like a master who will take in all the kind of jobs. And what he'll do is based upon trigger that has happened to the job or whichever job needs to be built, if at all, he can delegate these jobs onto some other machines or some other slaves. That's a wonderful thing to have. Okay, use case 1. Use case 2, assuming that, if you have a Jenkins server that is running on a Windows box or on a Linux one, and if at all you have a need where you need to build based upon operating systems, you have multiple build configurations to support. Maybe you need to build a Windows, Windows based .NET kind of a projects where you would need a Windows machine to build this particular project. You also have a requirement where you want to build Linux based systems. You also have a Mac. You support some sort of an apps or something that is built on Mac OS. You would need to build, Mac based system as well. So how are you going to support all these needs? So that's wherein a beautiful concept of master slave or, primary and delegations or agent and master comes into play. So typically you would have one Jenkins server who will just, configure with all the proper authorizations, users, configurations, and everything is set up on this Jenkins server. His job is just delegations. He will listen to some sort of triggers or based upon the job that is coming in, he will, if there is a nice way of delegating these jobs to somebody else and, taking back the results, he can control a lot of other systems. And these systems may not have a complete, or there's no need to put in a complete Jenkins installation. All that you got to do is have a very, very simple runner or a slave that is a simple jar file that is run as a low priority thread or a process within these systems. So with that, you can have a wonderful distributed build server that can be set up. And in case one of the servers goes down, your master would know that what went down and kind of delegate the task to somebody else. So this is the kind of distributed build or the master slave configuration. So what I'll do in this exercise or in this demo is I will set up a simple slave. But since I don't have too many machines to kind of play around, what I'll do is I will set up a slave in one other folder within my hard drive. So I've got the C drive and D drive. My Jenkins is on my C drive. So what I would do is I would just use my E drive and set up a very, very simple slave out there. I'll just show you how to provision a slave and how to connect to a slave and how to delegate a job to that slave. Let me go back to my Jenkins master and configure him to, talk to an agent. So there are various ways in which this client and server talk to each other. What I'm going to choose is something called as JNLP. Java Network Launch Protocol. So using this, I would ensure that, the client and server talk to each other. So for that, I need to ensure that I kind of enable this JNLP port. So let me try to find out where is that. Let me try this. Okay, yes. Agents, and by default, this JNLP agents thing would be disabled. So if you see here, there's a small help on this. So I'm going to use this JNLP, which is nothing but Java Network Launch Protocol. And, I'll configure the master and server to talk to each other using JNLP. So for that, I need to enable this guy. So I enable this guy instead of making by default, the configuration was disabled. So I make him random. I make him, enabled, and I say save this configuration. All right. So now I configured or I made a setting for the master so that the JNLP port is kind of opened up. So let me go ahead and, create an agent. So I'll go to manage nodes. So if you see here, there's only one master here. So let me provision a new node here. So this is the way, in which you bring up a new node. You have to configure it on the server. Jenkins would put in some sort of security around this particular agent and let you know how to launch this particular agent so that he can connect to our Jenkins master. So I would say new node. I would give a name for my node. I would say Windows node because both of these are Windows only. So that's fine. I'll just give an identifier saying that Windows node. I would say this is a permanent agent. I would say, okay. So if you see the name, let me just copy this name here with the description, number of executors. Since it's a slave node and both of these are running on my system, I will keep the number of executors as 1. That's fine. Remote root directory. Now this is where, let me just clarify this. Since I have both my master is running on my C drive program files 86, or hang on, not 86, C : program files. It is indeed 86. All right, Jenkins. So this is where my master is running. So I don't want the C drive. What I'll do is I'll use something called as A drive. I have another drive in my system, but please visualize this like, you're running this on a separate system altogether. So I create a folder here called Jenkins node, and this is where I'm going to place I'm going to provision my slave, and I'm going to run him from here. So this is the directory in which I'm going to provision my slave node. So I'm going to copy this here, and that is the remote root directory of your particular agent or slave. So I just copy it here. The label, probably this is fine for me. And usage, how do you want to use this guy? So I don't want him to run all kinds of jobs. I will only build jobs with label expressions that match this particular node. And so this is the label of this node. So in order for somebody to kind of delegate any task to them, they will have to specify this particular label. So imagine this way, if I have a bunch of Windows mesh system, I name it as Windows star. Anything that starts from Windows, I can give a regular expression and say that anything that matches Windows, run this particular task there. If I have some Mac machines, I name all these Mac agents as Mac star or something like that, and I can delegate all tasks, saying that start with whatever starts with Mac in this node, run the Mac jobs there. So you identify a node using the label and then delegate the task there. All right. So launch method, we will use Java Web Start because we're going to use JNLP protocol. Okay, that sounds good. Directory, I think nothing else is required. Availability, yes, we'll keep this agent, yep, online as much as possible. That sounds good. All right, let me save this. All right, I'm just provisioning this particular node now. So if I click on this node, I get a bunch of commands along with an agent.jar. So this is the agent.jar that has to be taken down to the other machine or the slave node, and from there I need to run this along with a small security credential. So let me copy this whole text here in my notepad. Notepad plus is good for me. Okay, I copy this whole path there. I also want to download this agent.jar. I would say yes. And this agent.jar is the one that is configured by our server. So all the details that is required for launching this agent.jar is found in this. For launching this agent is found in this agent.jar. So typically I need to take this jar file onto the other system and then kind of run it from there. So I have this agent.jar. I copy this, or rather I cut this. I come back to my folder, my Jenkins node. I paste it here. Okay. So now with this provision agent.jar, and I need to use this whole command, Control A, Control C, and then launch this particular agent. So let me bring up a command prompt right here and then launch it. So I'm saying in the same folder where there is agent.jar, I'm going to launch this particular agent, java-jar, agent.jar, JNLP. This is the URL of my server. In case the server and client are on different locations or different IPs, you have to specify the IP address. All this anyway would show up. And then the secret and the root folder of your Jenkins or the slave node. Okay. So something ran and then it says it's connected very well. It seems to have connected very well. So let me come back to my Jenkins instance and see, if at all you see earlier, this was not connected. Now let me refresh this guy. Okay, now these two guys are connected. Provision a Jenkins node, and then I copied all the credentials or the slave.jar along with the launch code and then took it to the other system and kind of ran it from there. Since I don't have another system, I've just got a separate directory in another folder, another drive, and I'm launching the agent from here. As long as this particular agent is up and running or this command prompt is up and running, the agent would be connected. So once I close this, the connection goes down. All right, so successfully we've launched this particular agent. Now this would be the home directory of this Jenkins node or the Jenkins slave. So any task that I'm going to delegate to this particular slave would all be run here. It will create a workspace right here. All right, so good. So let me just come back and let me kind of put up a new task here. I will say that, delegate job is good. I say freestyle project. I'm going to create a very, very simple job here. I don't want it to connect to Git or anything like that. Let me just create a very, very simple echo delegated to the slave, delegated to, I don't like the word slave, delegated to agent. Put this way. All right. So delegate it to agent sounds good. Now, how am I going to ensure that this particular job runs on the agent or on the slave that I've configured? Right? Do you see this? If at all you remember how we provisioned our particular slave, we gave a label, right? So now I'm going to put in a job that will only match this particular label. So I'm going to say that whatever matches this, Windows label, run this job on that particular node. So we have only one node that's matching this, Windows node. So this job will be delegated out there. So I save this and let me build this. This is again a very, very simple job. There's nothing in this. I just want to demonstrate how to kind of delegate it to an agent. So if you see this, it ran successfully. And where is the workspace? The workspace is right inside our Jenkins node. It created a new workspace, delegated job, it put in here. So my old or my primary master job is in SQL program files under Jenkins. And this is the slave job that was successfully run. Very, very simple, but very, very powerful concept of master slave configuration or distributed build in Jenkins. Okay, approaching the final section where we've done all this hard work in bringing up our Jenkins server, configuring it, putting up some jobs on it, creating users and all this stuff. Now, we don't want this configuration to kind of go away. We want a very nice way of ensuring that we back up all this configuration. And in case there is any failure, hardware crash or a machine crash, we will want to kind of restore from the existing configuration that we kind of backed up. So one quick way to do that would be, or one dirty way to do that would be just, take a complete backup of our program files Jenkins directory, because that's where our whole Jenkins configuration is present. But we don't want to do that. Let's use some plugins for taking up a backup. So let me go to Manage Jenkins and click on Available. And let me search for some backup. There are a bunch of backup plugins. So I would recommend one of these plugins that I specifically use. So this is the backup plugin. So let me go ahead and install this plugin. All right, so we went ahead and installed this plugin. So let me come back to my manage plugins. So this plugin is there. So hang on, backup manager. So you will see this option once you install this plugin. So first time I can do a setup. I would say backup this particular. I'll give a folder. This folder is pertaining to the folder where I want Jenkins to back up some data. And I would say the format should be zip format is good enough. Let me give a name or a template or a file name for my backup. This is good. I want it in verbose mode. I don't want to shut on my Jenkins, or should I shut it down? No. Okay. One thing that you got to remember is that whenever a backup happens, if there are too many jobs that is running on the server, it can kind of slow down your Jenkins instance, because it's in the process of copying few of those things, and if the files are being changed at that moment, it's a little bit problematic for Jenkins. So typically you back up your servers only when there is very less load, or typically try to bring it to a shutdown kind of a state and then take a backup. All right, so I'm going to back up all these things. I don't want to exclude anything else. I want the history. I want the Maven artifacts. Possibly I don't want this guy. I would just say save, and then I would say back him up. So this would run a bunch of steps and all the files that is required as a part of this is pretty fast. But then if at all you have too many things up on your server, for now we didn't have too many things up on our server, but in case you had too many things to kind of back up, this may take a while. So let me just pause this recording and get back to you once the backup is complete. So there you go. The backup was successful. Created a backup of all our workspace, the configurations, the users, and all that. So all this is kind of hidden down in this particular zip file. So at any instance, if at all I kind of crash my system for some instance, or say hard disk failure, and I bring up a new instance of Jenkins, I can kind of use the backup plugin for restoring this particular configurations. So how do I do that? I just come back to my manage Jenkins, come back to backup manager, and I will say restore Hudson or Jenkins configuration.
Hi guys, welcome to this video on Jenkins interview questions and answers. Jenkins is a popular DevOps open source automation server. It is used to automate the non-human part of software development and supports continuous integration and continuous delivery. Jenkins is a server-based system that runs in servlet containers such as Apache Tomcat. We have compiled the most important Jenkins interview questions that you might face in a Jenkins or DevOps interview. So without further ado, let us get started with Jenkins interview questions and answers.
So the first question you'll be asked about with Jenkins is explain a master-slave architecture of Jenkins. So the way that Jenkins is set up is that the Jenkins master will pull code from your remote Git repository such as GitHub and will check that repository every time there is a code commit. It will distribute the workload of that code and the tests that need to be applied to that code to all of the Jenkins slaves. And then on request, the Jenkins master and the slaves will then carry out all the builds and tests to be able to produce test reports. The next question you'll be asked is, what is a Jenkins file? And simply put, a Jenkins file is a text file that has a definition of the Jenkins pipeline and is checked into a source code repository. And this really allows for three distinct things to happen. One, it allows for a code review and iteration of the pipeline. It permits an audit trail for that pipeline and also provides a single source of truth for the pipeline, which can be viewed and edited. So which of the following commands runs Jenkins from the command line? Is it java-jar jenkins.war, java-war jenkins.jar, java-jar jenkins.jar, java-war jenkins.war? And the answer is A, java-jar jenkins.war. So when working with Jenkins, you're going to be asked what are the key concepts and aspects of working with a Jenkins pipeline. And you want to really hold out your fingers here and go through 4 key areas, and that is pipeline, node, step, and stage. So pipeline refers to the user-defined model of a CD continuous delivery pipeline. Node are the machines which are part of that Jenkins environment within the pipeline. Step is a single task that tells Jenkins what to do at that particular point in time. And then finally, stage defines a conceptually distinct subset of tasks performed through the entire pipeline. And tasks could be build, test, and deploy. So which of the following file is used to define dependency in Maven? And do we have A, build.xml, B, pom.xml, C, dependency.xml, or D, version.xml? And the answer is pom.xml. Working with Jenkins, you're going to be asked to explain the 2 types of pipeline used in Jenkins along with the syntax. And so a scripted pipeline is based on GroovyScript as the domain-specific language for Jenkins. And there are 1 or more node blocks that are used throughout the entire pipeline. On the left-hand side, you can actually see what the actual script would look like, and the right-hand side shows what the actual declaration for each section of that script would be. The second type of Jenkins pipeline is a declarative pipeline. And a declarative pipeline provides a simple and a friendly syntax to define what the pipeline should look like. And then you can actually, at this point, use an example to actually break out how blocks are used to define the work completed in a declarative pipeline. So how do you create a copy and backup of Jenkins? Well, to create a backup, periodically back up Jenkins to your Jenkins home directory, and then create a copy of that directory. It's really as simple as that. A question you'll be asked as well is how can you copy Jenkins from one server to another? Well, there are 3 ways to do that. One is you can move a job from one installation of Jenkins to another by copying the corresponding job directory. The second would be to create a copy of an existing job directory and making a clone of that job directory but with a different name. And the third is to rename an existing job by renaming a directory. So security is fundamental to all the work that we do within DevOps, and Jenkins provides the center core to all the work that gets completed within a DevOps environment. there are three ways in which you can apply security to authenticate users effectively. And when you are asked about this question of security within Jenkins, the three responses you want to be able to provide is A, Jenkins has its own internal database that uses secured user data and user credentials. B is you can use a LDAP or lightweight directory access protocol server to be able to authenticate Jenkins users. Or C, you can actually configure Jenkins to authenticate by using such as OAuth, which is a more modern method of being able to authenticate users. You're going to be asked how to deploy a custom build of a core plugin within Jenkins. And essentially, the 4 steps that you want to go through are, first of all, copying the .hpi plugin file into the Jenkins home plugins subdirectory. You want to remove the plugin's development directory if there is one. You want to create an empty file called plugin.hpi.pinned. And once you've completed these 3 steps, restart Jenkins and your custom build plugin should be available. How can you temporarily turn off Jenkins security if the administrative user has locked themselves out of the admin console? Well, this doesn't happen very often, but when it does, it's good to know how you can actually get into Jenkins and be able to resolve the problems of authenticating effectively into the system as an administrator. So when you want to be able to get into a Jenkins environment, what you want to be able to do is locate the config file. You should see that it's set to true, which allows for security to be enabled. If you then change the user security setting to false, security will be disabled, allowing you to make your administrative changes and will not be re-enabled until the next time Jenkins is restarted. So what are the ways in which a build can be scheduled and run in Jenkins? Well, there are 4 ways in which you can identify the way a build can be scheduled and run in Jenkins. The first is when source code management commits new code into the repository. You can run Jenkins at that point. The second can be after the completion of other builds. So maybe you have multiple builds in your project that are dependent to each other, and when so many other builds have been executed, then you can have Jenkins run. You can schedule builds to run at a specified time. So you may have nightly builds of your code that illustrate the changes in the solution you're building. And then finally, you also can manually build a environment on request. Occasionally, you will want to also restart Jenkins. And so it's good that when a question around how do you restart Jenkins manually comes up, that you have the answers. And there are 2 ways in which you can do it. One is you can force a restart without waiting for builds to complete by using the Jenkins URL that you have for your environment /restart, or you can allow all running builds to complete before restart are required, and in which case you would use the command of the URL for your Jenkins environment /safe restart.
So before we talk about Selenium, let's understand a few drawbacks of manual testing. Let's take an example of a very simple use case. As a user, I want to log in to my web application using username and password. A very simple use case, and it's a very common use case for any kind of web application you're working. So as a tester, what do? I need to write multiple test cases to test this use case. So I can use multiple data sets like valid credentials, invalid credentials, null values, and so on to test this particular use case. And then what you do, you start executing the test cases one by one. You find bugs, then your developers fixes them, and then you will need to rerun all the test cases again and again until all the bugs for this use case are fixed and your application is ready to ship. Now look into this. Now this brings us to the first demerit of the manual testing, which is what? If one has to run test cases with 100 transactions and repeat them again and again, this is going to be a very time consuming process and very boring. Also, it is more error prone since it's done manually and human mistakes are bound to happen. The third challenge is the scope of manual testing itself is very limited. For example, say regression testing. Ideally, you would want to run all the test cases which you have written, but since it's a manual process, this is going to be very tedious to do. And also, you would not have all the luxury of time to execute all test cases. So what do? You start picking up those test cases which are very important to be run. And that way, you are kind of limiting the scope of your testing.
Also, working with large amount of data manually is going to be impractical. What about performance testing? You want to collect metrics on various performance measures as a part of your performance testing. You want to simulate multiple loads on your application under test, and all these things manually it is very difficult to perform. And it's not feasible also. And to submit all this, creating manual test reports after running all the tests. Who wants to really do that? And again, another level of challenge here is, say if you're working on an agile model where code is being churned out by developers, the testers are building their test cases, executing them as and when the builds are available to them. This happens iteratively, and hence you will need to run all those test cases which you have written multiple times during your development cycle. And doing this manually definitely is going to be very tedious and boring. And is this the effective of doing it? No. So what do? We automate it. So this tells us why we want to automate. 1, for faster execution. 2, to be less error prone. 3, to help frequent execution of our tests. So there were many tools available in the market for automation. One such tool was Selenium, and that brings us to the slide, Advent of Selenium. So much before Selenium, there were various tools in the market like RFT, QTP, just to name a few popular ones. So Selenium was introduced by a gentleman called Jason Huggins way back in 2004. He was an engineer at ThoughtWorks. He was kind of working on a web application which needed frequent testing, and he realized the inefficiency in doing manual testing of his application repeatedly. So what he did was he wrote a JavaScript program that automatically controlled the browser actions, and then he named that as JavaScript Test Runner. He made this open source, which was later renamed as Selenium Core, and this is how the Selenium came into existence. So with this brief history of Selenium, let's understand what is Selenium and what are its main features. Selenium is the most popular and widely used automation tool for automating web applications. It enables us to test web application on different kind of browsers like Internet Explorer, Chrome, Firefox, Safari, Opera, and so on. And also they introduced support for Edge browser after Microsoft introduced it. Selenium is a set of tools and libraries to facilitate automation of web application. It is not a single tool. It has multiple components, and those we will be seeing in some time. All these tools together help us test the web application. So Selenium is open source and it is platform independent. This is the biggest reason why people are preferring this tool, because it is free of cost. QTP and RFT, which I just talked about, are a chargeable one. Selenium scripts can run on any platform because Selenium is primarily developed in JavaScript. So it is platform independent. Well, as you know, it's common for manual testers not to have in-depth programming background. So Selenium has a record and replay back tool called the Selenium IDE, which can be used to create a set of actions as a script and to replay that script. But this is mainly used for demo purpose. Why? Because Selenium is such a powerful tool that you should be able to take advantage of all its features and not just be with a record and replay tool, right? So that way there are a lot of record and replay tool anyway available in the market. The Selenium provides support for different programming language, Java, Python, C#, Ruby, PHP, and so on. You can write your test scripts in any language you prefer or you like. And again, as I said, one need not really know in-depth or advanced knowledge of these languages. You would still be able to write the Selenium scripts with a basic knowledge of this programming language. And also Selenium supports various operating systems. You can run Selenium test on Windows, Mac, or Linux, or even say if you have a Ubuntu machine, you can always run your Selenium test on Ubuntu machines. So you can run the test on any platform of your choice. Okay, so let's go now a little more deeper into Selenium. So I said that Selenium is not a single tool, but it is a suite of tools, right? So now let's look at what are those major components which comprises of the Selenium suite. First one is the Selenium IDE. So Selenium IDE is the most simplest tool in the whole suite of the Selenium. It is nothing but it's an integrated development environment. Earlier, this IDE was simply a Firefox extension and it offered a record and playback functionality. It was a very simple and easy to use. And as I said, mainly this is used for prototyping or for only the demo purposes, right? And not creating automation for your real-time projects because you know of its own limitation of being a simple record and replay tool. However, Selenium, what happened? Selenium IDE, it died with Firefox 55. So that means the support for IDE was stopped from Firefox 55 version. But the good news is very recently brand new Selenium IDE has been launched. And also what they have done is they have made this cross browser. That means you can install the extension on Chrome the IDE extension on Chrome or as an add-on on Firefox. So it is supported on both the browsers, Firefox and Chrome. Alright, so while we're talking of this IDE, let me also show you how the latest IDE on the Chrome looks. Okay, for that, let me go and launch my Chrome browser. So let me just open a new tab, and what I'll do is I'll search for Selenium IDE for Chrome download. Then I go to this website, and then you can see here Selenium IDE offered by seleniumhq.org. So what I simply need to do is, like you install any extension on your Chrome browsers, I just say add to Chrome, and this adds this extension on your Chrome browser. Now it has added. So Selenium IDE has been added to Chrome. Use this extension by clicking this icon. So can you see this icon here, which is Selenium IDE? That's it. So once you have installed this, you are free to start using the IDE on this Chrome browser. Similarly, you can do adding of this add-on, which is called as add-on on Firefox. So go to the Firefox browser, search for the Selenium IDE and just install that add-on. So let's get back to our presentation. So that's about the IDE. So what's our next component? Our next component is Selenium RC, which is nothing but Selenium Remote Control. Selenium RC is used to write web application tests in different programming languages. It interacts with the browser with the help of RC server. It has an RC server through which only it can interact with the web browsers. And how does it communicate? It uses a simple HTTP GET and POST request. And this is what was called as Selenium 1.0 version. But it got deprecated in 2.0 version and it was completely removed in 3.0 and was replaced with something called as WebDriver. So we will be talking in detail about why this happened, what were the drawbacks of RC which led to replacing with the WebDriver. So now that brings us to the third component, which is the Selenium WebDriver. This is the most important component. It is just a programming interface to create and execute our test cases. Of course, it's a successor of RC because there were certain drawbacks which I just mentioned, and we will be going in detail of what it were. So WebDriver, what the major difference what we see with the WebDriver is the architecture of the WebDriver is much simpler than RC for the reason that WebDriver interacts with the browser directly, unlike your RC where it needs an RC server to interact with the browser. So this gave a lot of advantage and edge over the RC. The fourth component, Selenium Grid. Selenium Grid is used to run multiple test scripts on multiple machines at the same time. With Selenium driver, you can only do the sequential execution. However, in real-time environment, you know that there is always a need to run tests on distributed environment. For example, say you have a web application and say you have automated around hundreds or thousands of test cases and you need to run them as a regression suite. And also one of the asks is that you need to run this on multiple browsers and multiple OS. Why? Since you have automated them and your application supports multiple browsers and OS. Now imagine the time taken to run these 1000 test cases sequentially with the WebDriver, right? It's going to take quite a bit of time. So what you need is to run this parallel on multiple machines, matrixed across the browsers and operating system, and that is where the grid helps you in achieving that. So grid has this hub and node concept and it helps in achieving the parallel execution which I just talked about. So you can check out our detailed video on Selenium Grid on Simplilearn. Alright, so now we talked about the components of the Selenium. So let's look at the different versions it evolved into. So when I talked about RC, I mentioned that this was Selenium 1 version. So now let's understand how this evolved over years and what it offers today. So when Jason Huggins introduced Selenium, the tool was called JavaScript program. He called it as JavaScript test runner. It had one major issue. Now that is something called as same origin policy. So what is the same origin policy? It says that a JavaScript when executed in a domain can access web pages in that domain only, and it cannot access any web pages in another domain. I will repeat it. Same origin policies dictates that a JavaScript is executed in a domain can access web pages in that domain only, and it cannot access web pages in another domain. For example, say every web page in say google.com domain like search, email, drive can be accessible, but nothing outside of google.com, like say if you want to access a web page in say Amazon or Yahoo, is possible to access. Why? Because of the simple reason, which is a security reasons. Now to overcome this, Paul Homan created something called a Selenium Remote Control Server. And why did he create that? He wanted to trick the browser in believing that the Selenium core through which you're going to run your scripts and your web application under test are in the same domain, with which you are able to achieve run your test on your web application without having to get into this issue of same origin policy. So this is what was a version 1 of Selenium, and we called it as Selenium Remote Control. And then what happened in 2007, Simon Stewart, he invented this WebDriver. Now why did he invent this? Because the architecture of Selenium RC was little complicated. RC required a separate server to talk to your browsers. So what he did was he removed the requirement of having a separate server in the RC, and this was the Selenium 2 version. Now since it was a transition phase, both the Selenium RC and the WebDriver coexisted in Selenium 2, while the WebDriver was still under development. And then what happened in 3.0 Selenium is the Selenium core, which is the RC, was completely deprecated and only the WebDriver was made available. So in this series of videos, we will be working with Selenium 3.0. And now Selenium 4 is already around the corner. So alpha is already released as of the day when this video was made, and I believe some of the features what the Selenium 4 is going to offer is they are moving towards W3C WebDriver standardization 1, and also there is going to be an improved IDE, the IDE which I just talked about, that it's a improved version of the previous IDE, and then an improved version of Selenium Grid also. So they might be doing a GUI based grid, right? So these are some of the major features expected in this version. Why Selenium WebDriver? So let's look at what led to replacement of Selenium RC with this WebDriver. For that, first we need to understand the Selenium RC and its shortcomings. As I said, Selenium RC is a simple tool to write tests for web applications in various supported programming languages like Java, Python, Ruby, and C#. And this is the architecture of the Selenium RC at a very high level. First, you need to write test scripts in any of the supported languages of your choice. So if you're more familiar with Java, you would be writing your test scripts, all your commands in the Java language. So before we start writing the test, one of the major required for the RC to run is your RC server. So first you need to start this RC server before you run even a single line of code. And this RC server is a separate application. And now what is the function of this RC server? This Selenium server or the RC server is responsible for receiving Selenium commands from your test script. It interprets them and then reports the result back to your Selenium test script. Now what are the Selenium commands? These commands are nothing but the commands written in your test script. These are called as Selenium commands. That is what the Selenium server does. Now after the Selenium server's function, let's look at how the browser interaction happens. The browser interaction happens through this RC server. This RC server uses a simple HTTP post and get request to communicate. And how does this communication happen? This RC server acts like a proxy. Say for example, your test scripts asks for launching a browser. This command from your test script goes to the server, and then this RC server launches the browser, injects its JavaScripts into the browser. Once this is done, all the subsequent calls, that is all the subsequent calls is all the rest of the commands which you have written after launching the browser, go to this RC server and then to the actual web server. So it routes, all the commands are getting routed through your RC server to your web browser. Upon receiving this instruction, so what does the code do? It executes these commands as the JavaScript commands on your browser. So once these are executed, the response from the browser or the results what you say are sent back to the RC server, and RC server is responsible for sending it back to your test script, and then the test results are displayed here. Now if you see this complete cycle from starting your command from your test script, talking to the RC server, then RC server talks to the web browser, it injects the JavaScript here, runs your command, takes back the results, sends it to RC server, and then back to this test script. This whole cycle gets repeated for every command which is written in your test script. And this is how your test case gets executed. Alright. So now everything is fine. So great. We are enabled to run the scripts. We are able to launch the browser. We are able to execute all the commands. So what was the problem here? Why was still RC not good enough? For the reason why the RC was still not good enough was, one, the architecture of RC is very complicated because of that intermediate RC server to communicate with the browser. So there is no direct interaction with the browser. This RC server needs to be installed before running any test scripts. That means it has an additional setup, because that is RC server is a mediator between your Selenium commands and your browser. The execution of the commands takes very long time. It is very slow. Why? Because we saw that every command written in your test scripts needs to make a full trip from your test script to the RC server, to the core, to the browser, and then back, which makes your overall automation test execution very, very slow. So how does Selenium WebDriver now overcomes this? This is a simple architecture of Selenium WebDriver. Even in WebDriver, we have test scripts. We have a web browser and a web server. However, we do not have an additional server for communication like the RC server, which we saw in the Selenium RC. This makes the architecture of WebDriver very simple. The Selenium WebDriver, that's one of the biggest advantages. The Selenium WebDriver does not use an additional server. Then secondly, it makes direct calls to your browser using your browser's native support automation. So since there is no intermediate server there, the browser is controlled directly from the operating system level itself. Now, due to this direct communication, the trips what we saw from the RC server to the browser and from the browser back to the RC server and to the test scripts, right? This was an indirect communication. Since this whole thing was avoided, the speed of test execution is much faster in RC. And this overall architecture of the WebDriver, if you see, it is much simpler than what the RC provides. So this was the major drawback from the RC, and this is where WebDriver replaced RC. Now, was that all because of the architecture? No, there were few other shortcomings with the RC. APIs in Selenium RC. A single function has several commands. Redundant and confusing APIs. RC is less object-oriented API. Though there are good set of APIs to work with, they are pretty redundant and confusing. For example, how and when to use a type key or a type command. Another example is the mouse commands. Click or to use click at, or when to use mouse at or mouse down. So this was getting pretty confusing for the developers. And to top it all this, every browser interprets the command differently, which makes your test cases brittle when it has to work on the multiple browsers. Developers had a tough time making their scripts cross-browser, and they had to add browser-specific code. Whereas Selenium Driver comes with a set of more matured and simpler APIs which are pretty straightforward to use. For example, a simple click to simulate a click action on any web element. Send keys, which simply means send the text to any web element on your web page. Scroll up or down on the web page, and so on. So we will see more of these commands when we actually start working with the WebDriver. Another difference is the browser support. Though both RC and WebDriver supports multiple browsers, RC does not have support for HTML unit, which is a headless browser, whereas the WebDriver supports testing on headless browser. Now, what is this headless browser? Headless browser is a browser which does not have a UI. It makes testing much faster because it does not need a real browser for testing. Now, to summarize all this, so if you look at the RC and the WebDriver comparison, which we talked about, RC is a complex architecture, whereas WebDriver has a simple architecture, for the main reason that WebDriver removed the need of having an intermediate server. RC, the execution of your test cases or your automation scripts, it's much slower than the WebDriver. RC requires a RC server to interact with the browser, whereas the Selenium WebDriver interacts with the browser directly using the WebDrivers. Also, we saw the APIs which RC provides, which are pretty confusing, and WebDrivers, we have much easier and easy to use APIs. No support for HTML unit browser, which is a headless browser. Selenium Driver also provides support for HTML unit browser. Now that we have understood what Selenium RC is and why WebDriver replaced RC, let's go another level deeper into WebDriver. So what is Selenium WebDriver? We know that the WebDriver in its simplest term is a tool or a programming interface to create and execute test cases on a web application. It supports multiple browsers, i.e. Firefox, Chrome, Opera, Safari, Edge, and it also has support for headless browser. So we will know in some time what is a headless browser. Some of the features of WebDriver. So while RC was introduced in 2004, WebDriver got introduced by Simon Stewart in 2006. WebDriver can run on any platform of your choice, Linux, Windows, Mac, and even if you have a Ubuntu machine, you can run your Selenium WebDriver. And what is this actual WebDriver? Is it an IDE? No, it is a simply a programming interface to run your test cases. And how does it work? The test cases are created and executed using web elements or the objects using web locators and WebDriver methods. So once we get into the demo, or once you start understanding how Selenium works, you will understand what are these WebDriver methods and the locating techniques which are used to perform these actions on web element. Selenium WebDriver is pretty fast. Why? Since the WebDriver interacts directly with the browser and does not have an intermediate server like RC. Each browser with which you want to work with has its own driver on which your application runs. And this driver is responsible to make the browser understand the command which are being passed from your script, like a click of button or entering some text in any of the input fields. Through your scripts, you tell which browser you want to work with. Say you want to do all this action, say on the Chrome browser. If you want to work with Chrome browser, then the Chrome driver is responsible for interpreting your instructions from your test case and executing them on the web application, which is launched on Chrome browser only. So like RC, WebDriver also supports multi-programming languages in which you can write your test scripts, like the ones which are listed here. Also, WebDriver supports different frameworks like TestNG, JUnit and NUnit. When we talk about the limitations of WebDriver, you will appreciate how this support for various frameworks and tools help in making the Selenium a complete automation solution for web application. Now let's try to know what is the architecture of Selenium WebDriver. WebDriver has 4 different components in it. One, we have the client libraries, or what is also called as language binding. Since I said Selenium supports multiple languages and you're free to use any of the supported languages to create your automation scripts, there are libraries available on Selenium website which you need to download and use them. Let me show you that. So let's go to my Chrome browser. So I have the Selenium HQ website already launched here. So guys, if you're working on Selenium, this website seleniumhq.org is going to be Bible. So everything and whatever you need to know and work with Selenium is available here. For now, we want to see the client libraries or the language binding. So for that, what you need to do is, if you go to the download section here, can you see here the Selenium client and WebDriver language binding? So for each of the languages which is supported, you have a client library which you can download from here. So if you're working on Java, you need to download the Java libraries. If you're working on Python, you need to download the Python libraries, right? So these are called as language bindings. So Selenium provides a lot of APIs for us to interact with the browsers. And when we do the demo, I will be showing some of those APIs. Now, what are these APIs? These APIs are the REST APIs. REST is representational stateful APIs, and everything for Selenium happens through this REST calls. The second component is the JSON wire protocol. So what is JSON? JavaScript object notation, and it's a standard for exchanging data over the web. So for example, you want to launch a web application through your script. So what Selenium does is it creates a JSON payload and posts the request to the browser driver, right? And where are these browser drivers? These are here. Right? And what are these browser drivers? These are a driver specific to each browser. So if you see here, you can see drivers for Chrome, Firefox, Opera, Safari and Edge, right? So we interact with the actual browsers here using these drivers. And how does this happen? This driver establishes connection with the real browser without revealing the internal logic of browser functionality, right? That's exactly the function of this browser driver. Now, what does that mean? Let's say we want to execute a test script. So what happens when the script is executed is an HTTP request is generated and sent to browser driver for each command in the script. And then the driver receives the request through this HTTP server and does all the execution on the actual browser. Once the execution is done, the execution results are just sent back over the same HTTP server to your test scripts. So this is the simplest form of the architecture of the Selenium WebDriver. Well, now as every tool has its own advantages and its limitations, so let's look at what Selenium WebDriver limitations are. Cannot test mobile applications, requires framework like APM. Selenium is for automating web application. It cannot handle mobile. Right? Mobile applications are different and they have its own set of automation tools. However, what Selenium provides is the support for integrating this APM tool. APM tool is one of the popular tool for mobile application automation, right? So it provides a support for integrating APM tool. So using APM and Selenium, you can still achieve mobile application automation. Now, when do you usually use this? In cases where, say, your application under test is also supported on mobile devices. So that means you need a mechanism to run your test cases on your web browser as well as your mobile browsers, right? And this is how you achieve it using Selenium. When we talked about components of Selenium, I said that the WebDriver can achieve only sequential execution. But in real time, we know that we just cannot live with this. We need to have a parallel execution on multiple machines and on multiple browsers. So this limitation of WebDriver is replaced by having the grid, which helps us in achieve the parallel execution. And do check out our video on more details on Selenium Grid. Selenium WebDriver has limited reporting capability. It can help create basic reports, but definitely we need more, especially when we are working on a big project. We need good reports to be created. So what it does is we have a support for multiple tools like TestNG, ReportNG, and even the extent reports, which you can integrate with Selenium and generate beautiful reports. Isn't it really powerful? Alright, there's another challenge what we have. These are amongst few of the challenges what I have put across here. There are other challenges also, but always there is a workaround to get through those challenges. So another challenge which we have mentioned here is Selenium is not very good with image testing, especially designed for web application automation. But then we have other tools which can be used along with Selenium to achieve any kind of image testing you want to do, like AutoIt and Securely. So same way, the way it provides a mechanism to integrate APM, so Selenium also provides a way for integrating AutoIt and the Securely tools. So if you look at all this, Selenium still provides a complete solution for our automation need. And that's the beauty of Selenium that makes it most powerful tool today for automation. Okay, so let's look at WebDriver in action. So before we do that, let's understand some of the basic browser commands and functions that we will be using in our demo today. The get commands. So there are 6 get commands to perform various actions on the browser. Driver.get. This is used to launch any website application. It takes a string argument and this needs to be a fully formed URL which you want to launch. Driver.getTitle. So this method fetches the title of the web page which you're working with. So for example, let's go to eBay. So if you just hover your mouse here, can you see the text there? Electronics, cars, fashion, collectibles, coupons and more, eBay. So this is nothing but title of this current page. And this command helps us to get the title. Get current URL. So to get the URL of any page is when you want to use this command. So this will be used especially when you're working with multiple web pages and you want to say print whatever the current URL you're working on the console. Get page source. This method dumps the complete HTML page source on your console. Actually, this is not really much used unless you really need to look at anything in your HTML pages. And then there are 2 more get commands related to Windows handles. These are used for handling multiple tabs and multiple windows on the browser. Now, we will not be dealing with this in today's demo. However, if you want to know the details of this command, these are available in our video tutorials for these commands. The next set of commands are the navigational commands. So these are self-explanatory and basically are used to navigate between the multiple pages of your web application. The first one, the driver.navigate.to, is very similar to driver.get. So both does the same function. And then you have navigate.back, navigate.forward and navigate.refresh. So this is used for refreshing your browser page. And then there are 2 commands, browser commands, which we use. One is the driver.close. So this closes the current browser window. So if you have got multiple tabs open in the window and you want to close a particular tab, so that is when you use driver.close. And driver.quit, what it does, it quits the entire browser session. Then there are few other commands. And some of the commands are listed here. However, if you see, there is a huge list of commands available in Selenium. And since we'll be using just a few of them in today's demo, I have listed here. So let's just understand these very basic commands which we will be using. Driver.findElement. Now, when you want to work with any application, what is that you need to do? You need to perform actions on the elements of the web page. And these are called as web elements. For example, let's go to our ebay.in. So on this website, say you want to search for JBL speakers. And what do you do when you want to search for this? You would identify the search box and you will enter the text JBL speakers, right? And then you go ahead and click on the search button. So this is the set of operations which you will do. Now for us to write this, and this is exactly what you need to do through your commands. For us to really write this text as JBL speakers, I need to know what this particular element is. Okay, so this particular input box is my web element which I need to identify. Similarly, if I want to click on the search button, I need to identify what this button is. And that's exactly is done by using driver.findElement. Selenium has multiple ways of finding these elements. It has 8 element locating techniques. And our future videos on Selenium do cover these 8 element locating techniques very much in detail. So for us, right now we'll be using couple of them. So one is with ID and one is with a link text. The next one, the send keys. So as the name indicates, it is used to send a certain text to any web element you have identified or you want to work with. Like in this example, as I said, since we want to search for JBL speakers, right, I would be basically sending the text JBL speakers to this web element using send keys. Click. So after entering the text, what we need to do, I said, we need to click on the search button. So for all such actions, we have methods defined in Selenium, and one of them is this click. What this does is it just clicks on the web element or the button which we want to work with. So now with these basic commands, let's go ahead and start writing our code for our test case. So what is the test case we are going to write today? So this is my use case today. So use case 1, as a user, I want to log into eBay application, search for JBL speakers, and then I want to check the today's deal. So there is something called as the day's deal. We will go and click on that and see what are the deals available. I have another use case here. What says is, from this website, from wherever we are, right, navigate to the Simplilearn website and navigate back to the ebay.in. So this, using this use case 2, what I want to show you is how do we use the navigational commands. And my third use case is, from the ebay.in, I want to print the page title and close the browser. So with this, we are trying to demonstrate at least few commands from each of the categories which we talked about. So I will be using Eclipse for writing our test scripts. And if you want to know how to get started with Selenium, how do we install Selenium, you can refer to our videos on installation of Selenium by Simplilearn. Okay, let me go to my Eclipse. So in Eclipse, what I have done is I have already created a project called Selenium Demo. And in this project, I've gone ahead and created a Java class in which we would be writing our test case. So the Java class which I have created is ebaysearch.java. And also what I have done is, if you look at few import statements here, I have imported all the required Selenium jars here. So if you look here in the referenced libraries, the way after we work with Java here, right? So Java is the prereq for your Eclipse. So you already have the Java libraries available here. So what I need to do is I also need to import the Selenium jar files, and this is the list of Selenium jar files which you will need to work with the Selenium, and this I've already imported for you. Then another thing what I do as following a best practice is, instead of writing all my code under this main function here, what I do is I create methods for each of the use case or the test case which I'm writing. So same thing, I'm going to do that today for all the use cases which we have taken for this demo. Now let's get started. So what is the first thing which we need to do? The first thing what we need to do is you need to declare your WebDriver. So which I've already done here. I've said WebDriver driver. And then I need to launch the browser before even I go into ebay.in and start performing the other test step. Now for me to launch browser, this is one method which I've already written here. So let me walk you through this. So there are multiple steps we need to follow for launching the browser. The first thing is set system property. So let's understand this particular command here, the one which I have highlighted. So this is used to set the property for your Gecko driver. Now what is a Gecko driver? If you remember, while we are talking of WebDriver architecture, I said for whichever browser you want to work with, you need to tell the WebDriver as which browser is what you're going to test with. And in my case here, I'm going to be using Firefox browser. And also if you remember, while explaining the architecture, I said every browser has its own driver which you need to download and install. And where is this driver? Let's go ahead and see that on the seleniumhq.org. So let me go to my Chrome browser. I already have a seleniumhq.org website open here. Now on this website, in the download section, if you go down, you can see something called as third-party drivers, binding and plugins. And here you would see a list of all browsers: Gecko driver, Chrome, Opera, Edge, right, and HTML unit, which is headless browser. So all these browsers which Selenium supports listed. And for each of this browser, we have a driver associated with it, which we can download. So if I want a Gecko driver, what I need to do is I need to click on this latest link. This will take me to the latest web driver which is available. So depending on the operating system which you're using, right now I'm using a Mac, so I've already downloaded it. So once you download, you need to place it in a particular directory. Okay, so let's go back to this. And now if you see this path here, what I'm highlighting, this is where I have kept my Gecko driver. So this Gecko driver, what you see is my executable. So if you're using a Windows machine, it will be geckodriver.exe. So this is the driver which we'll be working with. Now coming back to the system.set property. This particular method or this particular command is used to set your driver property. It is a key value pair and you will need to know which keys depending on which browsers you're working with. Since I'm working on the Firefox browser, the key which I need to set is the WebDriver gecko.driver. If I'm using Chrome, what I simply do is I have a key called Chrome and then I would set this path to Chrome driver, and this is exactly you need to do. So for you to even before launch the browser, you need to do this set property. So let me change this back to gecko. So now we are clear till here. Now what is the next command which we need to after setting the property is after setting the property you have to instantiate the WebDriver, which is done by using this particular command driver is equal to new Firefox driver. So once you do this, your browser is going to get launched. Then once your browser is launched, what is the next step you do? You would be launching the application on which you want to perform your test, and that is done by using the command which we just saw now, driver.get. Now since I'm going to be working with ebay.in, I have just said driver.get and the URL, fully formed URL. So this particular method is going to help me launch the Firefox browser and also launch the eBay application. Now advantage of using methods like this is you can reuse these methods in every test case which you're going to write, or you can make a common function of this and just call this function in any of your test cases. Now for me to call this method, what am I going to do? I'm going to create an object of this class. Let's do that. Object is equal to new, done, and then I need to call this method obj.launch browser. Good so far? Alright. So now let's get to the first use case. So let's go back to our presentation and see what was our first use case. Our first use case was that we want to launch the eBay application, which we have already done in the launch browser method, and then we want to search for JBL speakers. Now for that what we will do? Let me create a method here. So I will call this method, I'll say public void say search product. That's my method name. So I have created a method called search product. Now what I need to do is I need to search for JBL speakers. So for that, let me go to my Firefox browser and I need to first identify the search box element. So for identifying what I do, I go to this website, I go to this element and then I say inspect element. So now I know that there is already an ID which is unique to this particular web element available. So I'm going to make use of this ID. I need to go to my Eclipse. So now here I'm going to use the find element method. So for that I'll say driver.findElement, I'll say by.id and it's a string argument. I'll just copy the ID which I copied from the Firefox browser. And then what is the operation I need to do here? I need to send keys. And what is the keys I need to send? The product which I'm searching for. I'm searching for say JBL speakers. Done. So with this command, what it will do is it will enter the text JBL speakers in the search box. After doing this, I need to click on the search button. Now similarly, I need to identify what is the web element search. For this again, I already have a unique ID here, which I'm just going to simply copy from here and use it in the find elements. So same thing I will do, driver.findElement by.id, and this is the ID of the button. And here what is my operation? I need to click. Done. Good so far. Now other thing what we also need to understand here is, so what happens sometimes depending on the websites, some websites are pretty slow even while loading the page and some are pretty fast. Now for the Selenium to work without having to fail or without having to create exception of not finding the elements, it is good to use certain waits. So why we need to use waits is, say for example, when after entering the JBL speakers and after clicking the button, it's going to take a while for it to search for JBL speakers and give us that web page with the list of JBL speakers. And even before we start doing the first command, like searching, once we load the page, it takes time for the complete page to get loaded. Okay, so Selenium provides a lot of synchronization commands, right? And it's a very big topic on its own, which needs to be used, especially when you're working with any kind of website. Okay, so there is a since it's a separate topic, there's a separate video which will help you understand how to use the synchronization. Now, for the demo purpose, we have certain wait commands which can be used, and that is exactly which I'm going to use here. So that is called as thread.sleep. So what this does is, say I'm going to give 2000 here. What this does is, this basically, this script waits for 2 seconds, right, after the previous command is executed, and then it executes your next command, which is our find element. Now this is showing us an exception because it wants us to add a exception here, add throws declaration, which is interrupted exception. Okay, we need to do this. So once we are done, okay, we have done the click. So let's see what is the first use case which we had. Have we covered everything in the first use case? Okay, we said log into eBay, done, search for JBL speakers, and then I want to check on the days deal. Okay, we need to do this also. So for that, again, what we need to do is we need to go and identify. So what I will do, I'll use the inspector here and look for this daily deals. Now this is a link text. It's an anchor tag. So what I will do, I'll copy this link text, daily deals. I'll go to my Eclipse. Now after this, I will give another thread.sleep of say 2 seconds. That should be more than enough. And then I'll say driver.find element. Now this time I will be using something called as link text. And here as an argument, as a parameter, I'm going to paste the daily deals which I just copied. And then what do I need to do on this web element? I just need to do a click operation. Done. So the complete first use case we have covered. So what we will do is let's go ahead and execute this first use case. Now I have launched the browser here. I also need to call this method, which is search product. Now again here, since we are doing that add throw declaration on the method, we also need to do it for the main function. Exception added. I'll save this, and for me to run this, what I do is I simply right click on that and I say run as Java application. Now we see that our Firefox browser is launched. The eBay application is also launched, and JBL speakers entered and search clicked. So we have a list of JBL speakers here. And now as per our test case, it has to go on the daily deals, which it just did. Great. Alright, so we have our first use case working. So right now I have not used the browser.close. So what I will do is I'll just manually go and close this browser. So we are done with our first use case. Now let's move to our second use case. So what second use case says is from wherever you are, right now we are on the ebay.in, navigate to Simplilearn website and then navigate back to ebay.in. So let's see how to handle that. So let's go back to my Eclipse here. Now let's create another method. Instead of saying test case 2 or use case 2, we'll give a more meaningful name. I'll say navigate, since we are exercising the navigate commands here. I'll just use this method. Now, so we have done the click. So I need a quick thread.sleep here because I want it to wait so that we can see. Otherwise, it's going to be so fast, we will not be able to see what are the operations it did. So I'll just add a thread.sleep before we start navigating to the new website. Okay, thread.sleep, and I guess 2 seconds should be good enough even here. So same thing, we need to add the exception. So add throws declaration and interrupted exception. Alright, done. So now what we need to do is we need to navigate to the simplilearn.com. So for that, first I need a fully formed URL of the website which I want to launch. Okay, so let me go to, and here instead of ebay.in, I would say let's search for Simplilearn. I have it here, and I just pick this from here, https www.simplilearn.com. So let me go to my Eclipse, and here we saw another command like get. We said navigate.to. So let's use the same command. So I'll say driver.navigate.to, and I'm going to use to URL because, or you can just use a string because this is going to be a string variable. Now what does this command do? This will simply navigate to the URL which we have specified here. Now here again I'm going to give a quick sleep here so that we are able to see the website before we navigate back to the ebay.in. So I'll use a thread.sleep. This time probably I'll give a 3-second wait. Then what does our use case say? Let's go back to use case once and check. And it says and navigate back to ebay.in. So that means I need to use a driver.navigate. Can you see the list of commands here which provide which the navigate class provides? Okay, and the back is what we need to use so that it comes back to the ebay.in. Done. So far so good. Now let's do one thing before even we go to the use case 3. Let's execute our test case till here. So what I'll do, I'll save this program, and after search product I will call navigate method. Okay, I will save this and then right click, run as Java application. So our Firefox is getting launched. It has launched. The eBay application is on. So it's going to first find the JBL speakers, click on the search. We have a list of JBL speakers. Then it will click on the daily deals. Yes, it is doing that. We got the deals of the day. Yes, it is now navigating to simplilearn.com. Now after 3 seconds, it should take me back to the ebay.in. Okay, cool. So this was the last page where we left before we navigated to Simplilearn, right? And that is where we have come back using the back command. So now let me close this again because I have still not incorporated the driver.close. Now let's look at the use case 3. Now use case 3 says once you're back to ebay.in, print the page title and then close the browser. Cool, very simple. So So we'll go back to Eclipse. Probably in the same method, what I can do is, once I'm back here, I will say, so I have to use driver.getTitle. That was a spelling mistake, driver.getTitle. Okay, this is the method which we are going to use to get the title of the page. Now, we also said that once we get the page title, we want to print it on the console. Now, how do you print it on console? You just use a sysout statement. So instead of just writing this, what I will do is I'll directly write a sysout statement, system.out.println, and I'll write a text as the title of this page is, and then we will concatenate with driver.getTitle. As simple as that. And after I do this, I will simply call, it's actually, I want to call the driver.list, but it's always good to create a separate method. So I'll say public void close browser method. And here I'll simply say driver.quit. You can use close or you can use quit. So let me demonstrate how do we use quit here. Now I need to call the close browser. So simply what I'll do, I'll say obj.closeBrowser method. Okay, so this completes our all three use cases. So now let's execute all these three use cases now. And we should be able to see the title of this page on the console. So same thing, what I do is right click, run as Java application. Okay, same thing, our eBay is launched now. Send keys the JBL speakers, click on search button, executed, and then it has to click on the daily deals. That it is done. Moves to Simplilearn website. Now it has to come back to ebay.in and we should be able to see the close browser, which just happened at the snap of the finger, right? So now for us to know whether it really happened, what we have done is we have printed the page title. Okay, now can you see here? We have the complete page title printed here. All right, so let's go back. So let's look at what are the key takeaways from that. So in this overall video, we saw what was Selenium, what is Selenium WebDriver, what were the limitation of the remote control, which is Selenium RC, how did WebDriver replaced it, and we went into learning the architecture of the Selenium WebDriver, which is very important for us to understand because we will be working with the WebDriver to create all our automation scripts. And then, as I said, every tool has its own limitation. We also talked about limitations at a very high level and also as there are workarounds. And then I also demoed some of the browser APIs and their usages and some of the methods which we use with Selenium. This video focuses on teaching how to use Selenium IDE for creating automation scripts. What does this video cover? 1. A brief about Selenium and where the IDE actually fits in. Very recently, a new version of IDE has been launched, so we will look at what it has to offer. How does the record and replay tool work? And then let's understand the components of this IDE interface. We will work with few commonly used Selenium commands. And then, since we are using the new IDE, let's look at some of the key features of the Selenium IDE. And like every tool has its own limitations, we will also look at what are the limitations of Selenium IDE. So what is Selenium? So Selenium is an automated testing tool used to test web applications across various browsers. In my previous video where we have covered the complete basics of Selenium WebDriver, I have explained each and every components of the Selenium suite. So Selenium IDE is one of the components in the Selenium suite, right? And other components of the suite are Selenium RC, WebDriver and Selenium Grid. So in this video, we will be looking in detail about how the Selenium IDE works. So what is Selenium IDE? Selenium IDE was developed way back in 2006. It was created to facilitate a simple record and replay of the test automation. So record and replay tools were pretty much in vogue during this time. And the main advantage of using such tool was an automation engineer was not really required to know any knowledge of programming. He could just use this record replay tool and create the automation. And this IDE was available as a Firefox extension. So for one to use it, you need to just go ahead and install the extension on Firefox and then use its recording and record the steps of your test execution. It is a very simple interface which helps in building the automation scripts. And how this works? You just need to start the recording on IDE, perform your test steps on the browser, and these steps gets recorded in the script. And then what you could do is you could export the script into say a WebDriver or a JUnit, Ruby or any JavaScripts, and then you can use it. Now, however, the record and replay tool is not a very powerful automation tool, and hence this IDE is mainly used for prototyping or you could say demo purpose. Now, since Selenium WebDriver itself offers such powerful capability of creating robust test scripts, IDE more or less remains as a prototyping tool only. So in short, as I said, IDE is a part of overall Selenium set of tools, and mainly developed to speed up the creation of test cases. And what is the other advantage of that? One need not really have any programming knowledge to use this tool. And mainly it is used for writing some quick test for demo purposes. Advancements with the new Selenium IDE. Back in 2017, Selenium IDE development was completely stopped. The last supported Firefox version where this IDE was available as a plugin was Firefox 54. And from 55 onwards, the complete integration point was removed, or it was completely broken. However, recently, Applied Tools helped revamp much of the Selenium IDE code. They basically rewrote the whole IDE code, and then now they have released a new version under the Apache 2.0 license, and it is completely managed by the Selenium community. Now let's look at some of the features of this. Now traditionally the Selenium IDE was only a Firefox plugin. However, the new IDE supports both the browsers, the Chrome and the Firefox, and thus making it cross-browser. So before even we start looking at the other features of the Selenium IDE, I would like to show you how do we install this Firefox plugin or the Chrome extension. So for that, let me go to my Chrome browser. So in the Chrome browser, what I'll simply do is I'll search for Selenium IDE for Chrome. So then let's go to this chrome.google.com, and here you will see it as an extension, Selenium IDE. So go ahead, click on Add to Chrome. So this will add this extension to your Chrome browser. So now it says Selenium IDE has been added to the Chrome. So how do you make out if it is added? So you can see this particular icon here which says Selenium IDE. So this is the way you can go ahead and install it on the Chrome. Now on the Firefox, I have already installed it since we want to use the Firefox as a browser for all the demos in this video. So here again you can see the Selenium IDE. So if I click on this IDE, it is going to open a window for me, and the first window when it opens, it says either open a new project or open an existing project, or simply you can start recording a new test case, in which case it creates a default project for you first. So what I will do is I'll say open an existing project, and I've already got a project created. So let me go to my folder where I have this project. So I have this project created and I've opened it. I also have a simple test case written. Now what this test case does is, let me show you here. It simply goes to google.com, and then here what I'm doing is I'm searching for Selenium HQ documentation, and then I click on this site which says seleniumhq.org and docs. So which should take us to this particular website where the documentation is available. So this is a simple script which I have tried to write it in this IDE. So let's keep both these windows open and let's go back to our presentation to see the first feature of this Selenium IDE. The first feature, what it says is improved locator functionality. What are locators? So these are nothing but the techniques used for locating your web elements on your website. Now for example, in our example here, now the type here, the type which says name equal to Q. So name equal to Q is a locator. Now this is a locator of what? Initially, if you saw, I went to google.com and this is the search button which I used, right? The search text, and then I said enter. So this is nothing but your web element for which the locator is name equal to Q. Now what happens in IDE is when you record it, it has taken the attribute name and it has recognized this particular web element using this attribute. However, it also has a feature wherein it also records its multiple locators available for that particular web element. For example, it also has a CSS locator, it has an XPath locator. Now how does it help here? Say for example, tomorrow this particular attribute name, right, for the search box, if it changes, then what IDE does is when you execute this test script, it falls back on your other locators mentioned here in this dropdown. And then if none of these locators work, only then the test case is going to go and fail, not otherwise. So how does this help? This helps to make the test cases more robust. Otherwise, having just one locator, there is high possibility that test case might break or become pretty brittle as and when the web elements change their attributes. So this is what the locating techniques are. And that is how they have improved the locator techniques in the functionality in the new IDE. Now what's the next one? Parallel execution is possible with this new IDE. So the first IDE, the traditional one, the parallel execution was not possible. However, this is a new feature which has been added. So we will be looking in detail how to work with this parallel execution later in this video. Next is you can add control statements in your scripts. Now what are these control statements? Like if else, while loops, for each loops, and even the switch case. The earlier IDE also had this provision, but you had to install a plugin to enable the use of this control statements. And now with this new IDE, it is available out of box. Automatically waits for page to load. In any automation, synchronization between your application under test and your automation scripts is very important. Your script should not run faster than your application. Otherwise, your scripts are going to start failing. So it is necessary to have enough load times on the operations of your web elements and also enough load times on your page. Now this load time ensures that all the elements of your web pages and the page itself is loaded completely before even a single line of script is run. This new IDE takes care of providing that enough wait time. And also you have a global set speed option which you can use to control your execution of your scripts. So that is something which I will show you now. So if I go back to this, so can you see this clock icon here? So it says test execution speed. So what you can do is, right now it is set to the fastest, so I can actually control the execution speed here. So right now I've just kept it a little slower. So let's see how our test scripts run. So you'll be able to see a remarkable difference when I slow down the complete speed of this. So now do you see how slow it is? Initially when I ran it, you were unable to see what I entered in the search field of the Google, right? So now it's really taking time on each of the steps which we have mentioned it. So now it is executed successfully. So next, it supports embedded code. You can run a simple JavaScript from your test script, right? And how do you run that? By using a simple command called as execute. Now let's see how do we do that. So let's take the same example here. Now, after clicking this, okay, so this is our IDE. So what I will do is I'll first execute this test case, and then in the end, where I will show you how do we add a simple JavaScript and do some function. So let me get the speed back to a little normal because we do not want to waste too much time. So I'll just play the script once. So now we are in the Selenium documentation. Now if you look at this page, this is a pretty long one. So now I'm going to write a simple JavaScript wherein I scroll down towards the end of this page. That's all I'm going to do. Now for me to do that, what I can do is in my script itself, I can just add another line here. Okay, here I will say add a new command. Here I'll say execute script, which is my command. And what is the script which I want to execute? It's a Java script which I'm going to write here. I'll say window dot scroll by, and I'm just going to mention some coordinates here. Start from 0 and I'll say 1500. Okay, this is all my code is. And now I'll simply run this test again. Let's see what happens. So it's going to the documentation now. It's clicked on the link. Okay, it's moved down. Do you see this? Initially, it was right here on the top of the page. And once the JavaScript was executed, it brought me somewhere to the middle of this page. Okay, that is how you can insert snippets of JavaScript, and it has to be in context with your currently selected window. Okay, and that's how you run it. Alright, let's go back to our PPT again. What's the next feature? So every IDE has a debugger which allows step execution, adding of breakpoints. Now, apart from just having a breakpoints or adding the step execution, there is another feature which it provides called, I will show you that, which is called as pause on exception. So let's close this window and let's just keep this IDE window open here. Right? So can you see here pause button? It says pause on exception. So what it does is, if you enable this button, okay, and when you're running the script, so if at all there happens to be an exception in your script, it stops the execution at that particular exception for you. And we will see this in detail when we look at complete debugger for the IDE. Can be integrated in CI. Since you can execute scripts from command line, right? We also talked about the parallel execution, and you can also export the scripts to any of the programming language you want. So since you can do that, these scripts can be run from command line, and hence they can also be integrated with your Maven project, and through Jenkins you can run it. And that's how you achieve your CI. Working principle of Selenium IDE. Selenium IDE works on a very simple principle. One is the recording. It records user interactions with the browser, and which forms basically your IDE script. And using this IDE script, which is a recorded script, you execute the script and verify and monitor for its stability and success rate. And thirdly, what you can do is you can simply save your recorded script for your future runs or regression testing. And these scripts can be saved either in the form of an IDE project itself, or you can also export these test scripts into the form of a JavaScript or your Ruby scripts or even the WebDriver scripts. Now let's look at the components of this IDE interface itself. The first one is the menu bar. So let's go back to our IDE window. So here in the menu bar, what you can see is a project name. So either you can edit the project name here, or you can simply create a new project, open an existing project, and save the current project. Okay, so these are all the options available. And since we have already created a project here, I will not be showing how to create a new project, so that we can do it little later. Now next one is the toolbar. So this is the toolbar what we have here for the IDE. Now there are multiple components in the toolbar. So let's see one by one. So it says run all test. Now if you have multiple test cases written, okay, so this is an option where all the tests can be run one after the other. This is to run your current test which the focus is on. So currently our focus is on search test. So if I click on this button, it is going to execute the search test for me. IDE has this debugger option where you can do a step execution, right? You can do step-by-step execution using this option. We'll see how to do that. So for example, let's say we start from here, okay, and I click on this. So what it does is basically it has just executed the first step for me. So let's keep this side by side so that we can observe the complete execution. Now if I go and press on this again, step over current command. So that is the next command it is going to execute. Now it says type into this. Alright, so now you can see this Selenium HQ documentation. Okay, then again I say step, send keys, which it said enter. And then it is going to click on that documentation, which it did. And now we have a script written which scrolls down on this particular page. So let's execute that, and that is what it is. So this is how the step execution happens. So let's close this window and let's come back to our IDE window. Then we have buttons here where you can say record or you can stop recording. Okay, then you can pause the execution, and then there are other options available for disabling breakpoints. So basically you can add breakpoints anywhere here. So for example, if I want to add a breakpoint on the click here, so what I have to just do is I have to just click here. So this adds a breakpoint. And if you want to remove all those breakpoints, you just say disable those breakpoints. So when you run the script, even though you have a breakpoint available here, for that particular run, your breakpoint will be disabled and your execution will not stop at this point. And let's enable them for now. And what we will do is we'll just run the script until there. So now it has stopped here at this click. Now from here, either you can execute the rest of the test case by just clicking on this run button, or you can stop the execution. Okay, so for now what we'll do is we'll just stop the execution. So once you stop the execution, you will see that this is in red, which means that this particular line was not executed or it failed, either of the things, because you have aborted at this particular line. And the rest of the things what you see in green, it shows that all these test steps have been executed successfully. So what is our next component? Let's come back here. So we saw the menu bar here, we saw the toolbar, we saw start and stop of recording, address bar. Now what is this address bar? So this address bar is where you actually write your URL from where you want to start your recording. And as and when you start writing more and more test cases, it keeps a complete history of all the websites which you are working on. Next, then we have a test script editor box, which is this. So let me just minimize this little bit. Okay, this is nothing but your test script editor box, and this is where all your script steps are, all your interactions are recorded. Now there are 4 attributes in this. Okay, can you see a command? Now command is nothing but the actual operation or the action performed on your web element. So there are multiple actions you can perform. Like in this case, we have something called as open, we have got type, we have got send keys, and we have got click. So these are all the Selenium commands which are available. And then we have something called as target. Now this target is nothing but the web element on which you want to perform the action. And now this target, as I said earlier also, it is identified by multiple locating techniques. And if you click on any of this, like we looked at the name here, now similarly, the website which we are clicking on, if you look at it, there are multiple locating techniques which are available here. So the one right now which is being used is the CSS identifier. You can also have XPath here, which is a relative XPath. So these are all the locating techniques, and this is which is applied on the target. Value. So value is an optional field. So you can send any value to your web element. For example, in this case, where we are sending the value, which is our text, which is Selenium HQ.documentation. So this is the value which I want to send it to as a search text to my google.com. And then comment or the description. So here you can mention any description about that particular line which you have recorded. For example, I can say here, sending search text to the Google search input box, and this gets recorded here against your instruction. Now let's look at the test case pane. Now test case pane, that is here. So if you look here, now it contains all the test cases which you have recorded. Now there are multiple things here. One is your tests. say I can always go ahead and create another, say test case 2. Okay, I can add few more test case here, test case 3. So all these test cases are here. Now I can also have a test suite. Now there is already a test suite which I've created, which is called the Google Suite. And now if I want to add test cases under this, what I can do is I can just say add tests. And now I can add any of these tests which I just created under this test suite. So say I've selected the first 3 and I've added it. So we have test suite, we have tests here, and then executing. So executing is basically, it shows the particular test case which is currently in the execution mode. So whichever test case we run, you will see all the test cases listed here which have been executed at that point of time. That is your test case pane. And then we have test log and reference. This is a very important window which you need to be aware of. Now here, this is a running log. So as and when you are going to run your test cases, the every instruction, the every test step, as and when it runs, it is going to log here, whether it has passed, whether it has failed, whether the command was executed properly or not. And this is how it records it. It's a running log. Also, there is something called as reference tab. Now, for example, just go ahead and let's select one of this command which you have written here, which is send keys. Now, this reference, it will show you the complete description of the command and how to use that command. So say for click, it says reference is click locator, clicks on the target element. It gives you a complete detail of what exactly the command does. Let's create a test script now for say Amazon.in. So let's go back to our IDE. What we will do is we'll create a completely new project. So I'll click on the create new project. Are you sure you would like to without saving it? Yes, proceed further. And let's give the name as Amazon project. Now in this new project, what I will do is I'll say I'll add a test and my test name is search iPhone. Now basically what is the use case which I'm going to automate is I will launch Amazon.in and I will search for iPhones. And once I get the iPhones, let's verify the title of that particular page. Now just the simple steps, we'll go ahead and do that. So for that, first what I need to do is I need to enter the URL. Now this URL needs to be a fully formed URL. So for that, what I will do, I'll first launch Amazon.in on any browser. I'll just copy this URL and I can close this browser window. And in this URL address space, I would say Amazon.in and I'll say enter. And now I would click on this recording button which says start recording. So once I do this, what it does is it launches the web page with Amazon.in and from there I can start recording my script. So let's do that. I'll say record it. So let me just keep this window side by side so that you can see what is happening on the IDE window here. Now here, what I will do is I'll click on the search and I'll say iPhone and I will click on the search button. And here I will also click on this bestseller. Once I'm in this window, I'll say right click. Now, when your Selenium IDE is in the recording mode, you will get this option here which says Selenium IDE and there are a lot of options here which you can select. Now for this particular moment, what I want to do is I want to assert the title. So I'll just put an assertion point here for assert title and then I will close my browser window. Now let's see what are all the commands which it has recorded. Let's go one by one. Right, so it is done. It is opening the Amazon.in. It is setting the window size. Fine. It clicked on the to search window button and then iPhone is what we are searching. And then it said submit it. It's basically clicking on that button. And then we said we also want to open the bestseller link. And here is our assert title. Right. So it's a very simple test. So let's go ahead and execute this. Now, since I also have a close command here, this script is going to execute so fast that you will not be able to make out all the steps what we have written. So for that, what I will do is I will comment out this line. Now, how do you comment out any command here? Just select the command and can you see here enable and disable command? Just click on it. So now your command is disabled. Also, what I will do is I will reduce the execution speed so that you should be able to see exactly what is happening. So let's go ahead and execute this test first. So I'll say run current test. Okay, I have not stopped the recording. So that is the first thing. After closing the window, I also need to click on the stop recording. Now your script is ready to be executed. So let's go and run the current script. Again, I'll just bring this side by side so that you can see each of these commands being executed here. Okay, it has searched for the iPhone. It's clicked on the bestsellers and it has done the title assertion. Now, if you look at the log here, as I said, see every step as in when it was executed, it has been logged here. Can you see here? And it puts an OK and it color coded in green, which says that this particular command was executed successfully. Now let's go ahead. Now this is what we did by simply recording all the steps from the browser. Now one more thing what we will do is, say I want to continue recording here, right? I've not completed my test case. So what you can still do here is, you can come towards the end of the script and press on record button again, and then you can continue recording from here. Now say for example, after the bestsellers what we have got, say I want to click on say hot releases, hot new releases. So I do that. Okay, it says it has recorded the click, and then I want to stop the recording. Just the another step is what I wanted to add. Now it has stopped the recording. So can you see this new line which has got added? So that means you really need not restart recording all the steps again if you want to add something in the middle of your script. You can always go towards the end of the script or anywhere in between, and you can add more commands there, or you can record anywhere in between the script. And that is how this does. So let's go ahead and again execute this. Then I will show you another feature of this. Okay, it's done the title assertion now, and it has also clicked on hot new releases. Done. Now let's say for example, I need to add another command here. Now instead of going ahead and using this recording, what I will do is I'll manually add certain command here. Say for example, let's go to this Amazon website and say you want to click on this cart. So let me add a command manually here. So what is my command? My command is click. And then what is that I want to click? I need to identify that web element. For that, I can use this here which says select the target in the page. So I click on that and I simply select this target, which is my cart. And that is all I need to do. So my command is written there. So I'll just simply go ahead and execute this again. Let's see what happens. So let me close this window here. Okay, let's run this test cases. Bring this window to the side. So now you can see one by one the instructions being executed. Okay, the iPhone has been searched. The bestseller has been clicked, assert title. So it says your shopping cart is empty. So that means it is successfully able to click on the cart. So now with using IDE, there are multiple things you can do. You can simply record your script while you are running your test case. You can add a command all by yourself. You can stop recording anywhere and again restart from the same point. Now we have our complete test script ready. Now let's go ahead and save this. So how do you save this? Simply go here and save your complete project. So all the projects from the IDE are saved as .side file. So let's name this as Amazon project and I will save it. So if I show you in my Finder how it looks like, this is the project we created. So it always stores with the file extension .sid, right? That is Selenium IDE. Now, also I said you can export test cases into multiple format. So search iPhone is my test case. So what I can do is I can just say right click and I can say export. Now right now you can see only 3 options. It says Java JUnit, JavaScripts and Python. However, the older IDE had multiple options of export, which had even the WebDriver scripts and also the JavaScripts. This is still in works and they would be adding more support for other programming languages here. So, but for now, the only options what is available to us is Java JUnit, JavaScript and the Python. So let's go ahead and export this into Java JUnit. So it's just going to simply save it as .java file. So let me go here. In the IDE test, I'll save this file. So if you go back to my Finder, you can find our search iPhone test.java. So you can open that Java file and you can see here. It's a simple JUnit test. It is exported into. So if you have an Eclipse IDE, you can use this test and execute it from your Eclipse IDE. Selenium commands. Selenium commands can be broadly classified into 3: action commands, accessors, and assertions. What are action commands? Action commands are the commands which interact directly with the web elements on your application. So let's look at what these commands are. So if we go back to our previous example where we had written a test script for Amazon.in. So if you look at all these things like open, set window size, click, type. So these are all nothing but called as action commands. And if you go here, you can see, let me do one thing. So let me just come to a blank line. And now let's look at the list of commands. So you have a whole list of commands here listed in the alphabetical order. Like add selection, there are multiple assert commands which is made available to you, and then there are set of commands where you say click or click at a particular location, closing the browser, using a debugger command, double click, drag and drop, echo. I'll just explain how to use an echo command. So this is a command which is not used on your web element but something which you want to say display on your console. And then there are if-else statements which are used as commands here. Then you have something called as execute script for you to execute any say JavaScript or any different script which you want to execute from your test script here. And then you have few mouse commands here. Open, which is what we use for opening a URL, pause, and so on. So there are multiple commands which you can look at and try to use these commands in your script. So these are all called as the action commands. So let's go ahead and use this echo command and see what it does. So now in the same script, what I will do is towards the end of the script, I'll just add this command. I'll say echo and say I want to just display a message saying that this is the end of the script execution. That is all I want to do. Now I'll just go ahead and run this, and what we want to observe here is how this particular message what we have given here is displayed on the console in the log. So now if you observe here, so go to this last statement what we have. So it says after clicking on the card, it said echo, this is the end of the script. So this is what we displayed using the command echo. Okay, so this is how you can use the echo command. Another feature here, what you can do here is, now say for example, I just added a simple echo statement here. Now for me to execute that, what I did was I executed the complete script. You really need not do that always. Instead of that, what I can do is I can just come to this particular line. I can just say right click and I can say play from here. So what it does is from this point, it is going to play the script for me and not right from the beginning of the script. So I'll show you how. Now with this command, if you look here, see it started running the script here. It says running search iPhone. And then it executed only one command which says echo, this is the end of the script. So this is also possible to do with the IDE. Accessors. Accessors are the Selenium commands that examine the state of an application and store the results in a variable. So these are those commands which allow the user to store say certain values into your user defined variables. And these stored values can be later on used either to create assertions or you can have some verification points created. So let's see some of the store commands in action. So I have few store commands here which I'll be demoing. So first one is a store. So simply using a store command, you can store any kind of user defined messages in a variable. And then after that, you can either use it for displaying it on your console or you can do some assertions with that. Similarly, store title. So you can store the title of any of the web page under test, then store text. So store text is basically used to capture the text attribute of any web element on your web page and store it in a variable, use it as an assertion point. Store value. So store value again is used to store the value attribute of any web element. Like, so you have a lot of web elements on the web page and say one of the attributes is what you want to do an assertion on. So what you can do is you can use the store value command here, get the value attribute of your web element and store it in a variable. So let's see all these commands in action. So let's go back to the same example. So we have this Amazon test script example. So what I'll do is say instead of using Amazon, let's do one thing. So let's create another test case itself. So I'll go here, I'll say add new test and I will name this test as accessor test. And we will use the same Amazon site here. I'll say click on start recording, keep this window side by side. So first we will look at store title. So simply what I need to do is go to this Amazon site which we have launched, right click on this, go to the Selenium IDE and you have multiple options here. So go ahead and select store title. So once I click on that, it is going to ask me the variable name where I want to store the title of this page. So let's create a variable here. I'll say var title and I'll say okay, done. Now come back to your IDE. Alright, so I will stop the execution here. Now I have this store title command. I created a variable called var title and I'm storing the actual title into this variable. So let's also display this on our console. So I'll add a command here, echo, and in target, how do I use the variable now? This is the way to use it. I'll say $, and in flower braces, I will give the variable name which I have defined earlier. So it is var title. Okay, so this is all my script is where I'm storing the title of the web page and I'm displaying it in my console or the log. So now there are some extra commands which gets added here. Now because we are doing the recording on that, so whatever the mouse movements happen, it is going to record. We do not need this, so I will go ahead and delete this particular command. So let's close this window and execute this test first. So the script has executed successfully, but let's go and see whether did we get the title displayed on the console. Yes. So it did open the Amazon site. It has set the window size. It captured the title here in this line. And then after assigning it to the variable, we said echo and that variable name and it is displayed as the title of the page. So now similarly, let's go ahead and Let's see how do we use the store text command. Now for store text, I need an use case here. Say for example, what about this cart? Let's say we want to display the text of this particular element. Now the text of this element is cart. So now instead of again going and re-recording all the steps, I will simply manually add this command. So now after displaying the title, okay, so let's go ahead here and I will say store text. And in store text, I need to pick the text from this web element cart. So what I will do is I'll use this target, select target, and I will select this particular element, which is cart. After this, I need to create a variable where it can be stored. So I'll say var cart text. Now similarly, I will also display it using echo command. Echo $ in the flower braces. I'll say var cart text. So let's execute this and then let's look at the other command. So I'll just say, I'll close this window again, run this test. So now look at this log lines. So our last statements was storing the title and displaying the title. After that, we added store text. Okay, so here is the command. It said it is executed successfully. It was able to retrieve the text from the element cart, and the text retrieved was cart, and which is what got displayed with the echo statement on our console. So now let's move to our next store command, which is store value. Now as I said, store value, for us to use that particular web element should have the attribute value. So first let's examine which element we can take and display the value. Now on the same website, I have the search button. So I will right click on this and I say inspect element. Now look at all the attributes of this element. It is of type input, it has a class name, it is of type submit, and also it has this value attribute which is go. And this is exactly what I want to retrieve and print. So we will be using the search button. Now similarly, same thing what I will do here. I'll go ahead, add a command here. I'll say store value. Same way, I will select the target. I'll say select target from page. I will click on the search button. Alright, so here it has taken the target here. In the value, I will mention the variable name where I want to store the value. So I'll say var button and value. And similarly, I will say echo and I will print the value of this variable, which is $var btn value. Let's go ahead and execute this. I'll say run current test. So it has taken the title, it has printed the value on the line 7. So it says store value on this particular element, and the value was stored in the variable var btn value. So that command was successful, and the value actually which was got stored and which we retrieved using echo statement was go, and that's exactly what we had here. If you want to check again, go here to inspect element, the one which is highlighted. So as we said, the value is go, and that's exactly got printed on our console. Now apart from this, I also said there is a simple command which is just store. So let's use that also. Now after all this, here I will say store and say we want to just store a user message. I would say a target as all store commands demoed, and this message I will capture it in a variable, say var string, since it's just a text, and then like I did it in the other var string, then I'll say echo and the variable name. So now if we close this, and one way to do it is execute the complete test, so which will execute all our store commands, and also the last line is this, the line number 9 in the log, which says the store command which we use to store the text, all store commands demoed, and that is also displayed using the echo. So all the store commands we have demoed successfully. Now let's close this window and go back to our presentation. So this is all about the accessor command. Now what do we have after accessor? So we have something called as assertions. Now what is an assert? So assertion is nothing but it verifies the current state of an application with an expected state. So this is something where you compare your actual result with the expected result. Now assertions are of 3 different types. One is assert, verify and wait for. Now what does assert does? When the assert command is executed and if it fails, right, the test stops immediately after this statement. So if you are asserting, say, a title of a page, and if you find that the title of page is not as expected, as soon as it finds that failure, your rest of the test is not going to run, and it's going to immediately stop the test, and also it is going to flag the test case as fail. What is verify? Verify is something where this Selenium IDE, it logs that particular assertion as fail. However, it would continue with the rest of the steps in the test case. And then at the end of it, your overall test case is flagged as failed. That is what verify does. So verify is called as soft assertion, whereas assert here is called as hard assertion. Why it is called hard assertion? Because as soon as an assert statement fails, the complete test execution stops at that statement. Whereas in soft assert, what happens is after the failure happens, the test continues with the rest of the steps and it completes its execution and then flags the test case as failure. And when is this usually used? In cases like, as the same example, say if you are asserting a title, you really do not want the test case execution to stop even if there is a failure. Why? Because none of your steps are going to be dependent on this assertion point. And this is where you will require a soft assert. Wait for. Wait for is something which waits for a certain condition to be true. After that, it proceeds to your further steps. So if the condition goes false here, for whatever, say if you are waiting for an element to appear on the web page, and if that element does not appear, the test fails. However, it carries forward and completes the test by executing the rest of the steps and then flags the complete test case as a failure, which will be something similar to a soft assert. So let's see all these things in action. Let's go back to our IDE. We will create another test case here. So I'll say assert test. Now for this, what's the example we can take? So first for assert title, let's do the assert title on Amazon itself, and let's change the same test case to verify and see how this test case behaves. Now for this, I will launch the recorder with the same amazon.in. Okay, my recorder is launched. Now simply I will go to this website and I'll say right click, Selenium IDE, and I'll say assert title. Then I will stop the recording. Now here I will remove this command which has got added, which I don't need. So this is my assert title. Now we have already seen assert title passing in a couple of our other examples. Now I want to show you a failure on assert. So for that, what I will do, I will modify this actual title. So here in the last line, I'll just remove this amazon.in. So now ideally this test case is going to fail for us because the title which it is expecting and what it is comparing against are not the same. First, let's execute this. Well, I also need to show some statements after this. So what I will do is, let's add few more statements here. So let me start the recording here again. Say after asserting the title, we want to go and click on this bestseller, and then I will close this. Now let's execute this. Stop the recording and execute this test. Now do you see this? Assert title is in red. That means it has failed the validation here. So you see here in the log, it says open the site, done, set window size, done. When it comes to assert title, it says actual value was something different and it did not match with what you were trying to look for. Assert test ended with one error. Now after this assert, please observe that there are no other statements which got executed. The test stopped right away after this failure. This is called as hard assert. Now let's go ahead and change this assert title to verify title. So simply what I will do, in the command itself, instead of assert, I'll say verify title. And now let's execute this and see what happens. Now let me close this window first and then I'll say run test. Running assert test, amazon.in was opened, window size was set, verify title failed because the titles were different because we have modified that. However, do you see this fourth line being executed? Click on link test bestseller and click on close. Now since it was a very fast execution and I closed the browser, probably you were not able to see the bestsellers clicked here. That is fine, but in the log we can see here that the steps 4 and 5 got executed even after the title, verify title, step failed. And if you compare it with the previous example where assert title failed, the two lines after that, the line 4 where we are clicking on the bestseller and closing the browser are not getting executed. So this is the main difference between the verify title and the assert title. So now let's look at wait for. How do we use wait for? Now for wait for, I want to look at some kind of website where it would load an element dynamically after a while. So for that, I have a website here. Let's create a new test again. Let's go to the tests pane. I will say assertion test. And now let's go to a browser. We open a new window and there is a demo site which I want to use. So let me search for that and then I will use that URL. So I'll say internet. I'm going to use the dynamic loading. Do we have here? Yes, dynamic loading. Page, element rendered. Now, see, if you look at this website, when I press on the start button, right, after a while, this hello world text is going to appear on this web page. So in our use case, what we will do, we will launch this website, we will click on the start button, and then we will put an assert on this text using wait for. Let's do that. So let's go here. Let me copy this. This is the one. Let me say Control C, and in my new test, I'll say Control V, and then I'll say start recording. So it's going to launch this. So let's close the previous windows. Now in this, I'm just going to click on start. So that is going to get recorded. Done. And now, while the recording is still on, I will add a command here for wait for. So I'll say wait for element visible. That is exactly what we are saying, right? So wait for is used until for a condition and until that condition is true. So I am saying here, please wait for this particular element, which I'm going to give it in target, until it is visible. Now the target is, I'm just going to select the target from this web page itself. So I'll say select target, and I'm going to select this particular text. Come back here to your ID. So wait for the element to be visible. What is the element to be visible? Is this hello world text. And then you need to give a value here. Now what is this value? Since we are using wait for, we need to mention a timeout. So we have to tell basically to IDE that, okay, wait for say 1 second, 2 seconds or 3 seconds, whatever it is required. And that timeout value needs to be mentioned here. So, and this is in milliseconds. So what I will say is, I'll say, so let's fail this test case first. So I'll use a little lesser timeout. So I'll say 3000. So that is 3000 milliseconds, which is 3 seconds. That is it. And then we can say, so what we'll do here is we'll add an assert. So I will say assert text. Now what is the assert text I'm going to do? I need to look for the same element. So I'll simply say select target, this one. And what is that I'm going to assert with? I'm going to assert with the same text. So I'll just copy this text and I'll put it in the value. There's another way of doing that, which we have done it previously. So I can just go here, do a right click, go to Selenium IDE, and I can say assert text, which is basically going to give me the same command. So let me just go ahead and remove one of them. Either of them you can remove. Okay, so let's stop the recording. I will not close this browser because I want you to see how the dynamically loaded element behaves. And we'll go ahead and execute this. So I'll say stop recording and I'll say execute this test. Now it's here. All right. So it's waiting. Okay, it is failed. Now see this. So it says wait for element visible. After that, the value we have mentioned is 3000. There is wait for 3 seconds, which was not enough because, and it failed with saying that unable to locate the element within the timeout period. Now let's go ahead and change it to a passing value. So I will say 10,000 here, which is 10 seconds. So let's close this. And let's again execute this. Bring this to a side so that we can see, okay, it is waiting on that wait for element. Now look at the problem here. What we have done is we have closed the website and after that we have added the assert text. So this is a mistake what we have done. And hence, though it has found that element here for wait for, what did it do? It went ahead and closed the window, and after that it's definitely not going to find the assert text, right? So that's the mistake what we have done. So let's go ahead and debug this. So what we will do, after this wait for element, we want this assert to be put after that. We don't need this click content because this was an additional step which got added. Delete it and then close. Okay, fine. So now let's go ahead and rerun this. So let's say run current test. I'll move this to a side. Okay, it's waiting. All right, done. So now it is able to do an assert text on this. All right, so this is how you use the wait for. Key features of Selenium IDE. Let's look at the first feature, reusability of test scripts. So many of the test scripts have test steps that involves signing into an application or creating an account. Like for example, a login screen is a very key example in this case, where whenever you are testing your application, first you need to log in and then perform any other test. So now it's going to be a redundant or a waste of time to recreate the login steps again and again for each and every test case. So we do not want to definitely do that. So as we know, since a record and replay tool does not have enough capability of writing common test cases or a common functions and calling those common functions like our regular Selenium WebDriver has. However, what IDE has done is it has given us a provision to run one script from another script. So what basically what we do here is, especially for a login, we write one test case which is going to log into your application and call this test case in the other test cases. So let's take a look at how this works. So for that, let's go to our IDE. So in this IDE, we'll do one thing. Let's go ahead and create a new project. So let's say login project. In this project, I will create a new test case. We'll call it as login test. And I'll say add. Now in this login test, I need to give a URL. Now for this purpose, I will be using again a demo site. So first let me launch a demo site here, file new window, and I will say the demo site co.uk. Okay, this is a simple demo site which has a login functionality. Right, so here I will go to the login screen. Now this also allows me to add few users, and using the same users we can go ahead and do the login. Now coming back to our login page, so this is the URL which I need to launch, which is going to give us username and password we'll use to log in into this application. So give this URL here and say start recording. Move this window here for recording and this here. Now what is the first step we want to record? We want to come here, click on the username, and I'll say user1, okay, and I'll say password pwd1, and I will click on test login, and then what we will do is we will assert this text. So here I'll say right click, Selenium IDE, assert text. That's it. And then I will close the browser. Okay, this is all my test is. Now come back to your IDE. Let's see if there are any unnecessary commands which it has taken. Okay, click, type, all done. And now for the time being, I'm going to comment out this close command because I want the browser to be still open so that we can see the actual test execution properly till the end of the script. This is the login test case. Now simply if I run this, let's execute this. Let me execute this and show, stop the recording and execute this test case. So it typed user1, it typed pwd, which is my password here, and then clicked on the button, and then definitely it was the wrong password. So it gave me failed login. So this is passed. Fantastic. However, this is with one value I have used it, but this is a function which I want to use it every time. And also a probable use case I might have is that I might need to log in with a different user ID and password. And apart from that, even just to test this login test page, I would want to test with multiple user ID and password, like valid credentials and invalid credentials. Now for that purpose, what we will do is we will parameterize this name, that is user ID, and the password. And how do I parameterize it? Simply go here, instead of giving a hard-coded value here, what you can do is just say use any variable name here, and we'll define this variable somewhere else. So I'll say username. This is the variable. Similarly, for my password, in my value field, instead of a hard-coded value, I'll say $, and I will say password. Now I cannot run this program as it is because this variable is not defined in the login.test. What I will do now is I will create my actual test case. So I'll say here, I'll say invalid credential as my test case, and I'll say add. Now here is where I will assign values for my variable. Now which are those variables I need to use? Username and password. So I need to assign some value here and then call this function login test. So let's do that. In this video previously we also saw how do we use user variables and how do we assign value by using the store command. So I'm going to say store, and then my target is going to be the actual value. So user1, and where is that I'm going to pass this? To my variable username. So let's just check once if the variable name is username. Yes. All right, done. Now I have done the username. Now I need to pass the password. So I'll say store, the actual password, which is pwd1 in my case. And what is the variable I need to use here? I have to use password because that's the variable which we have used in login test here. And then after that, I need to use a command which is called as run. Now what this run command does is run, and whatever target you give, which is basically your another test case, it is going to run the test case. Now in our case, our test is login test. This is all our test case is going to be. Okay, so what is that we do in this test case? We created a variable username and password and assigned the actual username and password. And then we are just calling this login test. And in this login test, this username and password will get passed, which will be user1 and pwd1, and then it will execute this test with the value which we have passed to this variable names. So now which test case we need to run? The invalid credential. So let's go ahead, close this window and execute this test. Executed. So now look at the log of this invalid credential test. See here, running login test called by invalid credential. Before that it said store this value, store user1 in the value username, that is your variable. This is this line, and then the password. Then it says run login test. So it called the login test functionality, and in the login test we have all this clicking on the password field, clicking on the username, and then asserting the text, and that's exactly what is done here. This is how you use it. So now let's write one more test here for the same login test. So Let me add another test. I'll say valid credentials and I'll say add. Now same thing I will do here. I'll say command store. My target will be, now I'll say user3, value will be username, right? Okay. Now second command will be again storing. This time it is for the password. My password is pwd3 and the variable name is password. And same thing, I'll just call run and my login test. That's it. So now similarly, let's run this test and see what happens. Now this test is going to fail. Why? Let me close this window. I don't need this. Why did this test case fail? Because my assertion point, let's go to the tests, I'll show you. My assertion point in login test is look for failed login. However, we created a test case for valid credentials, right? Because our valid credentials said that the login was successful, which did not match with what we were asserting, which is fine, right? So we just wanted to see whether we can write a test case with valid credentials and invalid credentials. And this is how you do that, by passing the variables through your test case to your actual test case. The next feature is the debugger in the IDE. Like every other IDE offers a debugger functionality, so does Selenium IDE. So let's look at what are the different functions available for us in the debugging. So there are multiple functionalities which the Selenium IDE offers us. So one is called as the step execution. So for us to look at how each of these debugging techniques work, what I'll do is let's go ahead and create a new test script. So let's go to our IDE and I will create a new test case. So I'll say new test case. Let's use Facebook login this time. So I'll say FB login test, or we'll just say FB test. So now for this FB test, I would go ahead and use the Facebook login page. So I'll just copy this URL, paste it here, and then I will minimize this other Firefox window and I will launch the recorder now. So I'll click on start recording. Now let's keep this side by side. And what is that we are going to do here is, let's do a simple login functionality. So I'll just use some email ID here. So I'll say myuser@gmail.com. This is just a dummy user ID and password I'll use, and I'll say password as password1. Then I'll click on login button. Let's stop the recording here. So let's read the script once, whether it has got everything whatever we need. Okay, it has launched Facebook. It clicked on email ID. There's a double clicks here because I happen to click twice on the email ID field. So what I'll do, I'll remove one. We don't need it. And then I'm typing the keys, which is myuser.gmail. And then I'm clicking on the password field, typing the password and clicking on the login button. And then once I do that, okay, so I'm going to get this page as the password you have entered is incorrect. So let it be. So we will use the script until here and check out some of the login options. Okay, so we have completed writing of the script. Let me go ahead and close this window. Now, first thing what we will do is we'll just simply execute the script. So we have to just say run current test. So it's going to log in your Facebook. It'll enter myuser@gmail. It'll enter the password. It'll log in, and that's about it. So now your script is executed. Now let's go into the debug mode. As we said, there are multiple options for debugging. What is the first option? Let's see. So first option we have is something called as step execution. So what the step execution does is, from your script, you can execute all the steps one after the other. So you can basically control the execution of each step. And how you do that, what you have to do is just go and click anywhere. So let's start from the beginning. Let's close this window of our previous run. And there is an option here which says step over current command. So when you click on this, what it does is it basically executes your first line where your cursor was. And it stops immediately after that. So if you look here, it has launched the Facebook page, which says open the URL Facebook. And then let's go ahead and just do the simple step execution. Again, I will click on that. It is going to execute this command where it set the window size to certain value. Again, I will do a step execution. Now observe what happens here. It clicked on this email field. Do you see the cursor there? Now let's do the next step again. Again, I will do step over current command. Now the current command was it entered myuser@gmail. You can see it on the left side here. Now it will be more visible. Again, I will do a step execution. It is going to click on the password field. Now it is going to enter the password. And now the last step is it's going to click on the login button. And with this, all our commands are executed. And this is how you do the step execution. And now where is this useful? Say if you've got a very long test case written and you want at certain point you want to start doing the step execution to see where your test case is failing. Probably one of your web element you entered is wrong, or probably the text which you are entered is wrong. So for you to debug such cases, you can use this step over current command functionality. So what's our next command? Breakpoints. So there are breakpoints which you can insert in your script. Okay, so let's close this execution and let's come back to our script. So what I will do is first let's add a breakpoint. How do you add a breakpoint? Say for example, we want to add a breakpoint after we type in our email ID. So here what I do is I simply go and click here. So once you click here, this is where your breakpoint is added. Other way of adding breakpoint is you can right click on any command and you can use this toggle breakpoint. So if there is no breakpoint, it adds the breakpoint. And for you to remove it, you can simply go and select the toggle breakpoint again. So now I've added a single breakpoint. Now what you need to do is, once you execute this, once you say run test, what it will do is it will come till here, till your breakpoint. It will execute all the commands before that and it stops or pauses your execution at this point. Okay, let's go ahead and see how it does. So what I'll do is I've added a breakpoint at the click on password field and I will say execute this test. Do you see here? It says paused in the debugger. So by adding breakpoint, my test has entered the debugging mode. And where has it stopped? At the point where I added this breakpoint. So just go back here and see whether the previous steps have been executed. Yes, my previous step was adding this myuser@gmail.com into the email field, which it has done, and it has paused here. And now from here, I can either run the rest of the tests. If I just click on this run current test, what it will do is it will go ahead and execute all the steps, or even I can do a step execution from here. So say if I want to do a step execution, I'll do this. Let me minimize this window a little bit so that you can see. And I'm still again doing that step execution. So it added the password. And after this, I'll say just go ahead and complete the test. So it has clicked on your sign in login button and it is logged in. So this is how you can use the breakpoint. So that is about adding the breakpoint. Let's see what's the next. Removing the breakpoint. So I showed you. So if you want to add a breakpoint, you just click here, or you can do a right click and do toggle breakpoint. If you want to remove the breakpoint, just click again on the same place where it has added the breakpoint, or you can always do this toggle breakpoint. So this is the way of adding and removing the breakpoints. What is the third option? Disabling. Now say for example, my test case is a pretty long one. Okay, so I might have a multiple breakpoints. So say let's add one breakpoint here at the email, and then before clicking on login, let's add another breakpoint. Now when I execute this, it is going to stop here, and then again if I say continue execution, it is going to come and stop here. So let's do that first and then I'll show you how the disable works. So let's close this window again, execute this, bring this window here. Can you see this? It's paused here. Okay, and here now you should be able to see it. Now I'll say just run after this breakpoint. Do you see here? It is paused after entering the password. It has not clicked on the login button. It's paused at the click. And now I'll say again, complete the test. So your click on the login button is done and it is logged in. So it's a little bit slow. Yeah, now you got that logged in page. At some point of time while I'm debugging my test case, I would want to just disable all the breakpoints and not remove everything. For that, I have an option here which says disable breakpoint. So if this button is highlighted here, that means I have selected disable breakpoint. So what this does is when I execute this test, it ignores all these breakpoints for this run. It ignores these breakpoints until I have selected this disable breakpoint button. Okay, so let's see this. Let me close this again, and I have enabled this. Disable breakpoint is what I have selected. I'll just simply go ahead and run this test case. Do you see that? It did not stop at this breakpoint. It went ahead and completed the execution. Why? Because I have temporarily disabled it. Once I remove this selection and run it, it is again going to stop at the breakpoints. So this is how it works. So we saw adding of breakpoints, removing of breakpoints, and disabling of breakpoints. What is the next one? Enter debugger by using play to this point option. Okay. Now another way of doing this is, so let's remove all this breakpoint. Now for example, like the last time we said we want to add a breakpoint here. So now instead of doing that, what I can also do is I can just right click on that particular command and I can say play to this point only. So when I select this, what happens? It acts like a breakpoint and it comes and pauses at this particular command where I have said play till this point. So let's try to do that. So let me close this window and then for say type the password. So here, okay, I'll say right click, play to this point. So it is going to execute all the steps until the password and it will stop here. Can you see this? Paused in the debugger. So it again entered the debug mode and now it has stopped at this point. So now there are multiple options. Now every time, last time what we did a step over, and also we said continue with the rest of the test. Now what we will do, we'll just stop the execution. So this is also an option available. Say if you want to change something here, you do not want to continue with your execution, you can simply go ahead and stop the execution. So we saw how do we use the play to this point option. Now debugger command. Now all these things, whatever we did now, adding the breakpoints, this was done in the IDE. There is also a way of adding a debugger programmatically. And how do we do that? Let's see. Now at the same place, say after entering the password. So here I will insert a command. In this command, I'll just say debugger. This is all the command is. Now what happens when I execute this test cases? At this point, wherever it finds this debugger command, this program enters into a debug mode and it comes and pauses the script here. Let's see this in action. So simply I'll just play the script. Let's type the email ID. Let's type the password. Okay, it is going a little slower here. Okay, and there you go. Now it is paused in debugger. So this debugger did the same job as what we did earlier with the breakpoints. Now let's go ahead and just stop the execution, because let's not keep logging into Facebook with invalid username and ID. Okay, so this is how you can use the debugger command. So I will stop the execution here, close this window, and then now let's see the next one. Let's close this window. So we saw the debug, pause on exception. Okay, this is a very brilliant feature of this IDE. I'll show you how it works. Now let's say, let me remove this command now. I do not want the debugger. I'll say delete this command. Just click, let it be there. Now, if you look at this, what we are doing is we are identifying these elements like email, password, and then clicking on the login button. Now, say for example, say this click. So let's run this, then I'll show you what it is. And I want it to come and stop here. Okay, so I will execute this. All right, so now it is paused here. So now what I will do is the click, right? So this is where I'm clicking is this login button. So this login button is identified by some identifier, which is an ID. Now there is a possibility that tomorrow this particular ID might change, or any of the locator might change on this particular website. And if that happens, the first point of failure what you will see is when you click on this button, because this script will say that this element is not found. In such cases, if you are using pause on exception, that is here, pause on exception, what happens is whenever this script finds an exception, it goes and pauses at that and enters into a debug mode. Otherwise, what happens whenever you find an exception, your complete test script will stop executing because there is an error and your test case fails. Instead, since we are in a debugging mode, if you choose this option, what happens is if there is an exception, it is going to get into the debugger mode and it is going to pause the execution at that point. And once it pauses, what you can do is you can go and correct it and then continue your execution. So let's see that in action. So now, for example, the click button. So here the ID is u_0_a. So say I try to change this. Let me add 1 here. And then if I execute this, this script should fail for me, basically, because it is not going to find this. So can you see us trying to find this ID? And since this particular element with this ID does not exist, this whole test case should fail for me. Now, as I said earlier in this video, so if by any chance, if one of the element ID is not found, so if that is not found, it always falls back into the other locator techniques. And that is what it did in this case. It tried to locate the login button using some other ID, and that's what it says. So element found with the secondary locator. Okay, to use it by default, update the test step and to use it as a primary locator. And that is why the test case passed. So let's try to see if I can make this test case fail in any way. For that, let's remove this and let's try on the email ID. So what I will do is, let me try to comment this out. Let's remove the debugger and I will add a command here. I'll say insert new command, and in this I will say click, and then I will use the target as ID equal to email. Now in this case, I do not have a fallback ID because I am not using ID to recognize the element. Rather, I added my own command and I added my own locator here. So now let's try with this. And now instead of this is the right ID, so what I will do is I'll just change this ID to something like _1 so that this test case fails for me. Now let me close this and let's run this test case, and basically this test case should fail. So if you see here in the log, it's saying trying to find the element with ID email _1. So this ID has a default timeout, so it will keep trying to find the element until the timeout value is completed. Now there we go. So it had an implicit timeout of 30,000, so that is 30 seconds, 30,000 milliseconds, which was 30 seconds. Now after that, this test case failed. So this is the scenario we wanted. What happens here is it simply started executing. The moment it found an exception, it completely stopped. So as a tester, what you need to do is you need to go back, look for this red lines where it has failed, correct it, and then rerun the whole test. Now instead of that, what this pause and exception does is, let me click on that. So this is what is selected now. What it does is when I execute this, this is going to come and stop here. Let's see that. So let me close this and run this program again. So run current test. I'll bring this to the side. Now see, it's trying to find the ID. Since the timeout is almost 30 seconds, we need to wait until it pauses at this. So now do you see this? Now it is not exited from the test. It is just at the same step where it is unable to find this email field. Okay, and it's saying, okay, it failed with an implicit timeout of 30 seconds. But now since I'm in the debugging mode, and how did I get into the debug mode? By selecting this option, pause and exception. Now what I can do is I can go ahead and change this back to the actual one. And then from here, I can just simply do this. I can say run the test now. So now see what it did. The moment I changed that and I said run, it passed. And how did it pass? Because I gave the right ID here. And that's exactly you can do with this debugger. Control flow statements. So in the legacy IDE, these control flow statements were available as plugin. So one had to install the plugin for you to use any of these control flow statements. However, in the new IDE, these are available out of box. So let's see what these control statements are. So let's go to my notes. So there are two types of control flow statements. One is conditional branching and the other one is looping. So in conditional branching, we have a regular if, else if, nested if, else and end. And when we talk about looping, there are multiple loops available. One is the while end loop. So how does the while end loop work? The code between the while and the end is executed until the expression is true. And then we have a do repeat. So do repeat where the commands after the do will get executed first and then the condition is checked. And this is evaluated in the if statement. Times end. So you can specify a number of iterations you would like a piece of code to be executed using this loop. And then there's another loop which is a for each loop. So this provides the ability to iterate over collection objects. Like say if you have an array object with you and you want to say traverse through the array and perform certain operations on each of the array element. So that is possible using the for each loop. So let's go and write a test script and see how this works. So what I will do is I will demonstrate a use case for the if else, and then for the looping I have a few test scripts which I've already written, which I will show you and I will walk you through them. It's a simple counter which we can use where we'll be incrementing the counter using one of these loops. So we'll just see how the loops are to be used, what is the syntax to be used, and how they execute in the IDE. So let's go to our IDE now. Let's minimize this. So this was our previous test case. So what I will do is I will close this project and open another project. So I have another project here which is called as control flows. So as I said, I have few scripts written for some of the loops. However, for the demo use case, we will go ahead and write a new script. Okay, so I'll say add new test. And we are going to be working with a demo site called calorie calculator. Okay, so let me name the test case itself as calorie calculator test. So let's look at what is our use case. Now in this use case, this is my use case. I'm saying go to this calorie counter website. Okay, so let's see what that website is. I have this website open here. So this is a calorie calculator website. In this website, we are saying if the gender is male, then click on the male radio button. So you have multiple fields here where you're accepting the age of a person, the gender of a person, the height, the weight, and then the activity level of the person. And when you click on calculate, this is going to give you the number of calories. So for our purpose, for our demo use case, what we will do is we will store the gender to be selected in a variable. Say for example, I want a gender female to be selected. And then I'm going to write an if condition here that if the gender is male, right? So if the gender is male, then click on the male radio button here. And then I'm saying click active from the activity dropdown. So there's a dropdown called activity here. In this, I'm going to go and select active is daily exercise or intense exercise 3 to 4 times a week. This is what I'm going to be selecting. And if the gender is female, so if the value passed from the gender is female, then what is that I want to do? I want to click on this radio button female and select very active intense exercise from this activity dropdown. A very simple use case. So this is what we are going to write in our test script. So let's minimize this window, or we can just close this window for now. We don't need this. And here, so how do we start this test case? I need to enter the URL. So for me to enter the URL, let me go to that, copy this URL, Control C, minimize this and Control V. Done. So now here I will start my recording by clicking on the start recording button. So now this URL is open. Now the first thing what I need to do is, in my test script, I need to write a open command. So I'll say open, and my target is what? This URL. Done. The next command is, as per our use case, I want to store the gender to be selected in a variable. So we will use the store command, and when we use the store command, we need to specify the target. So let's say the target is F, and where is that I want to store? I'll create a var gender. That's my variable. So I have stored this now. What is the next thing I want to do? So once I have stored this, first is I need to put an if statement, because my use case is if the gender is male and if the gender is female. Now since by default the male is already selected here, so let's put an if condition for this condition, if the gender is female. Okay, so that is exactly what I'm going to do. So here I will say if in the command. Once I say if, in the target you need to specify the condition. Now condition is, I want to check for $, that's my variable, var gender. I want to check if this is equal to F. And how is that I can check? I need to use 3 equal to here. In double quotes, I'm going to mention F. Now this is what I've stored in the variable var gender. This is what I'm going to check. So if this is the condition, in the next line, now all the next lines, whatever I'm going to mention, are the ones which will be executed if this condition is true. Now in the next line, what I want is, I want to select this radio button, correct? So now what I will do, instead of writing all the commands manually, I will now use a recorder to do that. Since I'm already in the recording mode, I'll just go to the URL or the website here, and I'll go click on this female. So on the right, if you see, these steps are getting recorded. And then our use case also said that from the activity drop down, we want to select very active. So now if you look here, all our steps have been recorded. So I clicked on the female radio button, and then we selected the ID activity here, which is our activity drop down. And then we clicked on the desired value, which is very active. And then you end the if statement here. So, but we also want to add an else statement. So instead of saying end here, I will say else. So that means if the gender selected is male, okay, what is that we want to do? I want to go and select in the activity field as active, because the male is already selected. So I'm not going to select it again. And then I will end the if loop by end statement. That is all. So this is all my script is. So let's stop the recording here. There are some mouse move, mouse up, which I really do not need. So what I will do is I'll just delete this. So this is the simple statement what I need in the else, where I'm saying select. So select is something, a command which is used to select a web element, which is your drop down. So you select the drop down here, and once the drop down is clicked, and then you go ahead and click on this particular target is nothing but your active daily accesses or intents. This value from the drop down is what I'm selecting. And same thing what we did in the if statement. So let's remove these also. We don't mouse move, at, and mouse up, at. So all these statements we don't need. So same thing, if I'm saying the if statement says if the gender is F, that is female, click on the radio button, then go to the select activity, select the activity by clicking on very active, and then end the loop. So this is all our script is. Now let's go ahead and execute this and see whether it works. So let's minimize this window, and I will simply say execute the current test. Let's slow down the execution speed a little bit so that you can observe what exactly is happening. Now I'll say run the current test. So the calorie calculator is open. So we are passing the value F for the gender. Correct? So that means it entered this loop. You can see here in the log. So if the gender is F, which is female, yes, it found the condition to be true. And then it clicked on this radio button. It went to the select field, which is your activity drop down. It selected the very active option from here, and then it ended. Now in the same program, what I will do, instead of F, let's pass the value M. Male, and let's see what happens, and then we will go ahead and execute this program. So let's close this window again and execute the test script again. So now according to the script, we are not reselecting the radio button because this is already selected by default. And in this test script, if you see, now all the green colored one. If you see, okay, the open command ran successfully, store command ran successfully, it came to the if condition, it checked if the gender was F or M, it found that this condition is not true. So can you see here, all these other statements in the if are in black color. That means these were not executed. Instead, it came to the else part and then it executed all the commands in the else part. So this is how you use a if condition in your Selenium IDE. So let's close this. Now, as I said, there are other looping statements what we have, like while end loop or do repeat and times end. So I have couple of examples written here. Let's walk through that and see. So let's take the while loop first. So what happens in this while loop? Let's see. In this while loop, what I'm basically doing is I have created a counter and I am counting it from 1 to 5 and then displaying the value of the counter. And I'm using a while loop for that. So here it says, first I'm setting a counter value to 1 and then I'm saying while the counter value is less than 5, this is the loop, while and end. So whatever commands are within that, those get executed until the condition is true. So this loop will get executed until the counter becomes 5. So once it sees that counter is 5, it is going to exit the loop and just print the value of the counter. It's as simple as while loop. So just pay attention to the syntax, the way it has been used here. So this execute script is what a simplest statement what I have used. This could be anything. It could be any of your web elements you're performing certain operations. Say there is a calculator which you are using, say a calculator under test. So if you want to key in certain numbers until say the sum of the numbers is 30 or something. An example like that could be a valid use case for your while loop. So you could use that. So let's execute this and see how the counter works. So if I execute this command, so now take a look at the log here. It says running while test. So first statement where it assigned the counter value and then it got into the while loop and it executed the while loop until the counter was assigned the value 5. And once the counter became 5, the while loop got exited and we are printing the counter value. So this is how a while loop is used. Now similarly, the same function of using a counter, I have tried to use a do loop here. So let's look at it. Now in the do loop, what happens is the script is executed because it's the first command after the do statement. So whatever is between the do and repeat if is executed and then the condition is checked here. So here what I'm doing is I'm just first assigning a counter with value 0 and I'm incrementing the counter every time by 10. And then I have a condition that once the counter becomes 50, please exit the loop. That's all I'm doing here. And another statement what I have written here is every time the counter gets incremented, I'm printing the value of the counter. So let's execute this script. Can you see that the way it is executing it? Alright, now let's see the log. Running do loop test. Okay, the counter has been initialized to 0 and then it executes the script. In this script is doing what? It is just incrementing the counter by 10. The counter becomes 10 and then 20, 30, 40 and 50. So as soon as it becomes 50, it's going to exit the loop and print the value of the counter. So one thing to notice is there is no web element or website testing which I'm doing from the script. However, one thing what the IDE needs is it needs a starting point. So whenever you create a new test kit, it asks you to at least give it a URL from where it can start. Though it is not going to launch that URL, it is going to launch your browser definitely before even it executes a single line of test. So that is something mandatory in the IDE. So we saw do loop, we saw the while loop. There's also something called as times loop. So which is what I have said here. Times and end. So this is something you can specify a number of iterations you would like to perform a set of commands. So now in this example, what am I doing? I'm simply incrementing a counter by 1, right? And I'm saying just increment, that is, this is the only command which I want to execute, but I want it to execute 2 times. That's all. So there is no other conditions here. It is simply saying there is a set of command or a single command which I want to execute it twice. And the number of times which I want to execute is what I mentioned here in the target. So first initially I am assigning a counter with value 100 and then I'm saying increment this counter by 1 2 times and then print the value of the counter. So let's execute this and then change the number of times. So if I say run test here, so can you see this? The number of times it got iterated and now the value is 102. Why? Because initial value was 100. In the loop, which is the times loop, I'm saying the iterations is 2 times, execute the command which increments the counter by 1. So that is why your counter value becomes 102. Now say I increase this to say 10 so that we get a feel of how the loop executes here. And same thing, I will execute it. Now see it, you can visually see the number of times the loop is getting executed. Alright, and in the log you can see the values also here. Okay, can you see here? So this loop executed 10 times and hence the counter value becomes 110. So these are a simple ways of using these loops in the IDE. So you can implement these loops for any kind of functionality you may want to perform on your web elements or any logic which you want to build for your test cases. Selenium Side Runner. Selenium Side Runner is a command line runner tool which allows the user to run your Selenium IDE test cases on any browsers or to run the test cases parallelly, and also it gives you a mechanism to use the grid setup to run your test cases on a remote machine. Okay, so for us to work with this Selenium Side Runner, there are certain installations which we need to do. And some of the installation prereqs are, one is you need a Node.js server. And what is this Node.js server? Node.js server is a powerful JavaScript based platform. And this is the platform which is intensively used by many developers across the world for developing their web applications. And it's an open source and it is available free of cost to everyone to use it. So we will need to go ahead and install a Node.js server for this. So now let's look at all the installation steps which are involved in installing the side runner and running it. Okay, so let's go to my notes. So the seleniumhq.org has a complete documentation on how to install this command line runner, how to use it, and what are the different ways we can use this runner. I'll just show you where it is. And you can use this as a reference for any of the tests which you're creating and using the side runner to run it. So let me open a new window here. Let's go to this website. So if you see here, it has a complete guide on how to use this command line runner, right? Including the setups, what is the prereqs, installing the browser drivers, and how do you do the different configurations which are available with the side runner. So you can configure various browsers with that. You can set different capabilities for the browser. If you want to use the Selenium grid to run your test cases on remote servers, it also gives you complete details on how to do that. And also using the parameters, changing your base URL. So this is a complete guide which you can refer to when you're working with the side runner. Okay, so let's go back to our installation. So coming back to our installation here. So the first prereq what we need for the Selenium side runner to run is your Node.js. Okay, so if you go to this website nodejs.org, let me open the same browser. Okay, all right. So here you will see that the Node.js is available as an installable for all the platforms. Right? You have a Windows installer, you have Mac OS installer, you have Linux installers also. So if you're working with the Windows machine, there are two options for you. Either you can go ahead and download the MSI installer, or you can just download the zip and unzip it into any folder on your system. Okay. And since I'm using Mac machine, what I have done is I have downloaded this version, PKG version, and have installed it on my machine. Okay. So once you download, say if you're working on the Windows machine, so say if 64-bit is what you require, and you click here and download the zip package, I'll show you how the folder structure looks like. So this is where I have downloaded the Node.js installable. Now, if you look at the Windows one, so this is what happens when you download the zip file and unzip it. This is the folder structure it creates, and this is what we would need, right? So npm is something which we would be using to install all the packages which are required on this Node.js server. And I'll explain to you what those packages are, okay? So once you do this installation, you need to go and check if your installation is gone properly or not. So for that, what you do is go to your terminal window, or in your case, if you're using a Windows machine, just open a command prompt, right? And then you have to just give this command here. You say npm -v, which is basically saying what is the version of the Node.js which we have installed, which is 6.9. Okay. Now, what is this npm? npm is nothing but it's a Node.js package manager, and it gets installed with your node. And this is used to install all your other packages, or what it is called as modules, on your system. Okay. So now with this, we know that our npm has been installed properly. So let's move to the next step of installation. So now we have our Node.js installed. Now next thing is to install the Selenium side runner. Now the Selenium side runner is a library which is available to us, and we need to install this library using the npm. So let me go back to my terminal again. So I'll just show you the command what we use for installing this package or the library. And since I've already installed on my machine, I will not be doing the installation here. So what you need to do is, so if you are a Windows user, you can directly give the command as npm install -g Selenium side runner. Okay, So this is the command which you need to give. However, if you're a Mac user or a Unix user, since you need to use a root user here, what you need to do is just say sudo. Once you press enter here, it will go ahead and install this complete library on your system. Now, since I've already installed, I'm not going to do that. Okay, so I'll just exit from this. Now, once the installation is done, how do you check whether your installation has gone correctly or not? You have to just simply give a command like selenium siderunner -version. Okay, and now this will give you the version number if the installation has been successful. So right now the version installed, which is the latest version, is 3.11. Okay, so far we have done the installation of the Node.js server. We have done the installation of the Selenium. Now, while you do this installation, you need to know that where is the Selenium IDE siderunner has been installed, right? As I said, it's a library or what you popularly call as module in your npm. Right? So for you to check where it has got installed, you simply need to go to the directory. I'll say ls-user local library. So if you see here, you'll see something called as node modules. So whatever packages you're going to install using npm would get installed in this directory, the node modules directory. So let's go ahead and see whether I have my Selenium siderunner there or not. So I'll just use the same ls/node modules. Okay, do you see this? Selenium siderunner is what has got installed. And previously to that, when we installed the Node.js server, it also installed this npm, right? So that is also available under the same folder. So far so good. So we have our Selenium IDE installed now. Now, what else is required? So we installed the Node.js, we installed the Selenium siderunner. Now we need this browser drivers. Now, what are these browser drivers? Now, what you did using your IDE was, we said, right in the IDE itself, I said run the current test. And since I'm using Firefox browser here, any test case using the IDE plugin on your Firefox you execute is going to execute on the Firefox browser. Correct? Same way, if you're using the Selenium IDE on Chrome, which is an extension on Chrome, and you run the test cases there, it is going to use the Chrome browser to run the test case. However, any test cases or any automation scripts you're going to write, you want your scripts to run on all the browsers because you want to do a cross-browser testing, right? So for that purpose, what we do through command line is we install this browser drivers, right? So say if you want to run your test cases on Edge browser, so that means you first need to install your Edge browse driver on your systems before you run your test case on Edge browser. If you want to do it for Chrome, similarly, you need to download the Chrome WebDriver and install it. For Firefox, the same. And once you install that, then you should be able to run it on any browser. Now, where are these Chrome browsers available? So if you go to the seleniumhq.org, let me show you that. Okay, in the Selenium HQ website, if you go to this download tab, right, and if you go down here, you will see something called as third-party drivers, bindings, and plugins. And here you have a list of all the browsers and its corresponding driver files which are available. And this is which you need to go and download. For example, say I want to run all my tests on Chrome browser, right? So what I do is I click here, okay, in the download section, go to the latest Chrome driver available, click on that. And then depending on which OS you're working on, if you're working on Mac, just download this. If you're working on Windows, you download this. And once you download the driver, what you need to do is you keep that drivers, like for example, can you see this driver file? So this is my driver file. This is my executable driver file. So what I did was I just downloaded this file for Mac and I copied it to the location where my tests are present. Okay, now, so once I have this available, what I need to do is I need to install this driver using again the npm command. Okay, and to install this driver, what you need to do is you need to be in the same directory where your driver file is present. Okay, in the same directory, you just issue this command. You say npm install -g and your Chrome driver. This is it. So once you install this driver, you should be able to work with your Chrome driver. Got it? Very simple. So similarly, if you're working with different browsers, say if you also want to run your test cases with Edge or Internet Explorer or the Firefox browser, same way you need to download all the drivers from this location. So from here, like you have Edge browser here, Opera browser, you have a Mozilla Firefox browser. So any of the browser which you want to work with, you have to just download your driver from here, place it in this location and install it using npm command. Okay, so since I will not be executing this command again because I've already installed it. So once your drivers are installed, what's the next step? We are ready to execute our test cases. Okay, so these are all the installation steps which are required to get your command line runner, which is called as Selenium side runner, ready for you to execute your test from the command line. All right. Okay, now let's go ahead and see how do we execute the test cases. So let's go back to our previous example in this video where we wrote some of the test cases for testing our control flows. Okay, so these are all the test cases. Now, if you observe here, I have not created any test suite here. We just had a default suite which was created when we created the project, and we just went ahead and created all the tests here. For the side runner to run, we need to have a test suite there. So if I just try to run the test suite, let's try to run this. What is the name of this project? Control flows. So I'll show you what happens if there is no test suite defined for this. So let me clear the screen, and which is our project here? This one. Okay, so what I will do is let me simply go ahead and execute this project. So to execute any test, this is the command which you use. You simply call Selenium side runner and the project name. Okay, and also once you have installed the Selenium side runner, you can also check the version of it. Okay, so let's execute this. Selenium side runner and the project name. Project name is this. Done. So now if I press enter, now see what happens. Okay, it's saying running the default suite. Can you see here? It looks for a test suite to start its execution. Okay, so it picked up the default suite which is here. Okay, since it was created when we created this new project. Fine. However, it's a test suite failed to run. Why? Because your test suite must contain at least one test, and all our tests are residing outside the test suite. We have none in the default test suite, correct? So what we will do, let's go ahead and create this test suite. Instead of default, what I will do is I'll say first rename this. So let's give it a proper name. So we'll say control flow test suite. Okay, done. So I have renamed it. Now let's go ahead and add all those test cases which we have created to this. So I'll just simply say add test and select all these tests. So we have around 4 tests here. So I'll just select all them. Done. So I'll save this project. I'll go to my folder IDE tests and the same file name. I'll just say replace. Now we have a test suite called control flow test. Now let's go ahead and run that again. Now let's see what happens. Okay, so there are multiple test cases here. So let's see, all these test cases will be run one after the other, sequential. So we have that calorie counter test case, and then we have the loop test cases. All right, so it is done. So now let's understand the flow of this test case. Okay, so this is where we started running our test suite. So it finished first test case, it finished the second test case, it finished the third test case, and then the fourth test case. So all the 4 test cases it has completed. And it says all the 4 passed, total 4, and it also shows you the total time taken for the complete test suite to run. And for every test case, what is the amount of time required to execute the test. So this is all the information which is available here. If at all there is a failure in any of the test case, that would get reflected here. It would say 4 passed, 1 failed, and total 4 executed. Okay, so this is the kind of report what you will get to see. Good so far? Okay, so let's go back to our notes and see whether we have done everything. So the other way of running is, say you have multiple browser drivers installed and you want to run this on a particular browser. So during that time, what you can do is you can use this command. You can say Selenium side runner -c. -c is nothing but setting the capabilities. Capabilities for what? For the browser. And then you give a browser name here. So you can say Chrome or you can say Firefox, whatever the browser of your choice. And then give your project name. So with this, what happens is if your browser is installed, now we have to install the browser using this command, correct? So if your browser is installed, it will execute this particular test suite on the browser which you have mentioned here, right? And that is how you use this Selenium side runner to run your test cases on multiple browsers. Now simply what you can do is you can create a shell script or a batch script. You can add this line into your batch script for the multiple browsers and you can execute this. So that way all your test cases would execute it on all the browsers. So that way you can achieve your cross-browser testing. So other thing, if you remember, I also said that command line runner, like if you go back to our presentation, it says we can run it for parallel testing. Now let's see how do we achieve this parallel testing. Now to achieve this parallel testing, there are certain steps which you need to do in the IDE. So let's go back to our test suite. So we have this test suite. So if you go here and go to the settings, can you see this run in parallel? So you need to check this checkbox to run all these test cases in parallel. So right now what happened when we executed it, all the test cases ran sequentially, one after the other, correct? So for every test case, there was a Chrome browser launched and the Chrome browser was closed before the next test was launched. Now let's try to do this. I'm going to check this checkbox where it says run in parallel and I'll say submit. I'll save this project again. Now same thing, I'll overwrite this project, save, done, replace. Now let's go to our terminal window and run this test cases again. So for that, what I will do, I'll call the same command again. However, now please observe the number of Chrome browser windows it's going to open. Okay, I'll show you that. So it has started running the test suite. Okay, can you see this? 3 Chrome browser windows open at the same time. Okay, and one by one, they're going to get closed out. Okay, so there was also the 4th one open, but since the test case was so small that it was too quick for us to see here. Now look at the complete execution here. So what it has done is it opened all the browsers in parallel, okay, and it ran all the test cases parallelly. You will see a big difference, and since these are very small test cases, you might not be able to see a big difference in the execution time. However, if you have got a bigger test cases which you are running, you will see a remarkable difference in the time taken by the suite to run the test cases. Still here, you can see, okay, it's almost 11 seconds it took, whereas in the previous example, it took 13 seconds. As I said, the difference is very small because our test cases are very, very minute test cases, right? If you have a bigger test cases where it launches the browser, launches your application under test, then you're doing multiple operations, you'll be able to see a remarkable difference when you run the test sequentially and when you run it parallelly. Okay? So this is how you work with the IDE and this is how you achieve the parallel execution. Okay, so that completes our Selenium side runner. Now let's look at some of the limitations of the Selenium IDE. The first limitation is you cannot export your IDE scripts to WebDriver scripts. The support is yet to be added, right? So earlier in this video, I showed you there are ways to export the scripts to JUnit and Python. However, the previous IDE did have this capability of exporting your scripts to WebDriver scripts, and that support is yet to be added to the new IDE. Data-driven testing, like using Excel files or reading data from the CSV files and passing it to your scripts. So this capability is not yet available in the IDE. So you cannot do data-driven testing. Database testing is also not possible. So you cannot actually connect your database, read the test data from your database, or even you cannot perform any kind of database testing. Reporting facility. So it does not have a good reporting. We saw when we use the command line runner or through the IDE when we run the test, there's a very minimal reporting capabilities what we could see. So it does not really have capabilities of reporting like your test engine or the report engine. All right. So to sum it up, what all we learn in this video? We learned how to use the Selenium IDE to create automation scripts. We also looked at some of the key features of this new IDE, like the reusability of the tests, using the control flow statements, how do we use the debugger, and most importantly, using the command line runner, which is called a side runner, to run your tests on any browser and also to run test case parallelly.
Let's get started with what is Jmeter. Jmeter or Apache Jmeter is an open source software which is 100% pure Java application. The application is designed to load or test functional behavior and measure performance. Performance testing means testing a web application against heavy load, multiple and concurrent user traffic. It was originally designed for testing web applications but has since expanded to other test functions. To simplify, let's assume that someday your team lead tells you to perform performance testing of some website like google.com or facebook.com for around 100 users. What would be the first thing that comes to your mind? Do you think it's practically possible to arrange 100 people with computers and access to the internet and accessing the same website? Now just imagine the infrastructure requirement when this testing has to be done for 1,000 or 10,000 users. This is when a need for software like Jmeter arises. So what Jmeter actually does is that it simulates. It will simulate real user behaviors and perform load tests on a server, group of servers, network, or object. Moving further, let's have a look at the prerequisites to install Jmeter. The only prerequisite of installing Jmeter is that Java must be installed in your system. Since Jmeter is an entirely based application, that's why having Java installed in your system is a must. Other than that, Jmeter can be used in many operating systems such as Linux, Windows, Mac OS, or even Ubuntu. Now that we know the basics of Jmeter, let's go on to installing Jmeter onto our system. First, let's check if you have Java installed in your system. For checking that, we shall go to the command prompt and type java-version. We can see that Java is present in our system. Here, it will show the version of Java present in our system. The next step is to download Jmeter. Go to Google Chrome and type Jmeter download. Now go to the official Apache Jmeter website and go to the binary sections. In the binary sections, we shall download the zip folder. Once the zip folder is downloaded, open the folder location. Then extract the zip folder. Once the folder is again extracted, go inside the folder and go inside the bin folder here. The bin folder contains the Jmeter script file for starting Jmeter. Now it's time for us to launch Jmeter. But before we launch Jmeter, we need to know that there are typically two types of modes in which Jmeter can be launched, the GUI mode and the non-GUI mode. The non-GUI mode may refer to two types, the first being running Jmeter in the server mode and the second refers to running Jmeter in the command line. And if we talk about the GUI mode, then the GUI mode has a limitation which slows down the CPU utilization while running the recorded script. But GUI mode of Jmeter is perfect for adding and editing new configuration elements, thread groups, and samplers, as a result of which you can view a number of different listeners helping for debugging. Here, today, we shall be using the GUI mode. So, to open the GUI mode, inside this bin folder, select the jmeter.bat file. Double-click on this file. This may take a while and then the Jmeter window will open up on the screen. The home window is divided into two sections. On the left side, all the elements of the test plan are added, and on the right side, all the configuration of that element are added. As we see on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, listeners, and everything will be stored here. So, moving forward, let's rename this test plan. Let's name the test plan to be first Jmeter. Now, when you click outside this window section, you can see the element name will change. Otherwise, you can just save this and also the name will change. Now, when this is done, the next step is to add thread groups. Right-click on first Jmeter here and select the Add option. Then, in this option, select the Threads option and then Threads group. The thread group refers to the users that are used or created or needed to run this test. So let's name this thread group to be Jmeter. It has several different options, like the action to be taken after there is an error. You can choose it in the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the user's hits. Third, there is also a loop count where you can choose how many times the test will run for the number of users. You can choose the test to run infinite number of times. There is also a scheduler here that will help you schedule the start time and the test's end time. For now, let's leave everything to be one only. The next step is to go to first Jmeter and again to go to Add. In the box that appears, select Samplers. You can see all types of requests that Jmeter can work on. For now, we will choose the simplest of them all. Let's choose the HTTP request. Here, you will have to give the address to some home pages or websites. So let's make it a little easy. Let's rename it to be Home Pages. Here in the server name or IP box, we have to give the server name or the IP. Let's pick a website. Let's go to the Simplilearn website. Copy the URL from here. Come back to the Jmeter window and paste it in the server name box. Keep in mind we don't need to give HTTP or HTTPS since these are protocols which will come in the other box and they will be automatically taken in the HTTP request case. Then in the path dialog box, since we have to access the route page, we will leave a / there. Now, when our HTTP test is ready, we will perform the test on it. To determine what the result of the test will be, we need to add some more test elements. We shall again right-click on first Jmeter, go to the listener options. Then in the box we can check the different type of reports that Jmeter provides us. For now, we shall select two of these. Let's choose View Results in Table and the View Results tree. Now save the test and run it. For running the test, there are three simple ways. First, you can simply click the green button here to run. Second, you can go to this Run option and choose Run the test. And the third way is you can right-click on first Jmeter and choose to run. Let's simply choose the green button and run the test. After we run the test, we shall go to check the results of the test. Since we had put the number of threads and loop to be 1, there's just one entry in both the results. Now let's try one more thing. We shall go to Jmeter and change the number of threads and the loop count. Let's make the number of threads to be around 10 and also the loop count to be 10. And now run the test. After running the test, we shall see the results in the table and see the testing being performed. And the same happens in the case of View Results in tree. Since we have increased the number of users and the loop count, we can see the test being performed accordingly. Since the loop count now was 10, so for each user, the test will run 10 times. And here on the screen, we can see the time taken and the number of tests being performed and the status of each hit onto our website link.
Let's get started with what is performance testing. So, performance testing is one of the most important phases of any product launch, as it verifies and validates the overall product performance. This testing can be done in different forms depending upon the resource availability and the type and volume of the user base. The main agenda behind conducting performance testing on any product is to make sure that the product's performance is as expected before it gets launched into the market. So, performance testing is the process of testing a software application under a specific workload. Performance testing is a software testing process used to test the speed, response time, stability, reliability, scalability, and resource usage of a software application under a particular workload. The main purpose of performance testing is to identify and eliminate performance bottlenecks in the software application. Performance testing mainly focuses on three factors of a software program. First one is the speed. Here it identifies whether the response of the application is fast or not. Then comes scalability, where the maximum user load is determined, and the third one is stability, where the stability of the application is checked under various workloads. Now we know what is performance testing. Let us understand why we need performance testing. The only concern of a software system is not features and functionality. The response time, reliability, resource, and scalability are also important factors. So, the goal of performance testing is not to find bugs, but to eliminate performance glitches. Performance testing is performed to help the stakeholders with information about the application concerning the application speed, stability, and scalability. Furthermore, performance testing reveals what needs to be improved before the product goes into the market. If there is no performance testing, the software might suffer from issues such as running slow while several users use it simultaneously, inconsistencies across different operating systems, and poor usability. Performance testing determines if the software or application meets speed, scalability, and stability requirements under expected workloads. Applications sent to market with poor performance metrics due to non-consistent or poor performance testing are likely to bring a bad reputation and fail to meet the expected sales goals. Now we know the relevance and need for performance testing. Let's look at the types of performance testing. So there are 6 types of performance testing. Namely, load testing, stress testing, volume testing, capacity testing, reliability testing, and scalability testing. Let's have a look at all the 6 types of testing one after the other. So the first type is load testing. Load testing is a type of performance testing where the application is tested for its performance on normal and peak usage.
An application's performance is checked concerning its response to the user request and its availability to respond consistently within accepted endurance on different user loads. Here, the main consideration is the maximum load the application can hold before the application starts behaving abruptly. Then, another consideration is regarding how much data the database can handle before the system crashes. The second type of performance testing is stress testing. Stress testing is a type in which different ways to break the system are found, that is, how much load a system can sustain. Stress testing has an incremental approach where the load is increased gradually. The test is started with a load for which the application has already been tested. Then, more load is added slowly to stress the system. The point at which we start seeing servers not responding to the request is considered the breaking point. Here, the major considerations are the maximum load to a system can sustain before it breaks down. Then, how is the system broken down? And how will the system be able to recover once it has crashed? We also see in how many ways a system can break and which are the weak nodes that are to be kept in mind while handling the unexpected load. Moving forth, the next type is volume testing. Volume testing is the type where the performance of the system is checked with respect to the volume of the data. To execute a volume test, a huge volume of data is entered into the database. This test can be incremental or steady test. In the incremental test, the volume of the data is increased gradually. Generally, with the application usage, the database size grows, and it is necessary to test the application against a heavy database. If we consider an example, let's say there is a website of college having small amounts of data to store initially. But after 5 to 10 years, the data stored in the database of the website is much more and has become huge. Now comes the fourth type of performance testing, the capacity testing. So capacity testing is a type of testing where the application is checked for its capability to meet the business volumes. Capacity testing is generally done for future prospects. Here, the main concerns are if the application would be able to support the future load, if the environment is capable of standing the upcoming increased load, and what are the additional resources required to make the environment capable enough. Capacity testing helps in determining how many users or transactions of a given web application is capable of supporting and will perform well. During this testing, resources such as processor capacity, network bandwidth, memory usage, disk capacity, etc. are considered and altered to meet the goal. To consider an excellent example of capacity testing, we can see the case of online banking. Moving forward, the next type of testing is the reliability testing. Reliability testing is a type in which the application is verified if the application would be normal again after an abnormal state. It estimates the time that the system would take to return to its normal state to understand the concept. Let's say there is an online trading site that experiences some failure, and because of which the users are not able to buy or sell shares at a certain point of the day. But after a couple of hours, they were able to operate their shares and the application became normal. This is when it can be said that the application is reliable and can recover from its abnormal state. The last type of testing is scalability testing. Scalability testing is a type where the application is determined if it would be able to scale up whenever needed. The need for scaling up comes when there is an increase in user load. Now when we have learned the types of performance testing, we must learn the process of performance testing. So the process of performance testing is divided into 8 parts. That is, requirement gathering, selection of tools, performance test plan, performance test development, performance test modeling, execution of test result analysis, report. Now let's have a look at all of these processes one after the other. The first step in the process is requirement gathering. The requirements are identified and gathered from the clients by the performance team. This includes getting information on the application's architecture, technologies, database used, intended users, functionality, application usage, test requirement, hardware and software requirements, etc. The second step in the process is selection of tools. After the previous step, POC or proof of concept is done with the available tools. The proof of concept is a sort of demonstration of real-time activity, but in a limited sense. The list of available tools depends on the tool's cost, the protocol that the application is using, the technologies used to build the application, the number of users we were simulating for the test, etc. Now, the third step. The third step is the performance test plan. In reference to the above two steps, test planning and designing are conducted. The process of test planning involves information on how the performance test is going to take place, like the test environment, workload, hardware, etc. Moving forth, the fourth step is performance test development. In this step, the use cases for the identified functionalities are created. These use cases are shared with the client for their approval. Once the clients approve the use case, the script development begins. These scripts are validated against several different users and parallel to script creation. The performance team sets up the test environment. The performance team also takes care of metadata through scripts if the client does not take up that activity. So the next step is performance test modeling. Performance load model is created for the test execution. This step aims to validate whether the given performance metrics are achieved during the test or not. Then, the sixth step is execution of tests. The scenario is designed according to the load model in controller or performance center. Initially, the tests are not executed with maximum users that are in the load model. The test execution is done in incremental order. Let's say there are 1000 users. Then the scenario will begin testing from 100, then go to 250, then 350, and so on. It will gradually increase and go up to 1000 users. The next step is the seventh step in our process. That is the test result analysis. The test results are the most important deliverable for the performance tester. This is where we can prove the return on investment and productivity that a performance testing effort can provide. What makes the result analysis process more effective is that we must have a unique and meaningful name for every test result, which will help us understand the test purpose. In the test summary, certain things must be included, like the reason for failure, how the performance of the application changes regarding the previous runs. It is also a good practice to make a result summary after each test run so that the analysis results are not compiled every single time the results are referred. Then the final and the last step in performance testing process is the report. The test results should be simplified so that conclusion is clearer and should not create any derivation. The development team needs more information on analysis, comparison of results, and details of how the results were obtained. The test report is considered to be good if it's brief, descriptive, and to the point. Now that we know the performance testing, the next important topic to discuss is the understanding of performance testing metrics. The first is processor usage, which refers to the amount of time the processor spends executing the non-idle threads. Second metric is memory usage. Memory use is the amount of physical memory available to the processor on a computer system. The third metric is disk time, which is the amount of time the disk is busy in executing read or write request. The fourth metric is the bandwidth, that shows the bits per second used by a network interface. Moving forth, the next metric is the private bytes. It is the number of bytes a process has allocated that can be shared amongst the other processes. These are used to measure memory leaks and usage. Then comes the committed memory. This is the amount of virtual memory used. Then the next metric we have is the response time. It is the time between when the user enters a request to time to the first character of the response is received. Next metric is the throughput. It is the rate at which a computer or a network receives requests per second. Moving forth, the next metric is the hit ratios. The hit ratios are concerned with the number of SQL statements that are handled by cached data instead of expensive input-output operations. And the last metric in our list is the top waits. These are monitored to determine what wait times can be cut down to make the data retrieval faster from memory. Apart from this, some metrics like the rollback segment, garbage collection, thread counts, hits per second, CPU interruption per second, disk queue length, etc. Now, when we know almost everything that is needed regarding performance testing, it is very important to know the tools that make performance testing possible. Here are the top 5 performance testing tools in the market today. The first tool we have is the Load Runner or HP Load Runner. As the name suggests, the Load Runner is great when it comes to handling a large amount of users for testing. The second tool in our list is WebLoad. WebLoad is one of the best testing tools for stress and load testing. The next tool in our list is Load UI. Load UI is a great testing tool to map the scalability and speed of the target product. The fourth tool in our list is Neoload. It is one of the fastest testing tools with a speed of around 10 times the traditional testing tools that are integrated seamlessly into our existing software with a wide array of tests. The last tool in our list is the Apache Jmeter. Apache Jmeter is one of the best and most used testing tools in the market right now. It is highly capable of creating a large number of virtual users working on web server. Moving forth, we shall talk about Jmeter and understand why Jmeter is preferred over all the other performance testing tools in the market. So moving forth, let's see what Jmeter is. Jmeter or Apache Jmeter is an open source software that is 100% pure Java application. The application is designed to load or test functional behavior and measure performance. Jmeter is originally designed for testing web applications but has since expanded to other test functions. To understand the concept of Jmeter, let us assume that someday your team leads tell you to perform performance testing on some website like Facebook or Google.com for 100 users. What would be the first thing comes to your mind? Do you think it's practically possible to arrange 100 people with computers and access to internet and accessing the same website? Now, just imagine the infrastructure requirement when this testing has to be done for 10,000 users. This is when a need for software like Jmeter arises. So what Jmeter does is, it actually simulates. It will simulate the real user's behavior and perform load tests on server, group of servers, network, or object. Now, let's have a look at some reasons why Jmeter is used for load testing. We have divided these reasons into 6 parts. The first one is it's free of cost. Second one is performance testing of applications. Next one, platform independent. The fourth one is customizable. Fifth is recording and playback. And finally, sixth is the community support. Let's see all of these one after the other. The first reason we have is free of cost. One of the main deciding factors in any software is its cost. Normally, a software can range from high as 6 to 7 figures per license. Here, Jmeter is free of cost, very intuitive, and has all the possibilities you need to automate your work. Then the second reason is performance testing of applications. The application is used to perform performance testing on different types of applications like web applications, web services, LDAP, database, and shell scripts. Jmeter can conduct load and performance tests for many different servers and server types. Web, HTTP and HTTPS, database via JDBC, LDAP, and JMS. The third reason is platform independence. Jmeter is written and developed using Java to run on any environment or workstation that accepts Java Virtual Machine, for example, Windows, Linux, Mac, etc. The next reason we have is that Jmeter is customizable. Since Jmeter is an open source application, it enables developers to customize whenever needed. Jmeter has a comprehensive and user-friendly graphical user interface. Parameters are easy to define and understand. Scripting is simpler and clearer, and adding and defining elements is more intuitive. Also, one screen shows everything you need: the script, the scenario, and the analysis. These samplers are highly customizable when determining which request to be sent to the host. However, samplers don't enable full control of test actions. Moving forth, the following reason is recording and playback. The application provides record and playback options enabled with the drag and drop feature, making the application faster and easier. The next and the last reason on our list is incredible community support. Jmeter is an open source tool with a brilliant community that keeps adding features and supports users who run into issues and problems. This ensures new users always have someone to answer their questions, and long-time users can improve their abilities on Jmeter. Also, having an open source tool ensures that it keeps getting better and is always in line with users' needs and requirements. Finally, let's have a look into the demo that shows the working of Jmeter. So the first step is we shall go to the Apache Jmeter folder. In that folder, go inside the bin folder and select the jmeter.bat file. Double click on this file. This might take a while, and then the Jmeter window will open on the screen. The home window is divided into two sections. On the left side, all the test plan elements are added, and on the right side, all the configurations of that element are added. As we are on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will be using to perform this test will be stored. All the requests, listeners, and everything will be stored here. I have renamed this test plan as Performance Testing. Now the first step is to add thread group. Right-click on the performance testing, go to Add, then go to Thread or Users, and select Thread Group. Let's name this as Perform. Here, the thread group refers to the used or created users or needed to run this test. It has several different options like the action to be taken after there is an error. You can choose it the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the users hits. Third, there is a loop count where you can choose how many times the test will run for the number of users. You can also choose the test to run infinite times. There is also a scheduler here to help you schedule the start time and the test end time. Let's make the number of threads to be 2 and let's make the loop count to be 100. The next step is to add an HTTP request. For that, right-click on the thread group, go to Add option and go to the Sampler option. In the menu that appears, select the HTTP request option. Here on the screen, there is a server name or IP box. We have to give the server name or the IP in that. Let's pick up a website and place the link in the box. We shall use the Simplilearn's website here. Go to Simplilearn's website and copy the URL from here. Then come back to the Jmeter window and paste it onto the server name box. Keep in mind, we don't need to give the HTTP or HTTPS since these are protocols which will come in the other box and they will be automatically taken in the HTTP request case. Then in the path dialog box, we will leave the / there since we have to access the root page. And let's rename this HTTP request as simple. Now, to get results, we shall add listeners. Listeners are something that are used to provide the outputs of a load test. There are different types of listeners present in Jmeter and many may be added using plugins. We will use 3 different listeners here to have an idea about the representation that the Jmeter provides. For that, right click on the thread group, then go to the Add, select listener option and go to the View Results in Tree option. Then again, right click on the listener option and choose Graph Results. And for the third listener, again right click and select the View Results in the Table option. Now it's time to run the test. For running the test, there are 3 simple ways. First, you can simply click on the green button here to run. Second is you can go to the run option and choose the run the test. And the third way, you can right click on the first Jmeter and choose to run. Let's simply choose the green button and run the test. First, we will have to save this Jmeter test and then we shall go on to check the results of the test. Here in the View Results tree, we can see the test being run. The same in the case of Graph Results. We can see the throughput option, then we can also see the time the test has been executing. Since we had put the threads to 2 and the loop count to 100, so the test will run for a while. We can check the view results in the table. We can see different performance testing metrics on the screen. You can see the thread name, label, sample time per second, bytes, sort bytes, and the latency. And in the tree option, when we click on the test, we can see a lot of information appearing on the screen. These are again several performance testing metrics. And in the graph results, we can see the graph coming up on the screen now, which represents the test taking place with respect to the IP address, thread, and loop counts. So what Jmeter exactly does is creates a request and sends it to the server. Once it receives the server's response, it collects them and visualizes those details in a chart or graph. After that, it processes the server's response and finally it generates the test results in several formats such as text, XML, JSON, so that the tester can analyze the data. Let's get started with what is load testing. Load testing is a type of performance testing that determines an application's behavior when a large number of users access the application together. Here, performance testing is a software testing process used to test the speed, response time, stability, and reliability of the software application under a particular workload. The testing determines a system's performance according to real-life conditions. To give you a better idea, let's say you have a printer. So you want to test a printer by transferring large number of documents for printing. Or test a mail server with thousands of concurrent users, or to test a word processor by making a change in a large volume of data. This helps to know whether the existing infrastructure is capable of running the application or not. Load testing checks how much load can a system handle. The testing identifies the limitations due to hardware like CPU maximization, network bottleneck, memory limitation, etc. And it also identifies the issues in software configuration such as web server, application server, database server, etc. It helps to identify the maximum operating capability of an application and checks the performance of the application under different load conditions of system components and database components. Load testing is conducted to determine the number of concurrent users that an application can support without performance deterioration. The response time of each transaction of an application and the network delay between the client request and server response are also checked. Load testing proves itself very significant when it comes to determining user demands and satisfaction. Several tools make load testing possible, such as Apache Jmeter, WebLoad, LoadUI, LoadRunner, NeoLoad, LoadNinja, etc. Here in this session, we shall be using Jmeter for load testing. So Jmeter or Apache Jmeter is open source software that is 100% pure Java application. The application is designed to load or test functional behavior and measure performance. Performance testing means testing a web application against heavy load, multiple and concurrent user traffic. It was originally designed for testing web applications but has since expanded to other test functions. To simplify, let us assume that someday your team leads tell you to perform performance testing for some websites like yahoo.com or google.com for 100 users. What would be the first thing that comes to your mind? Do you think it's practically possible to arrange 100 people with 100 computers and access the internet and accessing the same website? Now, just imagine the infrastructure requirement when this testing has to be done for 1,000 or 10,000 users. This is when we need a software like Jmeter. So what Jmeter does is it simulates. It will simulate real user behaviors and perform load testing on a server, group of servers, network, or object. Next, let's have a look at some reasons why Jmeter is used for load testing. We have divided these reasons into 6 parts. It is free of cost, performance testing of applications, platform independent, customizable, recording and playback, and community support. Now, let's see all of these one after the other. The first one, free of cost. One of the main deciding factors in any software is its cost. Normally, a software can range from high as 6 to 7 figures per license. Here, Jmeter is free of cost, very intuitive, and has all the possibilities you need to automate your work. The next one is performance testing of applications. The application is used to perform performance testing on different applications like web applications, web servers, LDAP, database, and shell scripts. Jmeter can conduct load and performance tests for many different server types like web, HTTP, and HTTPS, database via JDBC, LDAP, and JMS. The third important reason is its platform-independent nature. Jmeter is written and developed using Java programming language to run on any environment or workstation that accepts a Java virtual machine, for example, Windows, Linux, Mac, etc. The next reason we have is Jmeter is highly customizable. Since Jmeter is an open source application, it enables developers to customize it whenever needed. Jmeter has a comprehensive and user-friendly graphical user interface. Parameters are easy to define and understand, scripting is simpler and cleaner, and adding and defining elements is more intuitive. Also, one screen shows you everything you need: the script, the scenario, and the analysis. The samplers are highly customizable when determining which request is to be sent to a host. However, samplers don't enable full control of test actions. Moving forth, the following reason is recording and playback. The application provides record and playback options enabled with the drag and drop features, making the application faster and easier. The next and the last reason in our list is incredible community support. Jmeter is an open source tool with a brilliant community that keeps adding features and supports users who run into issues and problems. This ensures new users always have someone to answer their questions, and long-time users can improve their abilities on Jmeter. Also, having an open source tool ensures it keeps getting better and always in line with users' needs and requirements. Now, after we know about Jmeter and the reasons to use Jmeter, let's understand the process to perform load testing with a hands-on demo. The only thing that is kept in mind before this demo is we must have a fully functional Jmeter on our system, and by now we know that Jmeter can be used in any operating system like Linux, Windows, Mac OS, and Ubuntu. In this demo, we shall look into both graphical user and non-graphical user interface mode of load testing. So the first step is we shall go to the Apache Jmeter folder. In that folder, go inside the bin folder and select the jmeter.bat file. Double click on this file, this might take a while, and then the Jmeter window will open on the screen. The home window is divided into two sections. On the left side, the elements of the test plan are added, and on the right side, all the configurations of the element that are added. As we are on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, the listeners, and everything will be stored here. So the first step is to add listeners. For that, go to test plan, right click on the test plan, go to add, then go to threads, users, and select a thread group. The test group refers to the users that are used or created or needed to run this test. It has several different options, like the action to be taken after there is an error. You can choose it the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the users hits. Then the third one, there is a loop count where you can choose how many times the test will run for the number of users. You can also choose the test to run infinite times. There is also a scheduler here to help you schedule the start time and the test end time. For now, let's leave everything to be only one. The next step is to add the HTTP request. For that, right click on the thread group and go to the option and go to the sampler option and go to the HTTP request option. Here on the screen, there is a server name or IP box. We have to give the server name or the IP in that. Let's pick a website and place the link in that box. We shall use the Simplilearn's website here. Go to Simplilearn's website and copy the URL from there. Now we have copied the Simplilearn's URL. Now let's come back to the Jmeter window and paste it in the server name box. Keep in mind that we don't need to give up the HTTP or HTTPS, since these are protocols which will come in the other box and they will be automatically taken in the HTTP request case. So this is what I was talking about. Now let's rename this name as Simply. Moving forth, let's create one more HTTP request. For that, again, right click on the thread group, select samplers and select HTTP requests and go to Simplilearn's website again, and there we have the resource link. Go to that link and copy the URL, then place that URL in the server or IP address box. We shall remove the HTTP from that link and add from the end. Cut the resource part and paste it in the path box there. Here we will rename the HTTP request as resources. Moving forward, to increase a load a little bit more, we shall use one more HTTP. So this time we shall add one more HTTP request. Again, right click on the threads group, go to the samplers option and select the HTTP request option again. To add one more link to the server and IP address, go to Simplilearn's website, go to the corporate training link. Now copy the URL and go back to the Jmeter window and paste that URL in the IP box. Now cut the corporate training part from the link and paste it to the other path box. We shall again rename this HTTP request box as corporate. Now let's save this file. In the save dialog box, let's name it as loadtesting.jmx. Now, to get the results, we shall add listeners. Listeners are something that is used to provide the outputs of the load test. There are different types of listeners present in Jmeter, and many may be added using plugins. The listener we will use here is the tree, as it is comparatively easy to interpret. For that, right click on the thread group, then go to add, select listener option, and go for the view results in tree option. Now it's time to run the test and check the load. For running the test, there are three simple ways. First, you can simply click on the green button here to run. Second is you can go to the run option and choose the run test. And the third is the way you can right click on first Jmeter and then choose run. Let's simply choose the green button and run the test. After we run the test, we shall go to the check the results of the test in the view results in tree section. We can see the green symbol that states the test has successfully completed. Since we had left all the values to be 1 in the beginning, that's why there is just one test for each HTTP request. Now let's increase the load and let's change some numbers. Let's make the number of threads to be 10, ramp up the periods to be 2, and the loop count to be 10. Now let's run the test again with the green button. After running the test, we shall see the results in the tree and see the testing being performed. Since we have increased the number of users and ramp up the periods and the loop count, we can see the test being performed accordingly. Since the loop count now was 10 for each user, the test will run 10 times. So here on the screen we can see the time taken and the number of tests being performed on the status of each hit onto the website. This is how you perform load testing in graphical user mode. Now perform the same test in non-graphical user mode. We shall remove the listener, so let's remove the view results in tree. After this, we will go to the command prompt. Then in the command prompt, we shall put the bin folder path in the Apache Jmeter folder. Let's go to the bin folder and copy the location from here. Now paste the path in the command prompt and execute it. Once that is done, the next step is to put the command prompt for Jmeter load testing. This command has got three parts. The first part is the -n, -t, and -l. Here the -n represents the non-graphical user interface mode. -t is used to specify the location of the test script. -l is used to specify the location of our output result. Now go to the location where our JMX file is stored. Let's search for the load testing.jmx file. Copy the path and paste it in the command prompt -t. In the link that we paste towards the end, make sure that you add the name of the file with .gmx. Now go back to the folder and make a .csv file, make an Excel spreadsheet and rename it with .csv extension. Now copy this path and go back to the command prompt and paste it after the -l. In the path, don't forget to add the name of the CSV file towards the end. Then execute the command and wait for the command to end. After the command is successfully run, you can see that the tree is successfully created, and towards the end of that execution, you can see that the message is the end of the run. Now you can go back to the folder and open the load testing.csv file. In that file, you can see the entire test result has been generated. This shows that the command has been successfully executed and the load testing is successful in the non-graphical mode without any errors. This is what we had in this demo. We saw the load testing in graphical user interface and non-graphical user interface mode. To have a better picture, we use Dashboards. Dashboards include several graphs that explain the working of the website link we use in the HTTP request. The dashboard generator is a modular extension of Jmeter. Its default behavior is to read and process samples from a CSV file to generate HTML files. It generates the report and at the end of the load test or on demand. The dashboard reports provide metrics like the APDEX or Application Performance Index. The dashboard also provides a statistics table, response time over time, response times percentiles over time, active threads over time, and response times in percentiles. We shall learn about dashboards and more in the forthcoming videos. In this video, we learned how critical is load testing in the software testing process and how it ensures high user satisfaction. A successful load testing will help to release high quality software.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let's get started with what an API is. We often come across this term while reading any technical blog or magazine. An API or Application Programming Interface is a programming code that enables data transmission between one software product and another. It is an intermediary software allowing two applications to communicate with each other. To understand API even better, let's take an example. For example, you're booking a flight. For that, you will begin with searching flights online concerning your destination, departure, return dates, and many more filters. To make all these choices, you interact with the airline's website and access their database and see if there are any seats available on those dates and what the costs might be. While you're doing all this, from the time to begin to the time you finish booking your tickets, you're doing that with the help of an API. To simplify it even more, it can be said that whenever we use an application on our mobile phone, the application connects to the internet and sends data to the server. The server then retrieves the data, interprets it, performs necessary actions, and sends it back to our phone. The application then interprets the data and presents the information we wanted in a readable way. This is what an API is. So that means each time we use an application like Facebook, send an instant image, check weather on our phone, or make some specific choices while online shopping, we use an API. Now when we have a good idea about what an API is, let's look at another major thing before going on to the hands-on demo. That is why we use Jmeter for API testing. Apache Jmeter is an open source software and it is used to simulate loads of various scenarios and output performance data in several ways, including CSV and XML files and graphs. We know that the Apache Jmeter is 100% pure Java application, so it is available on every OS that supports Java 6 or later. Some of these specific reasons what makes Jmeter a perfect fit for API testing are: Jmeter enables fast API testing. It performs quick scope tests and enables load and stress testing. Then, as we know, it is an open source tool and supports load testing and stress testing. It has a lot of plugins and extensions. Jmeter can be used across several platforms and can use various programming languages. Now, we know about API basics and why we use Jmeter for its testing. It is the right time to see the process of API testing in Jmeter. To download Jmeter, you can go to the Apache Jmeter website and download the file. To know the entire downloading process and installing Jmeter, you can check our Jmeter download and installation video in our Jmeter playlist. Moving on, I have my Jmeter installed. I will go to the Apache Jmeter folder, go into the bin folder and open the batch file. This might take a while and then the Jmeter window will open on the screen. The home window is divided into two sections. On the left side, all the elements of the test plan are added, and on the right side, all the configurations of that element are added. As we are on the test plan element, we can see the configurations of the same. Here, the test plan is like a place or a container where all the elements we will use to perform this test will be stored. All the requests, listeners, and everything will be stored here. So moving forward, right click on the first Jmeter here and select the add option. Then in this option, select the threads option and then threads group. The thread group refers to the users that are used or created or needed to run this test. It has several different options, like the action to be taken after there is an error, or you can choose it the way you want. Then there is this number of threads where you can choose the number of users you want. Then there is a ramp up period in seconds option that states the time gap between the user hits. Third, there is a loop count where you can choose how many times the test will run for the number of users. You can also choose the test to run in finite times. There is also a scheduler here to help you schedule the time for starting the test and the time for ending the test. For now, let's leave everything to be one only. Now, for some sample APIs, go to your browser and search for some sample REST API for testing. In this, we will go to the first link, that is reqres.in or requestresponse.in. We will create and run get, post, put and delete REST API request in Jmeter in the demo. Here in this link, we have all get, post, put, delete APIs. So we shall choose the first link here, list users. Here we have the link request. Open this link in the new tab. Then we have got the URL for this API. Copy this URL and go to the Jmeter window. Then in the Jmeter window, right click thread group and go to add. In the box that appears, select samplers. You can see all types of requests that Jmeter can work on. We shall choose the HTTP request. Here, you will have to give the address to some home pages or websites. Here, in the server name or IP box, we have to give the server name or the IP. So here, we shall paste the get API request URL. In the protocol box, we shall put the HTTPS. If in the URL the protocol would have been HTTP, then we would have left this box empty. In the URL, we shall put the URL link. Remember that we do not put any slashes here and that anything after the URL would be put in the path. So we shall remove the path from the URL and put it in the path box. Then we shall take part from the question mark and use it to give parameters. Since it is the get API, we will have to give parameters. We will add the name in the parameters and give the name as page and value as 2. In this HTTP request dropdown, we can see all the different types of HTTP requests that Jmeter accepts. For now, we shall leave it to be get since we are using the get API. And also, let's name this HTTP request as get API. Now, when our HTTP request is ready, we shall perform the test on it. To determine what the results of the test will be, we need to add some more test elements. We shall again right-click on the thread group, go to the listener options, then in the box, we can check the different types of reports that Jmeter provides us. For now, we shall select 2 of these. Let's choose View Results Tree and the View Results in the table. Now, save the test. I will save the test with the name API testing. And finally, let's run it. For running the test, there are 3 simple ways. First, you can simply click the green button on the run. Second, you can go to this run option and choose to run the test. And the third way is you can right click on the first Jmeter and choose to run. Let's simply choose the green button and run the test. After we run the test, we shall go to check the result of the test. Let's go to the view results tree. Here we can see the green status that shows the test was successful, and the view results in a table. We can see again the status is green. Since we had put the number of threads and loop to be 1, there is just one entry in both the results. Now let's try one more thing. We shall go to the thread group and change the number of threads to be 10 and run the test again. After running the test, we shall see the results in the table and see the testing being performed. And same happens in the case of view results in table. Now in the view results tree, we can click on a request and see different information. Here we can see the sample start, load time, latency error, etc. Same in the view results in table. You can see all such information in a tabular format. You can also see the response data here. This is the same data as it was there when we copied the URL from the browser. You can furthermore check the response headers and the request that was placed. Now we are done with the GET API request. Let's add the second request, that is the POST request. Again, add a HTTP request by going to the sampler in the thread group. Then come back to the browser window and click on the POST API option. Then open the request URL in the new window. Then go to this window, copy the URL and come back to the Jmeter window. First, let's rename this HTTP request as POST API. Then let's paste the URL in the server name or IP box. Again, let's put HTTP in the protocol box, address in the server or IP address box, and path in the path box. And in this HTTP request drop-down, select the POST option this time. Then let's go to the parameter part. Here, select the body data option, and we shall have to add body now. So go back to the browser window and copy the body from here. Come back to the Jmeter window and paste the body here. Here you can check some advanced settings also in case you need them. For now, since this is just a demo, we shall keep it really simple. So let's run this. We shall go to our two listeners and clear the previous output. Then we shall save the test and run it. Now you can see the two tests are here. Since the thread count is 1, let's make the thread count to be 10 again. Let's see what happens. Now when I run the test, I can see the test running a required number of times, that is 20 times. Again, I can see information about different requests that include different parameters like latency, errors, etc. Now let's move on to our third API request, that is the PUT request. Go back to the browser and click on PUT request. Open the request in the new tab. Copy the URL and come back to the Jmeter window. Make a new HTTP request by going to the sampler in the thread group. First, let's rename this HTTP request as PUT API. Then let's paste the URL in the server name or IP box. Again, let's put HTTP in the protocol box. address the server or IP address box and path in the path box. And in the HTTP request dropdown, select the put option this time. Here also we shall have to add body data. So go back to the browser window and copy the body from here. Coming back to Jmeter window, select the body data option and we shall have to add body now and paste the body here. We shall go to our two listeners and clear the previous output, make the thread count to be 1 and then we shall save the test and run it. Now you can see the 3 tests here. Since the thread count is 1, here by clicking on the API request, we can check a lot of data like the response, body and response headers. And same in the case of view results in the table. You can see the data in a tabular format. Let's make the thread count to be 10 and again see what happens. Now when I run the test, I can see the test running a required number of times. And here I can see information about different requests. Now let us add our last API request, that is the delete request. Go back to the browser and click on the delete request. Open the request in the new tab, copy the URL and come back to the Jmeter window. Make a new HTTP request by going to the sampler in the thread group. First, let's rename this HTTP request as delete API. Then, let's paste the URL in the server name or IP box. Again, let's put HTTP in the protocol box, address in the server or IP address box, and path in the path box. And in this HTTP request dropdown, select the delete option this time. Here, there is nothing to be added in the parameters section. So, let's go to the two listeners and clear what all is there. Then save this test and run it. Since we did not make the number of threads 1 this time, we can see the test running n number of times. We can see the information of any API request by just clicking on it. Let's get started with what is script recording. Record testing in Jmeter helps testers to record and run their activity against test targets. It is a type of automated testing, but for multiple users, the test script is designed to record such scenarios. The proxy server allows Jmeter to watch and record user activity while browsing web applications with a normal web browser. When we talk about proxy, it is a component that is present between you and the remote server. Let us say that you want to record web browser interactions when Jmeter starts acting like a proxy. This is when Jmeter script recording is used. Script recording is one of the advanced and impressive ways to figure out and eliminate the complexity of browser interactions in software testing. Now when we know what script recording is and how it is relevant, let's look into how to do it in Jmeter. But before that, let's check the prerequisites of script recording in Jmeter. There are 3 major prerequisites. First is having Jmeter installed in your system. The second requirement is having Java installed in your system. The third and final requirement is having Mozilla Firefox in your system. Now, let us have a look at the hands-on demo of how to perform script recording in Jmeter. So, the first step is we shall go to the Apache Jmeter folder. In that folder, we will go into bin folder and then select the jmeter.bat folder. Let us double click on that. This might take a while. And then the Jmeter window will open on the screen. The home window is divided into 2 sections. On the left side, all the test plan elements are added. And on the right side, all the configurations of the elements are added. As we are on the test plan element, we can see the configurations of the same. Here, you can think of the test plan like a place or a container where all the elements we will be using to perform this test will be stored. All the requests, all the listeners, and everything will be stored here. Now, the first step is to add thread group. So for that, right click on the thread group. select Add, and from Add, go to Threads or Users, and in that, select Thread Group. Here, the thread group refers to the users. It has several different options, like the action to be taken after there is an error. You can choose it the way you want. Then, there is this number of threads where you can choose the number of users you want. Then, there is a ramp up period and second option that states the time gap between the user hits. Third, there is a loop count where you can choose how many number of times the test will run for a number of users. You can also choose the test to run for infinite times. There is also a scheduler here to help you schedule the start time and the test's end time. The next step is to add an HTTP request. For that, right-click on the thread group, go to the Add option, and now go to the Sampler option. Select the HTTP request option. Here, there is a server name or IP box. We have to give the server name or IP in that. Let us pick a website and place the link in the box. We shall use the Simplilearn's website here. Go to Simplilearn's website and copy the URL from here. Then come back to the Jmeter window and paste it in the server name box. Keep in mind that we don't need to give HTTP or HTTPS since these are protocols that will come in the other box and they will be automatically taken in the HTTP request case. Then in the path dialog box, we will leave a / there since we have to access the root page. Now the next step is to add the HTTP test script recorder. For that, right-click on the test plan, then go to Non-Test Elements and select the HTTP Test Script Recorder option. The window on the screen shows several options. Here, we can see the Start option to begin the test. Then, there is a box that has the port number. You can make this number whatever you like. I'll put this number as 1234 for now. Then, let's go back to the Simplilearn's website and go to the Resources page. Then, come back to the Jmeter's window and rename the recording controller as Resources. Now, let us add another recording controller so that Jmeter works like a proxy with the help of HTTPS test script recorder. Then again, go back to the resources page that we just opened and scroll down a little bit. Here, we can see several technologies and several other links. In those links, you can select any one of the links. I will select digital marketing here. Then, go back to the Jmeter window and rename the recording controller as digital marketing. Then finally, let's add a recording controller for the home page and rename it as Simplilearn's home page. So now we can see that we have a thread group here. Then there is a HTTP request where we have Simplilearn website in the server name. Then there are 3 recording controllers, one for the resources, the second for digital marketing, and a third one for home page. And last we have a HTTP test script recorder. Here, I will rearrange the recording controllers in sequence, putting the Simplilearn's homepage controller on the top and then placing the resources, finally digital marketing recording controller. Now, let us open Mozilla Firefox in our system. Go to the general option here and scroll down to the network settings. In the network settings option, select settings. In the window that appears, select the manual proxy configuration. Here, we shall put the port number. For now, I will put the port number as 1234 in this box. Here in the HTTP proxy, we have localhost and we have selected to use this proxy for FTP and HTTPS and then click on OK. Now go back to the Apache Jmeter folder and now we shall use this Apache Jmeter temporary root CA file, which is a security certificate file. So coming back to the Mozilla Firefox window, go to the Options tab and in this tab, I will type certificates and here we shall select view certificates. In the window that opens, let us import the security certificate from Jmeter folder. Here we shall select these 2 boxes so that the proxy server can access the website that we shall enter here in the browser and then select OK. Coming back to the Jmeter window, let us add some listeners to get the results. Listeners are something that are used to provide the outputs of a test. There are different types of listeners present in Jmeter, and many may be added using plugins. For adding listeners, right-click on HTTP Test Script Recorder. For adding listeners, right-click on the HTTP Test Script Recorder. Then go to Add option and then go to Listeners option and then Add View Results tree. Now, let us add one more listener in the same way. We shall add View Results in tree. Now, in the HTTP Test Script Recorder in the Target Controller option, save the target controller. Here in the drop-down, select the Simplilearn homepage option as we will begin the script recording for the homepage. Finally, let's start the test by clicking here. Click on OK. Now, go back to the Mozilla browser and here, let us open the Simplilearn's homepage. Now, come back to the Jmeter window, go to the homepage recording controller. You can see the homepage controller has started. As you can see, the homepage controller has started recording the scripts that are being performed. These are the tasks that are performed on the client side to the server side. Now, we can check both the listeners that we have put to see what all functions are working fine and what all are not. All the tasks from the time that we have entered to simplilearn.com in our browser are recorded in this homepage controller. To take the test further, go to the test script recorder and stop the test. Now here in the target controller, select the second controller, that is the resources controller. Now start the test again. Select OK. Go to Simplilearn's website, select resources. After opening the resources link, go back to the Jmeter window. And now in the resources controller, you can see what all events are recorded from the client side to the server side. Once we click on the resources link, now again in the tool listeners, you can check all the scripts and tests are successful or have failed. Now for our last recording controller, go back to the test script recorder and stop the test. Now here in the target controller, select the third option, that is the digital marketing. Now here in the target controller, select the third option, that is digital marketing. Start the test and select OK. Now get back to the Mozilla Firefox window, go to resources, go to digital marketing. After digital marketing link has opened, go back to the Jmeter window. And now in the digital marketing controller, you can see what all events are recorded from the client side to the server side. Once we click on that link, I guess this is taking a while. You can see all steps coming under the recording controller, and then you can also see the two listeners. Some of the tests are being successful and some are not. We can sum this entire process as a way of communicating between the server and the client with a proxy server help. In this case, the proxy server is our Jmeter. That is why it was able to record all the steps that are happening while we were performing any task. This is how we can perform the Jmeter script testing in few simple steps. Now, when you are done with the proxy server, do not forget to go back to your browser and change your network settings back to normal. That is, go to these settings, select Use System Proxy Settings, and that's how it is done.
And with that, we have come to an end of day 3. So far, we have learned the DevOps testing. On the day 4 of DevOps Learning Week, we will reveal the next stage where you get to master the DevOps and cloud. So stay tuned and don't miss out on it. Thanks for watching and don't forget to subscribe and stay tuned for more from Simplilearn.